think in the paucity of time, we will start. I'll take a couple of minutes, then Steve and Tanno, so by the time the other people come, our first presenter will be on stage. So good morning, everyone. Can be a little louder. Good morning, everyone. Right. Welcome to this first edition of the Zak World of Façades conference here in Birmingham. This is part of our global series of events. This is the 119th global edition in the past 10 years. This is our I've lost account, 9th UK edition, if I'm not mistaken. We've been here in the UK since 2017. We've done a couple of events in London, a couple of them in Manchester, Dublin, and now another regional one here with Birmingham, with a focus on projects in the city, in and around the city. So this is also one of the faster growing cities in the UK. So we thought it was advisable to do an event over here. There's lots happening in the world of facades. So we thought we'll have an interesting agenda today. Luckily, for those who are from London, this event is not only about carbon. There's a lot about fire. There's a lot about other facade engineering topics also. Otherwise, seemingly any London event takes the direction of low carbon or embodied carbon. We do have that as pockets being discussed today, but it's not the whole event. So I hope you'll enjoy today's event. I'll quickly introduce the event. Is the clicker here? Is the clicker here? Shelja. Is the clicker? Clicker is missing. Okay, it's here. Sorry, it's here. Sorry, my bad. So, just to give a quick brief of the Zak World of Façades conference series, we've been doing this since 2012. We've completed 118 editions. We've got events all across the globe, from New Zealand up until Canada. Every event's different. Every event has its own challenges. So we've been very grateful to have hosted some of the creative minds and partners for the conferences across the globe. And I'd like to start off with our partners for today's event, thanking them, starting off with our presenting partner. So presenting partner for this event is Siderise. Siderise are a British manufacturer of cavity barriers and pacifier solutions for ventilated facades, for curtain wall. So they are our presenting partner for this event. Our powered by partners are Schüco. Schüco is a global leader in aluminium door, window, curtain wall systems. They've been the backbone of success of the Zak World of Façades conference series globally. I'd like to start with our associate partner, AkzoNobel. So this is their powder coating division of Interpon, participating here with us. So AkzoNobel also are a leading manufacturer of powder coating solutions for doors, windows, and facades. Axalta is another coating manufacturer. So they are also having powder coating solutions. Cosentino is a Spanish manufacturer. They have an interesting cladding material called Decton, which is now gaining a lot of popularity. FSS is a Portuguese manufacturer of weatherproofing solutions, membranes, tapes, and other gaskets and other solutions for facades. Curare is the mother company of the laminated glass interlayer brands Trocifol and Sentry Glass. They are also a global partner and supporter of the events right from the inception. NBK is a Hunter Douglas company. They are a terracotta manufacturer out of Germany. Obex, who happen to be our lanyard partners and our networking reception partners post the event, are a leading manufacturer of weatherproofing solutions, British manufacturer of weatherproofing solutions. A Proctor Group, another British manufacturer, weatherproofing solutions, membranes, vapor barriers, etc. Seems like it's an interesting product. We have lots of partners in this segment. Q Railing, German manufacturer of modular railing and balcony systems. And our next event, so we're doing Vancouver right next week, San Francisco after that, Chennai after that, Egypt, Milan, Washington, D.C., Hyderabad, so the list goes on, Hong Kong, Shanghai, London's at the 8th of November, again, the Hilton on Park Lane. We've got Frankfurt, we've got Norway, and then a few more events in between, but I've decided to skip them. And also I'd like to take a couple of minutes to request you to nominate yourself for the Society of Facade Engineering's Facade 2023 Awards. It's going to take place after the end of the completion of the Zak World of Façades event in London this year. So we've got some new categories this year, and these are the 6 categories which they have, which you can nominate yourself or your colleagues or anyone else you feel relevant for. So I think they're entries close in a month's time. So you've got 4 weeks to go to fill up your nominations. We've had a good collaboration with them last time around when we did this in London. So that's the link, cipc.org/facade awards. Those who are interested to nominate yourselves, you can get yourself nominated for this. That's it from me. I'd like to call upon today's event host and convener, Stephen Tanno. He's the Director of Pre-Construction Services at Schüco International KG. So he'll be leading you and taking you forward from here. Thank you.
Good morning, everybody, and welcome. I hope you can hear me okay. Good. My name is Stephen Tanno. I'm from Schüco International. On behalf of everybody at Schüco and at Zak, I welcome you to the first edition of Zak World of Façades in Birmingham. I'm not really sure why it's taken us so long to get to Birmingham, but at least we're here, and it's an absolute pleasure to be with you and to host you today. Okay, so the locals amongst you will immediately recognize this as the emblem or the flag of Birmingham. A very powerful looking symbol, and it's a very powerful city. The foundations of the modern industrial society probably started here. At one time, Birmingham was referred to as the first manufacturing town in the world. Birmingham was also the home of British engineering during the Industrial Revolution years in the 17th and 18th centuries. And this is proven because there are three times more patents that existed in Birmingham in that period than any other town or city in the United Kingdom. And this tradition continued into the 19th and 20th centuries, with innovations such as the cavity magnetron, which is the key component of modern radar and microwave, invented in Birmingham in 1940 by John Randall and Henry Boot. We also have the concept of the first modern jet engine, invented also here around the same period by Frank Whittle. The idea of nuclear fission was first theorized here in Birmingham. All these British innovations and many more were taken by the Tizard mission to the United States in 1940 during the Battle of Britain, and were later described by American historians as the most valuable cargo ever brought to our shores. The sole purpose of the Tizard mission was to share technical and scientific secrets with the objective of securing US assistance in maintaining the war effort and obtaining industrial resources to exploit the military potential of these technologies. Britain itself could not exploit them at the time due to demands of other war effort. This gives you an idea of the caliber of work that was going on in Birmingham, or has been going on in Birmingham for hundreds of years. Birmingham played a pivotal role in the Second World War. To that end, it was hardly surprising that it became a key target for the Luftwaffe bombing during the Second World War. While we are talking about war, I just want to take a minute to reflect on what's going on, because we are still having war in Europe today. If you're able to stand, I'd like you to stand for a minute, please, and join me in a minute's silence and reflection as we stand in solidarity with the people of Ukraine as they go through the misery of war. So we send a collective message of solidarity from Birmingham to Kiev, and we pray for a resolution to this terrible war and this suffering. Thank you for standing. Please take a seat. So back to today's event, and some of you may be attending Zak for the first time, and you've not experienced what the event is about. But before I talk about that, I just want to ask you if any of you watched the coronation on last Saturday. Did Did people, can maybe put your hand up if you watched the coronation? So you have a good number of people that watched the coronation. A lot of people commented on the great and the excellent singing by the choir of Westminster Abbey and these two fine gentlemen, Roderick Williams on the left and Sir Bryn Terfel on the right, who sang in Gaelic. Gaelic is the ancient language of the Celts. Both spectacular performances. To deliver good results like this, you have to bring your best people forward. And this is something in Britain that we did during the war years, and we saw again the best of British, perhaps, during the coronation. Including the splendid Westminster Abbey. Now, while I was watching this on TV at home, my partner turned to me and said, "Why don't you build nice buildings like this?" Well, that was a really difficult question to answer because, as I was discussing earlier with Dav, today's buildings is quite often gets attacked. It's predominantly a money-driven environment we are working in, and we have to deliver as good a product as we can in this environment. But I think the other important ingredient in this is to bring passion to everything we do. If you're just going through the motion, you're going to end up with pretty average, pretty mediocre results. So it's important for us to bring our passion, bring our imagination into what we are doing. So the prime purpose of the Zak World of Façades series of events is to disseminate essential facade knowledge and share that knowledge. By having this group, this diverse group of people from architects, engineers, suppliers, developers, and so on, we're getting a complete 360 view on the construction scene. We all bring our particular focus, whether it is technical, design, aesthetic, cost, program. We bring that to the table and we all have to listen and try and accommodate all the different aspects of what we have to do. So today's event has the title or the theme of Transformative Facades Powering an Evolving Metropolis. And Birmingham is certainly at last beginning to receive the recognition that it deserves. And the scale and the quality of the projects that are coming up in Birmingham are something to be proud of. And this is represented well here by this project, which is a project that we had the fortune to work on recently with our partners Inasus from Spain. And with also the demands of sustainability and net zero carbon driving us to genuinely come up with new ideas and new ways of doing things. So it's a good time to come together to explore this. And we have to embrace craftsmanship, but also embrace this digitalization, which is where we are driven to go with especially with a sustainability agenda. We have to inject passion into our work, push quality up, and push the design life of buildings to maybe 100 or 200 years. Why should buildings like Westminster Abbey withstand the test of time and some of our buildings don't last more than 5 or 10 years? I want to say a special thank you to all the speakers that will and the contributors that will be part of today. They've all taken a big chunk of time out of their busy schedules to prepare their material and to come and deliver it today. So thank you to all the speakers. And I want to remind the speakers at this point that at the end of every session, there will be a memento award to the speakers. So speakers, please stay at the end of your session. So on to the serious business of today. And I'm really delighted that our first speaker today is Dav Bansal from Glen Howell Architects. Dav is a local Birmingham architect, has probably seen more transformation in the city than most of us. He's been with Glen Howells for 24 years, I believe. Is that right? Yes. Yeah. And he leads the Birmingham studio. He will talk to us about aesthetic and ethics and give us some insights into the work of the practice. Thank you, and over to Dav.
Thank you, Stephen, for the introduction. Yeah, it has nearly been a quarter of a century now since I've been working at what is now Howells. So we've rebranded. So I would like to welcome you all to our new name, Howells, which is the slide on? Oh, sorry. Which was only launched a few. God, that is bright, isn't it? Which was only launched a few weeks ago as an evolution to the practice over the last 3 decades, and to equally reflect the strength, the expertise, and the breadth of our homegrown leadership. So my name is Dav Bansal, and I'm one of those partners who leads our Birmingham studio on a significant number of projects across the UK. At Howells, we make lean projects and buildings by interrogating every part of our design, and to make them work hard, but also to do more than one function. And the facades is no exception to that. Hence my title about less aesthetics and more ethics. Now, they say that aesthetics is concerned with the questions of what is beauty, what is ugliness, and how can beauty improve our lives. The Victorians, the Georgians, the Edwardians did it extremely well with decorative facades to express wealth, power, civic pride. But we are now in a different world where ethics concern the question of what is right, what is wrong, and how can we make the best decisions for a sustainable future. And just like our skin, an extremely versatile organ of our body, the facade of a building should be natural for it to be a part of that building which bears a fabric-first approach, capable of becoming adaptable to the environmental conditions and of the place of where it is located. And from a performance standpoint, facades provide the largest single surface area of the building enclosure, and I think we all know that, especially the QSs. But just having a very different impact on the long-term durability and energy performance of the building. And I think that's really key to understand, as Stephen picked up earlier in his introduction, about making buildings that will last forever and be able to be adapted and flexible. And we know facades can contribute up to 30% of the total embodied carbon of a building, according to a World Business Council for Sustainable Development study taken out in 2021. So how do we seriously begin to consider facades that do more to address carbon and embodied carbon and climate changes, where the design rationale and the direction should be more about the ethics than just the aesthetics? I think what I'm trying to say here is that the approach should not just be a contextual or a heritage or an urban design response to materials and architectural style, which is then manipulated to attempt at addressing sustainability, user comfort, or energy performance. Hence, there's more to a facade that meets the eye, and it needs to be an intelligent facade for the future, serving many more purposes and many more benefits than simply fulfilling an aesthetic goal. From first principles, the form factor of a building, where building less is more. Now, these are extracts and slides, and I'm sure many of you come across these studies that have been conducted. And they illustrate that efficient forms and massing reduces a facade's contribution to embodied carbon. And we know a circular plan is the most efficient, but more challenging and sometimes unconventional to build. Challenging because of internal layouts and internal spatial arrangements. Hence, a very unique octagon tower, which I will elaborate later on in the presentation. A simple palette of materials and fewer system types, facade types with repetition or standardization of the facades go a long way to promoting prefabrication. And the opportunity to explore modern methods of construction, in addition to reducing embodied carbon or site wastage. So be it like the unitized system that we've used on the Rotunda in Birmingham, where we strip the existing building right back to the concrete structure and reclad it in a fully unitized facade system. Or it can be precast or designed for manufacturing assembly, otherwise known as DFMA. So embodied and whole life cycle carbon should drive our choices, or should be one of the elements that drives our choices. Early testing with facade engineers and exploring sustainable materials, as well as construction methodologies, should help inform the direction and design of materiality and choices of delivery, not the other way around. At Washwood Heath Depot, our project for HS2, the lightweight cladding in zinc reduces the embodied carbon by up to 20% compared to a heavy masonry alternative. And due to it requiring little maintenance and its durability compared to, say, a polyester powder-coated aluminium finish, there are further reductions in its whole life cycle carbon. This has contributed to halving the building's embodied and operational carbon. A fabric-first approach to managing overheating and operational carbon, where we test sunlight, daylight, and wind early on to establish orientation and the approach on different aspects of the building form. Here on 100 Broad Street, our project in Birmingham, this study provided us with very important data to determine the size of openings for the various orientations to manage overheating, and also the free area for opening lights. So therefore, it is much more beyond aesthetics that a facade needs to do more than just look pretty and keep the water out. And it needs to address the current environmental challenges and resolve problems in its context, in its climate, and for its users. I will take this opportunity to briefly present to you with 3 case studies by Howells, which I believe represent a range of buildings considered to be ordinary urban typologies, from high-density residential to workspaces in an urban setting. Through these examples, I do hope to elaborate on the approach to my presentation here, which is that beauty is more than skin deep, and I'll be using the Wardian towers to demonstrate that. A lean and therefore clean approach should be promoted, using our One Centenary Way project at Paradise. And finally, we should design for assembly and prefabrication, and subsequently disassembly in the future to treat buildings as material banks, for which I will use the Octagon as a case study. The cool towers at Wardian. So in contrast to prevailing backdrop of sheer facade office towers at the Canary Wharf, Wardian is fully wrapped in balconies that signal that distinctiveness of its pair of residential towers at Canary Wharf. The Wardian has an inherently efficient design comprising of 2 simple rectangular towers on a north-south axis, and they're shifted apart on their dramatic waterside edge. This simple diagram allows every apartment to enjoy unobstructed views of the city skyline and to maximize the daylight. However, the facade has been designed to reduce solar gain through the use of deep 1.8 meter projecting balconies as external shading devices, so resulting in a staggering 42% load reduction in comparison to cooling load reduction, in comparison to towers with unshaded facades. And this is projected to rise to 55% saving by 2050 as global temperatures increase. This maximizes daylight while offsetting a glazing ratio of 45%, and subsequently defines a simple yet functional expression of the architectural language. And that's far better than solar controlling coating and fitting on flat facades. And rather than relying on air conditioning, Wardian's sky balconies cool incoming air, as well as providing every home with generous shaded amenity. The greenery also contributes to air quality, creating an environment that is relaxing and supports the wellness of its residents. The continual balconies also add on an average of 400 square feet to the apartments and have their own watering point for maintaining the planting. And in some cases, this is 4 times more than the average private amenity provision for London urban housing. So this facade approach provides not just generous outdoor living space, but protects the apartment interiors from solar gain, heat build-up, and overlooking and privacy. So perhaps maybe we should mandate this amenity provision in our regional cities like Birmingham, which would subsequently help to shade our buildings and our homes. Anticipating the logistics of the building on a constrained inner city site, we also designed the repetitive wraparound balcony systems and facades for off-site fabrication, enabling efficient installation from within to minimize crane time and site wastage, and also to contribute to reducing embodied carbon. Now, every project at Howells is generated from first principles and a clear thinking. Underpinning this approach are 5 guiding design principles, one of which is to make lean buildings. And this is because they use less material, are cost-effective to build, and ultimately consume less energy, and are better for the planet. So the approach to One Centenary Way is no exception. This is probably the most complex site in the city, riddled with constraints. The Queensway Tunnel that runs through the site underneath the building, the service tunnel that runs across east to west, and the proposed access into the Paradise Master Plan all restrict the area where the building can actually physically hit the ground. But these combined constraints have demanded a very bespoke and innovative steelwork design to resolve the structure, which in turn becomes the facade. A building of 2 parts, as they say, that braces it to ensure it does not buckle or twist, and the 16 transfer trusses that span over the underpass to create a platform, and then the steel exoskeleton that stabilises the commercial building above it due to a non-load-bearing structural core. So it's a truly engineered-led design that informed its architecture and facade. A number of options were tested early on for the steel exoskeleton, comparing their performance efficiencies on structural stresses, points, flexibility to work with the constraints, and being open and honest about cost, which is where the Vierendeel approach was concluded to be the most optimum solution, as well as provide the most effective form and extent of shading. The Vierendeel structure is made of these huge 1 metre steel sections, creating a very deep horizontal frame. And the frame is external and sits detached from the unitised curtain wall to support the slabs, provide structural stability, and as a consequence, the much needed shading to the building, which in turn, as I said, becomes the architectural language for the design. So the sustainably sourced exoskeleton frame reduces the need for concrete also, using the construction by almost up to 2/3, with the concrete only being poured over the crinkly tin floor slabs. And this is a time when I guess we didn't have access to low embodied carbon, or what they call now smart carbon in terms of GGBS. But with the naked structure now becoming the facade, and with no additional materials to overclad the structure, with the exception of the applied intumescent paint, it was absolutely key to ensure that every detail and junction was considered, tested on full-size mock-ups, and refined. The facade and the structure becoming one also pushed sustainability and innovation to be a common thread throughout both design and manufacture. A switch from plate girders to roll sections saved 900 tonnes of embodied carbon. The innovation and the innovative construction methodologies that were utilised in the factories on a very super scale structure. So this was a way of applying the intumescent paint on these big, huge sort of wheels that were able to turn the trusses around completely without them touching the ground. And then the steel fabricators using power generated by an on-site wind turbine as a low-carbon solution. This made the design one of the most sustainable workspaces in the city, where the facade not only protected the internals, it stabilised the structure and also shaded the building, which was 100% glazed to provide ample daylight into the deep and efficiently planned working floor plates. The story continued inside with the exposed structure and services, framed by the letterbox proportions of the facade and the 1 metre banding of glazing, offering a very bespoke and innovative alternative to the workspace. The 3 metre centres challenged the conventional 1.5 metre vertical glazing that we find in many office buildings of today, and instead created a larger order to the facade with panoramic views out. The holistic and honest approach creates a facade that delivers on many levels, including its muscular, timeless beauty and robustness, which will age gracefully. The Octagon is the first pure octagonal high-rise residential building in the world, making the most of its location on the Birmingham Ridge at the northern tip of the Paradise Master Plan. The tower houses 370 spacious built-to-rent apartments with uninterrupted views across the city. It's a 49-storey built-to-rent scheme, which will become one of the city's landmark, instantly recognisable due to its quite unique form. Again, the simple octagonal plan maximises the form factor of the building, which I picked up on earlier in the presentation, with a highly efficient water-flow ratio of 0.4, which reduces the surface area by as much as 15% compared to a similar conventional design. The 12-metre facets of the octagon are expressed as deep metallic skeleton frame, as I call it, profiled to provide shading while offering good levels of daylight, and the glazing datum with an internal sill level for hiding furniture and all the sort of residential clutter while maintaining views out when seating and standing. The sculpted form actually offers more shading to the bedroom spaces, while the slightly opening up in the centre of the sort of folded spandrel, it opens up to the central living space for an improved view of the sky. The hopper-style opening vents on the glazed section work very well on a tall building and allows for generous fixed panes above to offer the panoramic views of the city. and the better quality of daylight deep into the apartments. We felt that that sort of panoramic element of glazing is not too dissimilar to what you would do if you were doing sort of vertical windows, but by providing it as a horizontal aspect means that we do get better quality of daylight deeper into the apartments. So the proportions of the glazing in a solid were established by testing the outlook when you're standing or when you're seated. So the form of the facade and the sort of proportions of facade follows the internal function. The repetitive nature of the facade also, with its single material wrapping around the octagon, also allowed us to explore a number of prefabricated methods for construction. With no corners on the octagon, all 352 facets are identical, and they repeat over 44 floors, so it's perfect fit for a prefabrication solution. In this case, designed for manufacture and assembly in a way to construct the facade more quickly, efficiently, and also sustainably. Using this approach means that the elements are created in a factory environment rather than on-site, and using a more standard components and specifications. So, in essence, a kit of parts coming together at factory and also in parts on the site before being lifted into place. And the lightweight system of folded metal sheets is then fixed to a steel cage structure, which is prefabricated in 6 panels for each facet, and then these will be assembled on site together, lifted into place with the glazing in situ. So hence designed for assembly, minimizing off-cut waste and also, more importantly, utilizing standard size components. The durability of the components and the materials, designing reversible connections with a dry construction method, and the standardization is also designed for future disassembly and therefore treating the facade as a material bank. This DFMA approach ensures tolerances are managed with minimal deviation, quality is checked, safeguarded as it leaves the factory. And this full-size bay mock-up that we went to see at Macmillan's yard in Belfast has helped us to refine those interfaces, establish those tolerances, and understand the general assembly. So it's very important to get your sort of one-to-one full-size mock-ups, I guess certainly agreed into your contracts when you're building buildings of this scale. And that was really important here, where they built an entire facet for us to understand those challenges of installation and tolerances. And with no site wastage, nor heavy reliance on site labour, the quality is precise, the speed of installation will be rapid, and it can follow closely behind the rise of the precast, core and floor slabs. So we're looking very much forward to seeing this facade take shape later on this the next month. And finally, architects may not always be responsible for calculating the embodied carbon on a facade or its environmental impact on the performance of the building. But as architects, we can have a huge influence on the results. And this should be our starting point on all designs going forward if we are to achieve our carbon targets. Charles Holden, the RRBA's gold medalist in 1936, once warned against style as a basis for design. He said, style, should arise out of a particular problem and the capacity of the architect to give visual aesthetic quality to the solution. So therefore, I do hope we can look forward to discussing smart solutions that are less about the aesthetics and more about the ethical values to deliver prefabricated, low-embodied, and intelligent multifunction facades for a sustainable and beautiful tomorrow. Thank you.
Well done. Thank you. Just stay for a minute. Thank you very much, Dav. That was absolutely amazing. I see you've embraced prefabrication in your practice. You referred to prefabrication as, as a method of construction that you like. You've used it on several projects. Do you always get the opportunity to do it, or do you find sometimes obstacles?
There's always obstacles because with prefabrication, the sort of likely upfront costs are higher than doing, I guess, the traditional build. But in some respect, what we've got to look at is a sort of, the benefits of prefabrication. No waste, site wastage, yep, reducing embodied carbon, but also reducing prelims and overheads and time on site and the health and safety of workers. Yep. So there's many benefits, and I think we design buildings with that initial consideration early on, which yep, I think is more about thinking about the ethical values of what we're doing rather than creating style and then thinking about how do we prefabricate a facade.
great to hear that. And also, I think we're chatting a little bit earlier before, and you mentioned how do we get cost consultants, quantity surveyors to, if you like, highlight the benefits of prefabrication rather than detract from it. Because quite often, you're right, sometimes it looks like on a unit rate it has higher cost.
Yes.
But there's a lot of other benefits, such as reduced prelims on site, reduced program,
Yes.
less site access requirements. How can we get that into the equation that people understand the benefits of prefabrication?
I mean, first of all, good QSs and PMs are a rare breed now. So first of all, find them. And then I think it's important to have that conversation early on and look at it as a holistic approach. And sometimes working with facade consultants and facade engineers and facade contractors early on to gain that knowledge and understanding how the entire process of build, design, prefabricate, and how does that work for the entire program of the project and beyond. So it's an education that I think we all need to sort of continue to work with. But we are working on more challenging sites, more complex inner city regeneration projects. And to be honest, the way forward is going to be about prefabrication. Because I think, gone are the days when you can have scaffolding up for the entire duration of a project and relying on people to sort of be up there and create the quality. There's also the essence of snagging and the quality. If the quality is checked early on, that is a lot of time saved on site. Yeah. So there are some commercial benefits, which benefits the project, the viability, and developers. And I think it's having those conversations early on, rather than trying to design the facade, then get planning, and then think about the conversation. Because at that point, I think it's too late in the day to be thinking about how are you going to make something that you've just designed.
Well, I find talking to you very refreshing because you reflect all the things that we believe in early engagement and working collaboratively. So that's great. Thank you for that. One final question before I let you go.
Yes.
How do you see the Birmingham market? You're very much connected here. You see the state of play here. Do you, and we've all seen kind of an explosion of projects here in Birmingham. Do you see that continuing for the foreseeable future? I know it's driven a lot of it by HS2.
I mean, Birmingham is going through a huge renaissance. This is the last time this happened was about 120 years ago, when Joseph Chamberlain, sort of established the city as a municipal city, and therefore bringing in, the civic heart, the sort of homes and businesses. And what we're seeing right now is amazingly just the start of this. We're launching at the UK Reef next week the Future City Plan alongside our partners, Birmingham City Council, and that is taking what we regard as a city core, which has been defined to date with the ring road, inner ring road, and we're pulling that city core out towards the middle ring road, and that is going to vastly improve the opportunities and the scale of the city. So bringing in the communities that live around the sort of city core, bringing that in. So I think the opportunities for projects, for creating a sustainable, walkable, good, well-connected transport of a city is just a start of where we are at the moment. So I think Birmingham will go through a transformation over the next 20 years, and hopefully we'll still be around to enjoy that. So I think there's a lot of lessons that we can learn globally that I think, and also from other cities, that we should bring to Birmingham and make sure that we do a fantastic job.
Great. Thank you for that. I'm sure that's a message that's well received in here as well. So
Great.
Thank you so much.
Thank you. Thank you.
Our next speaker is Gurprit Bassi from Wintec. Gurprit's going to talk to us about condensation and airtight solution. Thermal bridging and the thermal bridging conundrum. And actually, I was thinking about Gurprit's presentation when you were presenting Centenary Way, because that's always an issue when you have an external skeleton. How do you deal with the thermal and make sure that the building is not losing energy? So I'm looking forward to Gurprit's presentation. There you are.
Hi, can everybody hear me? Yeah, I can hear myself. So my presentation's about thermal bridging. My name is Gurprit Bassi, and I'm a director at Wintec. Just going to find the clicker. So why did I choose to do this presentation today? Well, the primary reason is Part L has changed. It came into effect last year, it was in 2022, it came out. And for buildings that are registered past the 15th of June 2022, it's now mandatory to comply with the new Part L. So I don't know about you guys on your projects, but previously a lot of buildings tended to ignore thermal bridging. And now that the new Part L has changed, we're finding a lot of consultants and a lot of projects are now having to consider this. They don't know what they're doing, they don't know why they're doing it. And the reason is because CO2 targets have dropped in Part L by 31% for dwellings and 27% for other buildings. In 2025, the Future Home Standard is going to come out, and the Future Building Standard is going to drop even further. So it's going to be increasingly more unlikely that we're going to that we can't ignore thermal bridging anymore. So just a little bit of context on what we can do in terms of thermal bridging. So 9 metric tons of CO2 equivalent. This is in 2009. This is what could be saved if all the existing inefficient dwelling stock is upgraded with good thermal bridging. I'll describe what good thermal bridging is later on. Just to give you some context of what 9 metric tons is, Cyprus has a population of 1.1 million, and it emitted in a whole year 9.5 metric tons of carbon. So just a little bit of context there. I just need to run through with you what thermal bridging is, just for those of you who don't know. So a thermal bridge, or a cold bridge, as it's otherwise known, occurs where there is a localized weakness or discontinuity within the thermal envelope of a building. They generally occur where the thermal layer is interrupted by more conductive material or by a change in geometry. So this is a diagram from the Zero Carbon Hub. It's all of the interfaces around the windows, the doors, the ground floor, and the parapets and so on. So what are the consequences? The obvious one is heat loss through a junction. The thing I should mention is we're talking about non-repeating thermal bridges. So those are the ones I just mentioned, and the repeating ones are the ones in the wall, which tend to be the studs and the mortar joints. And the other issue with thermal bridging as well is condensation and mold growth. So just some denominations for you, just to make the rest of the presentation, just so you understand it. A Y value is a measurement across the facade, so it's measured in watts per meter squared. A psi value is a lineal measure of heat loss, measured in watts per meter Kelvin, and a chi value is a point loss, measured in watts per Kelvin, just so you can understand the rest of the presentation. So I'm just going to run through with you what the previous requirements were and what the new ones are before I get on to the conundrums. So the previous requirements, there were 4 options. A, B, and C could be interchanged, and if you didn't want to consider thermal bridging at all, it was option D. So you just use option D as a blanket value. Approved construction details, B is to calculate, and C is to use default psi values. For existing dwellings, you could either use accredited construction details, and it's impractical to consider condensation. So what changed? A and B disappeared, it's now just L1. Approved construction details disappeared. So the reason they disappeared was essentially they were out of date. And they tended to be applied to multiple construction details when they shouldn't, because the values are different. They tend to use U values within their wall. And as U values have decreased, essentially they're no longer applicable. So they've been replaced with junction details from a reputable non-government database. They've said this in the guidance. There's only one database I know of. It's called the BRE Certified Thermal Details and Products Database, but essentially it's quite limited in what it has to offer. The default value's gone up by 0.15 to 0.2. So this was the value that everybody used when they wanted to ignore thermal bridging, and it's gone up, so it's now even more difficult to use. Personally, I don't think this value is high enough, but I'll explain why I don't think that value is high enough. A few other additions. There's lots of prescriptive guidance if you read Part L. An interesting point is we now have to take on-site photographs for each dwelling to inform the building control body. So that's now something that's Part L, and we have to ensure constructions are buildable. For existing dwellings, accrediting construction details have gone, and it says that we should take care to limit unwanted heat loss. So this isn't really a mandatory requirement. It's, how much should we care? This really irks me, and I'll get onto this later on as well. For non-residential buildings, there's two approaches. This was previous, so you could calculate or use default site values. And for existing, you'd have to do a report to ensure that what you've designed is as what's built. You should have used accredited construction details or do a condensation check. So what changed there? A and B is gone, it's now Part L2. Again, you have to do site inspections to inform the building control body, and accredited construction details have gone. So there's not much changes there. So it's quite a big topic, thermal bridging, but I've kind of narrowed it down into a few conundrums, just to kind of inform you guys about what it is and what it's all about. So I'll explain to you what the significance of thermal bridging is. Which one should be calculated? So this is quite important. Should I calculate one? Should I calculate the worst one? Should I calculate all of them? How many should I calculate? When should I be checking for thermal bridging? So it should be in RIBA stage 2, stage 3, all the stages, so we'll look into that. How do we design to be thermally efficient? So just some tips on that. The benefits versus the potential pitfalls. So if the guidance is now forcing us to calculate thermal bridges, what are the benefits? And will all benefits or potential pitfalls? And the last one is quite an interesting one, is this word care that I spoke about before, or limiting thermal bridges. How should we go about caring? And in terms of net zero refurbishments, I don't know about everybody in this audience, but I've never seen a net zero report even consider thermal bridging as part of a net zero analysis. So I'm going to try and analyse whether it's worth considering it. So how significant is it? Well, this is just a few examples. We've got, on the left is a pretty decent wall configuration, and on the right is an even better one. According to the Zero Carbon Hub, thermal bridging can account for up to 30% of the total heat loss in a building. But in these two particular configurations, it's 20 to 24%. So the key takeaway from this slide is, as we improve the thermal values of walls and glazing, the thermal bridging value as a total heat loss component tends to increase. So what happens when we try and reduce thermal bridging value? So we've got the not so good wall here and the very good wall here, and we've gone down from 20 to 5 and 24 to 6. So it does have the potential, if you do consider thermal bridging, to have some quite significant gains in reducing heat losses through your building envelope. So which ones should I calculate? So this building here, there's a lot of numbers on here, so I'll just explain. On the bottom left is this is our building. So it's 4 stories high, 3-story high floors. The distance between party walls is 9.7 meters. And these are thermal bridges at the top. So what we've done is, I don't know if this will work, the pointer, no, it's not, yes? Yeah, okay. You can see, oh, this is really good. You can see that we've used default values. So we've used default values for all the thermal bridges, and the key takeaway here is, if this pointer works, this value here, 0.37. So the Y value is way higher than the default, which you remember from before was 0.2. This is primarily why I think the default value is not high enough, because with all the default values, it's way higher than 0.2. So let's try and calculate 2 of the thermal bridges that are really high. So we've got 23%, which is the lintels, I think, and we've got the balcony. So we'll calculate those 2. So we've calculated those 2, and we've now got to 0.19. It's still pretty close to 0.2. Should we use a default? Probably. We've only calculated 2. It hasn't made much difference. So what if we calculate the next 3? We've calculated the next 3, and we've got that Y value down to 0.1. So that's half the default. So that's pretty good, and we're getting somewhere. So what if we now throw the kitchen sink at it and calculate everything? we've got it down to 0.07. So this is kind of the area we're getting into where we're at the limits of what we can possibly achieve for this particular building. Interesting to note here is this yellow blob here. This is for balconies, and it's contributing 40% of the total heat loss. So balconies as a proportion of the total building is a massive component. Something else as well is for the sill, I've used a default value for the door sill. I'll explain why I've used that later on, but it's generally as what we used on this project was a continuous bracket under the door sill, and because of that, the default option was the better option rather than the calculated value. So when should we be checking for thermal bridges? So because we now have to check for thermal bridges, we have to check much earlier on. So that's stage 2 and stage 3, and whatever we come up in the architectural proposals, it has to be, in essence, similar to what we think is going to be proposed by the contractor later on. So that requires some really early development. So in doing some early development, we have to consider all the performance. So that's structural, thermal. Does it work? Is it buildable? So I'll kind of get onto that later on, explain it a little bit more. In stage 4, we'll have to review the design. So are they as we intended? And do a final detailed design check at the end of stage 4. And this stage 5 is where we do our site inspections. So this is where we have to do our photographic evidence to inform the building control body. So how do we design efficiently? These are just some basic pointers. I only had 20 minutes, so I couldn't really go into this, but we want to try and remove the thermal bridge. Can we remove it entirely? Can we use less conductive materials? So can we replace maybe aluminium with stainless steel? Can we thermally isolate and put thermal packers in? Can we alter the geometry? So can we make sure that the thermal line is continuous and there aren't any steps? Can we increase the depth of the bridging element? So this is something that's not immediately apparent, but say a window frame, if you make a window frame deeper, it increases the distance that the bridge has to travel. So these are all the performance aspects on the right-hand side that we should be considering early on. So performance, practicality, building, sequencing, cost, aesthetics, architecture. This is all the things that we need to consider. When we design early, do we always know about cost? Do we also know about procurement at that stage? And if we don't, is it worth getting a subcontractor on board early on so all of that is factored in? Because we don't want it to be a problem later on when we've finalised these early stage designs. So if you want to know a little bit more about designing efficiently, there's a document here from the Zero Carbon Hub. It's a thermal bridging guide. They've got lots of illustrations if you want to know how to design better. And CWCT TN108 will be coming out soon. So just a little plug there. And they've got some good tips on how to design more efficiently. So I just wanted to go through some examples of what's happening in the industry and how we need to start kind of changing our mindsets. So this is a modular building. This was a window with a continuous bracket all the way around the jambs and the sill. So the reason they do this for modular buildings is because it's to stop the windows from falling off essentially as it's going down the motorway or wherever it's going, as the thing's being assembled. But as you can see, it's not particularly good for thermal bridging. So do we need to think about the way that we design these buildings a little bit better? Can we use isolated brackets? Can we use a thermal block in there? There was one modular building contractor that I went to see in Leeds. I won't name them, but they used thermal blocks. So maybe we need to start thinking about this a little bit better. And this thing with the door sill here that I was talking about before, can we somehow remove this door sill stop it from being continuous? Can we somehow reinforce the subsill? And so we can only use one bracket either side? Is there some innovation to be had in order to reduce these thermal bridges? So we saw before how balconies are such a massive component of the total heat loss. So should we start to think differently about balconies? So I know it doesn't look particularly pretty here, but we've got some restraint ties. Can we start thinking about adding some restraint ties in to reduce the number of connections? Can we use stacked balconies? I know they only go up a certain level of stories, but that will considerably reduce the number of connections. Can we remove the bridge entirely? So we've got an example here of a unitized panel with a balcony stub bracket integrated into the panel, zero thermal bridging. Here we've got a balcony connected into a precast unit. Again, it doesn't go through the insulation, zero thermal bridging. Yes, they're more expensive, but can we start considering these types of options if we want to get even lower? So what are the benefits versus the potential pitfalls? Well, the obvious one is it will reduce energy. There are cost benefits in considering thermal bridges. So the next slide, I'll go on to why I think it's incredibly cost effective in order to consider it. Increased early stage design. So by doing early stage designs, we can increase cost certainty. But there's also synergies with the Building Safety Act. So we believe that the Building Safety Act, when it's finally enacted, is going to force people to design their buildings a lot earlier on. So because of that, and there's certain synergy there with thermal bridging, where we also really need to consider these early stage designs. And it will give you increased condensation performance as well when you do start to calculate thermal bridges. So what are the potential pitfalls? Well, I've kind of discussed this before, but when you start designing earlier, you do need to start earlier, and there's a lot more resource you need. It has to be designed for performance, and there is a risk that the eventual construction doesn't match what you intended at the start. So it really does need a lot of design input in order to mitigate that risk. So how cost effective can it be if I wanted to calculate it? So this is from the Zero Carbon Hub. We've got 3 houses here. One's got 5.5 meters squared of PV, and the one at the end has 0 PV. The difference between these is the first one didn't consider any thermal bridging, and the one at the end did, and it removed the PV entirely. So I've considered some costs at the bottom here. So this is just some indicative costs on what I think it would cost to calculate the thermal bridges. But if you was to do this as a one-off, it probably wouldn't be cost effective. So we're talking about economies of scale. So in terms of economies of scale, you only need to calculate once, and when you calculate once and the detail is repeated multiple times, say on a high-rise building or a modular development, if you only do it once, your cost savings are multiplied by the number of units that you have. But obviously, if you're building a one-off grand design with bespoke details and interfaces, you're probably better off doing it using another technology, such as maybe lighting, PV, MVHR, and so on. So the final slide I've got here is of refurbishment. So it's this issue of taking care. How should we care about thermal bridging in refurbishments? Should we care? The guidance says we should care. And also, is it worth considering thermal bridging in a net zero analysis? So this just 2 examples here. This is a project I was working on in Belleville House. So we had a continuous angle at the sill. This was there before, and it was there to support the reveal. It's not particularly thermally efficient because it's a continuous bridge all the way down. I mentioned this to the client. We had a really good collaborative design team. We were under the old Part L, but they still wanted to be efficient and consider a different way of building. So we removed the bridge entirely, and we put a bracket here and connected it to the helping hand. And by doing so, we reduced the heat loss through this particular junction by 43%. So just that small change, it didn't cost anything, but it was just us thinking outside the box. How can we reduce that thermal bridge? In terms of net zero, so our headquarters in Wolverhampton, it's called Quartz House. We're currently undergoing a net zero refurbishment. So we got to thinking and we thought, well, how could we consider thermal bridging as part of our net zero refurbishment? So we've got some pretty inefficient windows. They're screwed into the brick. It's brick and block. We don't have any cavity closers, and we've only got 25 mil of insulation in the wall. So we thought, well, we're going to remove the windows anyway. Is there any opportunity to maybe improve this interface? So we put a new window in, we moved it back in line with the insulation layer, we added an insulated cavity closer, and it reduced the insulation, the heat loss through that junction by 65%. So I've got some numbers here, I wrote them down just to give you an example. So just this improvement alone reduced the energy consumption. So we did a dynamic model for the building, and just making this improvement in our dynamic model reduced the energy consumption by 3%. This doesn't mean anything. When we talk about net zero reports, we talk about payback. So we worked out a payback of 5 years for this particular improvement. We got 62 of these windows. And to give you some context, we changed our LED lighting from fluorescent. That gave us a payback of 5 years. And we've got an option for changing the double glazed units by keeping the frames. And that's a payback of 4 years. So is it something we should be considering? It certainly should be. And you should be seeing it more and more in a net zero report. So to summarise, we do need to start considering and designing interfaces and junctions much earlier for new builds if we are to consider thermal bridging. What that does is it will constrain the design, but so we have to have a lot of confidence that what we're designing and constraining could be built later on. We should be improving junction details as far as we practically can for refurbishment. So we should be doing all we can for refurbishments. This word care, and up until a point in which the government puts some values down so we can design more efficiently. And should we be considering thermal bridging in net zero refurbishments? We certainly should be. And yeah, it's something we need to do. And it's imperative in my view. So thank you very much, and thank you for listening to me. Yeah.
Gurprit, well done. That was really interesting to hear the changes to the regulations, and also all these little junctions. So one of the things I learned from it is reduce the number of junctions, just have constructions which are more homogeneous. What you've also told us is a lot of the prefabrication seems to have better results than site assembled. And that horror picture you showed us of the modular construction with the window in it. I mean, I know our next speaker is from one of these membrane companies. He would probably be horrified at the way in which the membrane was being used as well there, just kind of loosely.
Probably wasn't completed at that point, but yeah.
Yeah, sure. So these are all kind of takeaway lessons that we've learned from that. The question I want to ask you as well is airtightness. What effect does airtightness have on all of this? We've all heard horror stories about airtightness issues, especially in built-up rain screen systems. What's the effect of that? What energy losses could...
Yeah, so as part of our net zero refurbishment that we're doing on our building, it's the first thing that makes the biggest difference.
Right.
So we've put an air barrier in our roof. I was talking about the payback periods. We're talking about 5 years for this. We're talking about 4 years for the double glazed units. For the air barrier in the roof, the payback period was 1.2 years. So it's the first thing you should consider in any refurbishment is how can we make the building more airtight, because it makes a massive difference. Equally so for new builds as well. Airtightness is critical. But we're now trying to get to these lower values. The limiting value is 10, but we're trying to get to like 3. Or passive house, we're trying to get down to 1.
Yeah.
Prefabrication does help. So it increases the quality, and it does reduce airtightness. So that does help.
Great. Thank you for that.
Thank you.
Our next presentation is on a similar theme, looking at condensation and airtight solutions for facades, and it's Adam Sold from Proctor Group. Adam.
Thank you. Thank you very much. This presentation leads on quite nicely. There we go. Leads on quite nicely talking about airtightness. I'm Adam Solt. I'm the Business Development Manager at the Proctor Group. I specialise in modular and off-site construction, but I also get involved a lot with high-rise and facade construction and a lot of projects in and around Birmingham, which we'll demonstrate today. If you don't know about us, we are a family business based up in Blairgowrie, and which is in Scotland. And our kind of approach to the market is to look at the design, look at the problems and try and find solutions, rather than here's a product, this ticks all the boxes. So today I'm going to be talking about condensation and air tightness and some solutions for facade systems. As we've just heard, the importance of thermal bridging, air tightness is also a very critical factor within your design. But taking that holistic approach, we mustn't forget the moisture content and the condensation as well, and how we deal with that. So when approaching a project, how do we achieve a successful hydrothermal design? Well, the first stage is to look at the internal environment. And what I mean about that is what is the building we're building? We want to make it fit for purpose. So if we're building a care home or a leisure centre, we're going to have a lot more internal moisture, different internal environments to, say, a warehouse. So it's important that we're designing a building that's fit for purpose and understanding those internal environments. Once we've got a good understanding of that, we can then move to the external. Now, Dav today in his presentation did a lot on the external environments and the benefits that and importance of it. But you've got the solar gains, you've got the orientation of the building, you've got the weathering to consider. Is there sheltering, surrounding structures protecting yours? Is it exposed out up in the highlands? So all of these are going to contribute to the way our building functions and operates. So understand the internal, then the external environment. From then on, we can look at the building itself, and this is where we've got the most control as designers. We can start looking at the materials we use, steel or concrete, analysing then the moisture loadings, the dry out periods of those, they're all going to interact differently. We can start to look at building off-site or on-site. These are all going to play an effect. Obviously, building in a controlled environment in a factory, we may get better performances. We may also get a lower dry out time than if we were to build on site as well. So all of these factors we can start to consider and weigh up within our design. And then when we've got a good understanding of that, we can start to look at what we call the HAM principles, which is your heat, air, and moisture movement, and taking a holistic approach to make sure we balance all three areas and get a successful hydrothermal design. So how do we do that, especially in a sort of facade system? Well, one of the important things is to understand where the vapor drive comes from. So if we were to build, say, in Dubai, where we're out in the desert, hot external environment, we'd have a bit of a different vapor drive because we've got a warmer external and a colder internal. But in the UK and most of Europe, we have a warmer internal and a colder external. So once we understand that, we can start to look at where we position our insulation and our types of membranes that's going to help us achieve this. Types of membranes we're going to be looking at is vapor control layers. Used to be called vapor barriers. That term isn't used as much anymore because the term barrier kind of means a complete seal with your vapor line. Very difficult to achieve on site with all the penetrations and surfaces. So we tend to use vapor control layers now as the terminology, but also referred to as air as well because they can play that dual function, be vapor tight and also airtight. They're going to limit moisture ingress and limit air leakage. A reinforced and durable system is going to help achieve better performances because any penetrations or damage to that is going to prevent vapor and air to escape from our building. Typically in the UK, we see these behind the plasterboard in that service zone in the internal of our build. We then look at what's more known as the breather membrane in the market, but I prefer to use the term vapor permeable membrane because a breather membrane can be air open or airtight. It's more looking at the vapor transfer. So a breather membrane needs to be vapor permeable. But we can utilize here having an airtight membrane externally can help limit that air leakage away from that service zone, but it still needs to be moisture neutral to not cause a condensation risk and allow our construction to dry out. If it's a fully self-adhered system, like our wrap-type membrane that we'll talk about later, it's going to simplify the installation and help achieve those performances a lot better, especially when looking at air tightness. So what regulations do we refer to when looking at the management of moisture in buildings? We've got the BS 5250 document, which was updated in 2021 to take a more holistic approach, a more unified approach to looking at condensation and damp proofing. Interestingly, when studying some other countries recently, we found out a lot of countries do refer to the BS 5250. It has good definitions on different types of membranes, how to deal with condensation. It also specifies two assessment methods, which is the EN 13788, probably an assessment method most people are familiar with. You run them on every project. It's a Glaser method calculation. So you'll have every month for the next 12 months with a graph showing whether you're going to get a condensation risk. So you'll have your temperature gradient and your dew point temperature, and whether those two intersect is where you're going to get condensation. But there's also specified the EN 15026 standard, which is a dynamic numerical simulation. Takes in a lot more data, and we're going to speak about that in a bit more detail now, looking at a typical facade system. So this is an example of dynamic numerical simulation. It's done using WFI software, which is made by the Fraunhofer Institute in Germany. So it's specified for solid wall construction, but the amount of data we get from it can be useful for any design and give us a lot more insight. So the difference being from this standard to your standard Glazer method is you'll see in the top corner there, actually, I might be able to analyze that. We've got a calendar, a date, ticking by every day. We can run it for 5, 10, 20 years. This gives us a lot more insight into our building. So we're not just looking at the next 12 months. We can start analysing the moisture problems 5 years in advance, 10 years in advance. We've got the temperature across our facade system on the red line. The green line is our relative humidity, and the blue line is our moisture content and the build-up throughout the facade. We can actually start to introduce problems. If we put moisture in at this area, what's going to happen in 5 years' time? Is that going to dry out? Is it going to get more and more consistent? Is it going to start causing problems? So a lot more data within our design gives us a lot more predictions and help us design a better build overall. You can intersect at any point within those years that you want to run it for, looking at the external and the internal surfaces, analysing that moisture content and that build-up in much more detail. It's a full report, and our technical team put a summary at the end to make it a lot more simpler to understand. A great project that really utilised a real difficult hydrothermal design was this project here in Exeter. It's called St Sidwell's Point. It's the world's first passive house leisure centre that I was lucky enough to work on myself. If you kind of let that sink in, world's first passive house leisure centre, you've got all the worst kind of case challenges. You've got a lot of internal moisture. You've got to try and achieve those low energy designs, insulation thicknesses, low U values. Passive house is 0.6 air tightness. However, they were going for 0.3 air changes per hour, which was achieved as well. A lot of people, when they think about passive house, they think about a box-shaped design, very simple, to achieve those low-energy design performances. We see there a number of curvature facades. There was a number of different facades as well, CLT, concrete, blockwork, SFS, really pushed the challenges in design. They didn't want to make this project simple. It was also a high-rise building, so fire was of consideration as well from that point of view. Obviously, being a leisure centre, we've got a lot of moisture being generated from the swimming pool, a lot of heat. We've also got the gymnasiums as well. And trying to optimise and utilise that building in the best way possible, every aspect of it was analysed to get the best performance out of that. And it's still now it's open, is going to be analysed for the next 5 or 10 years as well to make sure it's being an optimised design. We ran our WFI calcs on every single facade design, playing around with the relative humidities to understand those internal environments, which is critical, especially in a swimming pool project, to get a good understanding of where there might be condensation, what's going to happen to that moisture, and what the problems are going to be. Intersecting it at any point and looking at those different types of products within that facade. A big part of the design to achieve those low performances, and it's kind of been mentioned today, is having the collaboration of everyone involved. So upskilling the labour force was a big importance to the main contractor, which was Kia. So all the staff were trained on how to install the products, and everyone had the buy-in of the project to understand what we were trying to achieve. You'll see in the top corner there, they built mock-up boxes, mock-up rigs, so we can start to play around with that facade design and get an early indication of where the problems might be, where the challenges are, before we actually start installing on site. So everything was kind of analysed before we even implemented onto site. And then when we got to site, you can start to see the quality level of install because of all that legwork done prior to it. Really good tape detailing, sealing everything up using our wrap-tight tape. So it used our wrap-tight membrane onto the sheathing board, the CLTs, to give its external air tightness line away from its surface penetrations. But you'll see there, we're also holding another membrane out in front of the insulation. Now, Passive House have something specified called wind washing. So that's to do with any air that gets behind your cladding that's going to interfere between the gaps within your insulation. Obviously, in an ideal world, we're not going to have any gaps, but actually, practically, when we get to site, there will be air gaps between our insulation. So another membrane that's airtight was positioned on the outside to prevent that wind washing or thermal bypass of the design. And again, some more photos of the quality of the install. And that's a good photo there demonstrating all the different membranes. So you've got the wrap type bonded onto the sheathing board. You've got your rock wool insulation. You've then got your external airtight membrane for thermal bypass or wind washing, and then your cladding system demonstrating the different benefits there throughout the whole design. A project a bit closer to home, you might have actually seen this on your way in today, is Kent Street Baths. It's a bright red building, you can't miss it, just down by the big roundabout there. There's also Holloway Head. So again, utilising our wrap-tight, fully self-adhered system, critical on sort of high-rise, because a lot of taped-on systems can start blowing off and getting damaged quite easily with the winds. And that bonds onto the substrate is your external airtight line. And obviously, being high-rise, it needs to achieve a minimum fire rating of BS3D0, and this achieves a BS1D0 as well on certain substrates as well. So yeah, that achieves that, and obviously stands out quite nicely, looks very good. But there's a lot of membranes out there. There's no one shoe fits all for all your projects, and it's really important to understand your building and make sure we're designing the right solution for whatever challenges you're going to have with your building. Whether it's from your ground gas, protecting from radon or methane, building a lot of brownfield sites, especially here in Birmingham. So detailing from the bottom all the way up as well. But thank you very much today, and hopefully you found that interesting.
Thanks, Adam.
Thank you. Cheers.
Thank you. Just a quick question before you go.
Yep.
You mentioned the leisure centre
Yep.
is going to have 5 years going forward doing monitoring of
Yep.
their performance.
Yep.
What kind of things are they monitoring, and how do you learn from it?
Okay, so Gale and Snowden are the architects that worked on that. They're based in Exeter, and I believe they're just going to be analysing that performance of the building, make sure it's still from what when built on site, make sure you've still got the air tightness, making sure you've still got the thermal performances, moisture, and everything's just operating. Low energy design, so they don't want much input of energy from any of their systems. So everything's just being monitored. And that's typical on a lot of passive house projects now, when you go for the full certification as well. So yeah.
Right. Great.
But brilliant, thank you very much.
Thank you.
Yes.
Thank you very much. I should have announced it earlier, but if you need Wi-Fi, Obex has very kindly provided Wi-Fi for everybody to use. They will be happy to give you the password for it if you call at their booth outside if you need Wi-Fi in the coffee break. But before we go to coffee break, we've got one more presentation, and it's going to be on protecting modern buildings and ensuring effective compartmentation of curtain wall facades. And it's going to be delivered by Graham Laws, who's Technical Director at SideRise. Great.
Hi, great to see everyone today. Very pleased to be able to present here. I'm Technical Director for SideRise. I've been with them quite some time now, coming up to 23 years. Wanted to talk to you today about compartmentation and the challenges with aluminium curtain walling. As you'll be aware, almost all curtain walling is non-fire rated in the UK. And aluminium, beautiful material, very versatile, lightweight, has some challenges with respect to fire. So what could we be doing differently? And what is the UK doing now? What's happening around the world? And so when we're looking at compartmentation, we know that from a regulatory point of view, the concept is that we constrain fire to a specific location. One of the other aspects with curtain walling is that you will have movement. So we're needing fire stopping that can constrain fire from spreading, but also cope with the demands on the building from a loading, mechanical, seismic movement, and settlement point of view. We move through into regulatory in the UK. The primary route for compliance is 13501 Part 2, and that leads us to the fire test standard 1364. Comes in two main flavours. You've got the Part 3, which is the full configuration, and Part 4, which is a part configuration, looking specifically at the spandrel zone. The scenario that we have currently is there's still permissible to use BS 476. We know that it's up for review currently, and we go on further in the presentation to discuss the differences between 476 and 1364. Apologies for throwing the numbers, but they will become apparent, and hopefully if there's one number you need to remember, it will be 1364. So there's been a number of movements in the industry. The 1364 standard came out in 2007. The ASFP recommended it as the primary demonstration of fire performance for perimeter joints in 2014. It was introduced into the 13830 standard by SEN in 2015. The EAD came out in 2017, and importantly, this introduced the concept of cycling of the perimeter fire stop. We have a video later on to demonstrate. Just last year, CWCT have signalled that there will be a change in their technical note 98, where currently they have permitted the 476 and 1366 standards, but as of last year, they've signalled that they will be moving to 1364 Part 4. So what are the differences in the test? What are we trying to achieve? What are the challenges with curtain walling? So the leapfrog concept is when you have a fire within a compartment, it then attacks the facade, and in a non-fire rated facade, at some point, there will be a failure. So we have breakout from inside the building to outside, and then it re-attacks the facade and potentially breaks back in. The next compartment catches, and then that can daisy chain up the building over time. So currently today, predominantly in the UK, we're still working to 476 Part 20 or its successor, 1366 Part 4. Very similar test standard number, very different test. If we move across to the right-hand side, in Europe, we are seeing fully fire-rated facades. So the entire facade is a Type B fire-resisting facade, and then we have true compartmentation from in to out. In the UK, we only have the fire stop that's been fire tested. The facade is not fire tested. So you have a compartment floor, fire stop abutting the facade. So they're the two extremes. So on the left-hand side, you've got what we're doing today. Right-hand side is the optimum, where you have full compartmentation with a protected facade. In the center, we have a compromise position effectively. So 1364 Part 4 with a protected spandrel zone. So the concept is we're trying to reduce leapfrog. So in the far right, with a fire-resisting facade, you've got that true compartmentation. Under 476, there's no protection of the facade, and breakout can occur. So 1364 Part 4 is a compromised position to reduce the leapfrog effect, to effectively buy time. So just to show what that looks like, we have our protected spandrel zone there, the perimeter fire stop at the slab edge. And we'll come on later to this movement aspect, but as that facade moves, the fire stop needs to be able to cope with that movement and not degrade and still provide the compartmentation that we need. So protected spandrel and also protected mullions. So what's the road look like? As I mentioned, came out in 2007. We started testing in 2009. 2014, I mentioned on the ASFP, brought out their guidance, and then we fast forward right to 2022, where the CWCT is signalling that change. So that's really making a difference in the industry. It's asking questions. There's a working group that's been established with the CWCT and the ASFP to look at the challenges of, okay, we have this test standard, how do we apply that to a real building? To explain more about the tests, 476 or 1366 is a static test, 2 leaves of concrete, no movement involved. There's no physical aluminium facade, so it's purely a test of the fire stop only. Doesn't look at the interface between the fire stop and the spandrel. Conversely, 1364 Part 4 contains a commercially available non-fire rated facade, and that's important to note. We've seen tests in Europe called a curtain wall test, but they are lumps of steel clad in plasterboard. They don't represent a commercially available facade. So it's important to get beneath the skin, not just hear the number, but look at the test evidence that's behind it, what's been put together in the test, and how has it been treated. So I mentioned about the EAD earlier, and under the EAD, there's movement cycling introduced. So we have 500 cycles, plus or minus 10%. And the important note here is that facade movement over time, if you have a standard fire stop with horizontal fibres, there's the potential for degradation where those fires get crushed over time and they don't fully recover. So the importance of this test, it's in the full arrangement. So there's the spandrel zone, the fire stop, the cycling occurs, and then that cycled fire stop is put through the 1364 Part 4 fire test. So it's a true demonstration of how will this fire stop perform over the life of the building if the fire were to occur on day 1 versus year 20, year 30, etc. So we've worked with a number of system partners, and that's created some great data that we can learn from. We can use that data for engineering judgments to apply to other systems. We can learn what systems are the most effective and what treatments are required and what the quantity of protection required for the spandrel zone. Just an example of some details. This is the 1364 Part 4 test. You can see the thermocouples on there that will pick up the temperature readings. So it's a test both of the fire stop itself and the spandrel. And any breakout would be a loss of integrity. So that's obviously visible flaming, holes occurring, etc. But importantly, temperature. On the fire side, we've got 1,000 degrees. On the non-fire side, we're looking for no more than a rise of 180 degrees. So it's quite a significant test and a real challenge when you have aluminium components where structural strength is being lost around 350 centigrade and a melt point of 650. So to get that through 1,000 degrees for 2 hours is a challenge. So taking those tests and then moving across to example projects. We're using an example here of the UAE where protected spandrels are actually stitched into the life safety code. So unlike the UK where protected spandrel is not mandated, over in the UAE it's written into the code, and that's been a key driver for the development of our products in relation to 1364 Part 4 testing. An example project here, and you can see the protected spandrel there, just behind. Fantastic building. So onto verification. This is third-party certification, and post-Grenfell, it's ever more evident that the importance of what's gone into the test needs to be understood. And make sure that what's being produced by a manufacturer and being supplied to the market on a daily basis is identical to what went into that fire test. So under third-party certification, there's factory audits, there's sampled material, the test is witnessed, there's ongoing follow-up service where they're looking at your quality control, and they are taking chemical fingerprinting of the materials to make sure there's no change to raw material, for example. Any change to the production process has to be notified, etc., etc. So it's about control. And when you have third-party certification, you get that confidence that what's being supplied matches what's in that test report. So we all know we've had a delay on UKCA, but that's something we're still working toward. So the message that we're trying to get across today is by working with the CWCT, we're wanting to signal a change in the UK industry in terms of curtain walling. For a long time, we've worked to the old standards, the 476, where it's perimeter seal only, and we need to move forward to look at that combination with the facade. It's the most relevant test that puts the product through the real-world demands of movement, the deflection that occurs with the facade, the deflection of the floor slab, the dynamic stresses that are going on to that product. And not all fire stopping is equal. The product that you've seen today has a vertical fibre orientation that allows for that compression, and it will recover to deliver its fire resistance performance after the cyclic movement. So the technical note is expected late summer from CWCT, and we know that that's when the real questions will start to be asked about how do we translate this test standard to a real building, and how do we deal with the challenges of the protected mullions and the protected spandrel. And that's where we look to partner with the design team and assist them, hold their hand through that process to take the certified products and then apply it to their project. Thank you.
So Graham, thank you. That's a really interesting presentation. I know it's a big topic at the moment, but to stop fire jumping from one floor to the next, what we know in North America and other parts of the world, they have a concrete perimeter beam that does that job. And then you have architectural freedom in the facade to do what you want, and you're not being restricted by having a certain depth of spandrel and stuffing it full of insulation. What's the answer? Do you think that we should be going down the path of making curtain walling restricted in terms of its appearance by having a fire-rated spandrel? Or do you think we should be actually looking at other ways of achieving the fire separation?
I think they're all great points that can be debated. The advantage of what we've shown today is that it takes existing commercially available systems, applies a lightweight, slimline protective layer to it, and provides that 2-hour performance that we've been discussing. So I think that it's for the industry to debate, but there are solutions available today to solve these issues.
Okay. The second question I have for you is, you've shown in your graphic that the insulation layer was integrated into the depth of the mullion transom system of the curtain wall. And you've shown that also with the UAE project where it's been done. We had a similar experience recently with a project in London, which I won't mention, and they opted not to play with the construction of the curtain wall. They just added a layer behind the curtain wall in the areas where they needed it. Mm-hmm. For the UAE project, were you able to do a project-specific test to demonstrate compliance? How do you demonstrate compliance?
We've tested both arrangements, so we've had protective fireboard on the face of the mullions, and we've had it inset. So we have test evidence within our library for both arrangements.
But every curtain wall, as we know, is different. Are you then going down the line where you're asking for project-specific tests?
Within the 1364 Part 4 test standard, there's direct application guidelines to show the range, so the mullion spacing, depth of mullions, and what you can work within. There is extended application guidelines for how far you can go with that existing test, and then beyond that, it's engineering judgment. So under the draft new technical note from CWCT, that's the tiered approach.
Yeah.
Direct application from the test standard, extended application to show how far you can go, the series of rules to say you can extend this dimension, you can reduce this dimension, etc., what you can and can't do. And then beyond that, it's into engineering judgment. So we do see project-specific tests. Generally, we'll look to the library initially to say, what's the closest match we have? Can we hit the performance that we need within the XAP guidelines, or do we need to go project-specific?
Great. Wonderful. Thank you for explaining that so beautifully. And we look forward to the CWCT note as well, because I think there's going to be a lot of debate around this in the months and years to come, I'm sure. But thank you for today.
Okay.
We're going to be glad to hear we're going to coffee break now. If we can be back 11. So welcome back. Hope you enjoyed your coffee break. Earlier this morning, in Dav's presentation, he gave us a little hint of what might be coming in Birmingham in the next 20 years. We're going to hear a lot more about that now from Simon Delahunty-Forrest, who is Assistant Director for Planning and Development in Birmingham. And he's going to talk to us about what the city might look like in 20 years' time.
Thank you. Cheers. Thank you very much for the invite. I presume you can hear me, yeah? Yeah, cool. This is a bit weird. I've never had such a big screen as this before. It's pretty good. Yeah, my name's Simon Delahunty-Forrest, as introduced. I'm not a planner. I'm an architect. So it's quite interesting. You might think that an architect manages and runs a planning department, Birmingham City Council. But it's really good because it allows that creativity to come through, and sort of creativity you guys, the presenters earlier, were talking about in terms of cold bridging and thermal stuff. It took me right back, to be honest. So my role in the city, I've been with Birmingham City Council, man and boy, out of school. I was either going to go on the tools, and the only O level I got was art, and Birmingham took me on, and Birmingham put me through the system, 9 years part-time study. So I owe a lot to Birmingham. And I'm in a really, privileged position to actually form how the city's going to grow and how you guys can do what you do. I miss Dav's thing, but I've known Dav a long, long time, worked with him, and Dav's been part of this partnership going forward with our future city plan. But look, I'm going to give you death by PowerPoint. There's a shed load of stuff to show you in a very short amount of time. And I don't shut up, and I don't like that clock. But anyway, let's crack on. The City of Growth, look, let's just give you a bit of background about this place. It's a fantastic city. And you've got Ian Simpson in the room here, and it's a damn sight better than bloody Manchester. Right, damn sight lot better, and Liverpool, but we'll come back to that in a minute. But look, we need to build a shed load of homes, 150 of them, and we need to make them affordable, okay? We've got to do that. And we are in the process of reviewing our local plan in 2026, which is the stick that sort of makes them things happen. And we've got to be net zero by 2030, and you know all about that. So with the City of Connections as well, on that piece there as well, which is important. I can't see my screen. I don't know what's happened. Let's go back. Here we go. So we are the best connected city. 850,000 people, 30 minutes from the city centre. That's pretty incredible. We are compact, really tight. And 9% of the UK is within a 4-hour drive to our fantastic city. And with the third largest airport outside London, and the big game changer is high speed too. Love it or hate it, it is the big game changer, and it's built confidence in our city. And we're a city of talent. We're the youngest European city. 36% under 25. Super diverse. And that's one of the big things. Really pushes to get our diverse communities into our world. It's not happening enough. A lot of our diverse communities the built environment's not on their radar from either laying a brick or doing what I do on that. And we've got to change that because we have a shed load of students come here. We need to keep them students in our city, and we are the most populous city outside London, and I'm going to say that. So we got started, enterprise, you go to Digbeth, Jewellery Quarter, Gun Quarter, it's all happening there, small SMEs, there's a massive demand for grade A office. COVID, when that came, we thought, oh no, the world's going to be different, working at home, smaller office space. No, it's going to be a hybrid of that. It's what that office space is like, what that environment's like, and how you want to work. And we have £1 billion towards our enterprise zone, which is transforming the city as we speak. So how do we reshape Birmingham? Okay, well, we go on a journey, but Birmingham, its motto, forward, its coat of arms, it never stops still. It is always going forward. And this slide here shows the great things it's done, from the ICC through to the ball ring, to the redevelopment of the rotunda and the library. We always do good stuff. And the big city plan, you heard of the big city plan? Yeah, the architects in the room do. Yeah. This did exactly what it said on the tin. It's the 5 areas of transformation. Back in 2010, it was a master plan for growth, and it did all the right things. And one of them was here, Paradise before, and some of you will remember what that looked like, and that's what it looks like now. We feel like a European city. We feel like a global city now. The quality of the build, the quality of the public realm is really, really important. But the challenge is, how do I make those communities that are 15 minutes, and sorry I've used that word 15 minutes, outside the city, to come and make our city centre relevant? And that's part of it. And then we've got the golden decade. The leader of the council, Ian Ward, talks about the golden decade, and that golden decade started with that, the Commonwealth Games. Put Birmingham well and truly on the map, well and truly. Brummies came out of the woodwork, who'd never gone into the city centre, and loved their city, embraced their city, which is, fantastic. And people from all over the country came, and all over the world. It put us on the map. So, what are our challenges? You'll know about these challenges. The climate emergency, transport problem we've got at the moment. Been accused of demonising the car. Well, you think back to, heroes in the past of the 60s. Manzoni, did he do the right thing? He based our city on the American city. We're repairing that now. We're changing all that. Levelling up, we are the third most deprived core city in the UK. That's pretty bad news, that is. And we've got to change that. More than 40% of children live in relative poverty. That's pretty shocking. And I have to say that, I'm a civil servant, I work for Birmingham, local government officer, and that's on my watch. And we need to change that. We need to get them kids into our world, which is really important. And then, people are living in temporary accommodation. I've said earlier, we're not building enough homes. We need to build them quicker. That connectivity, do some public transport, metro, bus. It's got to be good. It's got to be quality to get people on them. So the opportunities are, we need to be that global leader in that green economy. We need to be bold about Birmingham. 100 languages in this city. Foreign investment, when they come to Birmingham and talk to us about coming to our city, they know more about Birmingham than I'll ever know. They know about the different cultures. They know about the heroes, both past, present, and the ones that are going to be the future. And some of you in this room are going to be that. Some of you are a bit past it, but don't worry about it. And then it'll be about centrally connected. Like I said, we've got the high speed too, which is, is a game changer. So where have we been? What have we been doing since 2019? Well, we had this idea. The Big City Plan did exactly what it needed to do, that 10-year vision. We had an idea in 2019 when we were all getting ready to sit behind our virtual world about where does the city need to be in the next 20 years. So rather than what we did with the Big City Plan, which was sit in a room, lock ourselves away for 2 years, and come out and go, there you are, get on with it. This time we went, actually, what do you want to do? What is it that makes your world tick? What makes your friends' and families' world tick? Businesses and that. So we went out with what we call Shaping Our City and asked the question, from community groups to developers, consultants, what is it? So we gathered all that and we commissioned Arcadis to get all that information because, we are a local authority. We haven't got all that skill set in-house to help us do that, to bring all that together along with Glen Howells Architects. And this time next week, We will have launched our Future City Framework 2014 UK Reef. It'd be great if you can go there and you'll see that document and the opportunity. Now, I'm under an embargo. I can't show you anything, but I might. We'll see where we go. We'll see where we go. There's no heckling at the moment, so I think all right, so we'll carry on. But through that framework, and that's the umbrella, that vision for 20 years, there's then going to be bespoke pieces of work. Oh, I wanted to use this. I was really impressed with it. Oh, look at that. Yeah, all these things are going to come out. I've got to get one of them. So be SPDs and all that, a bit of a stick, not to beat you with, but to help you to deliver what we've got in our heads, where we want to go. So our Future City Plan said we went out, but you've got to start somewhere. You talk about innovation, you talk about being distinctive, and you talk about being unique. They're the key components. You've got to start somewhere. And the one thing I really like is the fact that, embracing technology, creativity, beauty, and imagination. They're really nice words. And they're important because we all understand them. We all understand what we like, what we don't like, what we watch. It's really important to tap into that because planning is not just black and white. It can't be. It's got to be them things. So me fronting up planning has allowed me to do them things, get planners to think a bit differently. So we had to start on a few principles, and it's going to be about green, equitable, livable, and distinctive. Got to start somewhere. So they were the headlines that went out there. Nothing more than that. But this is the exciting bit. What we did go out with was this lovely image here. This is the city centre in the middle. Now, the big city plan, when you have a look at it, did that. It was all about inward looking. What we wanted to do was actually go, hold on, let's stop. The wealth, the benefit, the opportunities that comes out of that middle bit there needs to be spread that way, that way, that way. Oops. It's really important to do that. So this is on a massive scale, what we're proposing here. It's massive. It's not been seen at this scale, in Europe, let alone this country. It is massive. And you might think I was just saying that, but I'll show you in a minute on there. So that ring road is something that we need to deal with before we deal with all these areas here. So, part of that, there's these themes that run through it. The city of centres, about healthy living zones. There's that 15-minute neighbourhood for the conspiracy theorists in the room. Growth for all. It has to be. It's got to be for everybody. For them kids, as I said, in relative poverty, it's got to be for everybody. And it's easier said than done. The city of nature, really big thing as well. How do we capitalise on the green infrastructure we've already got? Do we repurpose it? And how do we then complement it? And we've been brave about some of our green space, because a lot of our green space in the city, people don't go to. And they don't go to it because it's not overlooked. Crime's there, drugs, whatever. So we're saying, build on it. Front it up. Make that green space more usable, that people want to engage and use. However, we'll offset that by putting green space elsewhere. And we need partners to do that. City of Layers is the big baby for me. I really love this one. How we promote our history, our diversity, and I'll come back to that in a minute. The connections for the transport engineers in the room, if there's any, and knowledge and innovation. How do we keep all them kids that come here and learn? How do we stop them buggering off back to London and elsewhere? Well, we've got to provide them the opportunity for growth in terms of homes and also job opportunity there as well. So, the city moving forward. That's ticking down quick. So our past, you've got to understand our past before we understand where we think our future's going to be. And this is really, really interesting. You go on that journey, and I won't read these, you can see them in the document. But Birmingham was the superpower back then. It was the superpower. It's the city of 1,000 trades. It's where we built stuff, made stuff, imported, exported, did it all. But what's really interesting is about then how the population changed, how we were focused in the city centre. All them years ago, 1850, but then urban sprawl. Let's use this tool again. Urban sprawl started to happen, which is really interesting. So people were moving out. So, post-war planning, 12,500 per person, kilometre squared. Really intense. Hybrid initiative back in the 80s with the big city plan, 2010. You can see what's happening, 9,000. It's changing. People, how they want to live, how they want to work, it's changing. Central Birmingham, which is now 7,000. So we're moving out. We have to ask the question why, and is that the right thing to do? And when you compare it to what's going on in Europe and overseas, we haven't put the American stuff on there, but you can see we're well off Geneva, Barcelona, Brussels. You know, if we really want to be a global city, we need to be looking at these guys and what they're doing and how they're doing it. This is really cool drawing. A Nolly plan for those urban designers in the room, the architects. They're all at the same scale. Now, you can see with all of them, the development in terms of how much is coloured in black. All right, the green, the blue, and the white. Green infrastructure, blue infrastructure, roads, car parks, etc. Look at Birmingham. There's more white than black. So there's a massive opportunity there to change density. How do we increase density in them opportunities in the city? So we've got to be bold if we're going to do that. So this is our framework. You're going to be seeing the Raging Bull more and more often, coming out and doing his thing. He'll be in Grand Central soon. But we have to be, you know, if we're going to operate on that global scale, you know, it's about prosperity shared by all, distinctive, inclusive, creative, resilient and connected. So what does that mean? Well, our central areas is what we're calling them, our neighbourhoods. There's the city centre. Well, it's a lot smaller than that. So what we're calling that city heart, and then we have these central growth areas around it. So central north, central west, east and south. That's the scale of ambition where we want to try to change. That's the scale of ambition where we're going to be building on them white pieces of open space, where we're going to be building on some green space, where we're going to be adding new green space. And it's like a jigsaw, because when you see the document, you'll see that it all connects together. It links together. There's walking routes, there's cycling routes on that development and the public realm. And density is not at the cost of the public realm. Public realm is really important. If anything, architects should be doing public realm first and then the buildings that fit in them. That's my view. That's what should come first, not the other way around. It's like architects doing a building, then the mechanical engineer coming on and sticking that blinking box on it. Got to think a bit differently. The speakers earlier were talking about how you think differently about things, and we need to do that in terms of planning. So you can see the scale of ambition here. There's a sneak peek. No photographs. But we're calling these the greenways. You'll see a much more rendered up vision on that. That ring road, which is that barrier, which is that thing that goes all the way around. So you've got high speed 2 there. You've got the ball ring here. What we're doing is we're turning that ring road over to green infrastructure. It will be Birmingham's park. It's a massive move. It's a bold move. But when we've done sneak peeks and we talk to investors and developers, they totally get this. They totally get it because it's where the world's going. So when you come out of high speed 2 and come into our city, you'll come into a green oasis. And that might be all sorts of different things, rain gardens, play areas, who knows? Well, we do know because Arcadis and Glen Howells have done all the detail behind this. We know we can deliver it. It's going to be over a period of time. And we've looked at best practice, Boston Big Dig in the States. They're on this journey. They're doing this already. Lancaster in the States, they're doing it. They're starting. The car is going there. You're still going to have to get access in, deliveries, etc. And there's been the debate about, electric cars. Well, not everyone can afford an electric car. You've got to do things very different. So you can see the ambition there. And what this also means is that if the highway is going to shrink as well, we've got more development plots. There's opportunity. So there's a bit of a carrot for people as well to help us do that, because the council can't do that. We're going to need people like you to help us do it. But it's pretty mental, really, that is. And then part of that greenway thing is that you've got these strands that are coming off. And this is already happening with Hagley Road, Calthorpe, we work very much with them. What we did, as I said at the start, with Shaping Our City, we work with people. So Calthorpe, massive landowner, we work with them. They've bought into our vision, and this is what they want to do on this. You know, and that will be the Greenway, more green infrastructure leading right into the city centre just up there, decent public transport and affordable homes. This block's been built now, and it's doing what it needs to do in terms of that affordability. And then Park Birmingham. You all recognise that building? Rotunda. This is the High Street. Okay? We're doubling the width of the High Street. We had our first developers sounding board yesterday, where all the landowners came in and sat with us because they've bought into this. They get it. They want a Parkside address rather than High Street. So this is really, really exciting. And they're the only ones that can help us deliver this. This is out of date. You'll see that in the new document it's got it because we've knocked down Primark. We shouldn't have done that. But anyway, it will come back. And there you go. There's a vision of Park Birmingham. And you can see the carrots. The carrots are poking up, you know. And they've got to be green buildings. You know, there's the Hammerson's master plan, Station Square here, the new Odeon going in there. What was really good about the feedback about that from the people was the park's not big enough. It needs to be bigger. So our park is doing that, widening. We're consolidating all this bit here because if our partners are going to take some pain, we need to take some pain. So we're consolidating all that together to deliver that vision. So these are things I'm interested in as well. Talked about. We're the 20th biggest landowner in this country. We've got a shed load of land. And what we've done in the past is gone for sale, put a red line around it, highest bidder, great, take your money in the bank, done deal. We can't do that anymore. We just can't. Because you'll go around the city and you'll see some of our sites we've sold and they're still sitting there with hoarding round. We need to be partnering with people because if we're going to spread that opportunity, where it happens in the city centre, I can then move that opportunity into them other growth areas I showed you earlier. So we're changing our mindset on that. We're going to work with partners to develop that. The other bit, talk about our city. You know, support them young companies that are coming in. Guy from Leeds is doing this. Came to Birmingham, didn't know what he was going to do. Guy called Provide, his company, fell in love with Birmingham. His whole clothing range, and he's a brilliant entrepreneur, doing really well. It's all around Birmingham, that thing. And then, of course, the other man who's put us on the map, Mr. Shelby. It's amazing what TV can do. I was in London not long ago, did one of these things, had an orderly queue afterwards thinking I want to talk about OFC, and they wanted me to introduce them to the Peaky Blinders. I said, they don't exist. They used to, and if they still exist, you wouldn't want to meet them. And then this one here, where are you from? This is a slide from the Home of Metal exhibition in Birmingham just before COVID to celebrate the godfathers of heavy metal, Black Sabbath. Now, if it's Manchester, you know, I keep on hearing, sorry about this, but I keep on hearing on about Hacienda, Oasis, Happy Mondays. These guys changed the blinking world. So how do you capitalise on it? And when I go to Liverpool, I told Liverpool that the beach scene started in Birmingham. It started here, it didn't start in Liverpool, it started here. So we need to capitalise on them things, not reinvent them. But what's great is that thing was about as big as this. They asked the people that visited the exhibition, put on where you come from. So if we're getting people coming from all over the world to our great city to celebrate a heavy metal band and what they did globally, how do I capture them? How do I get them to stop here, to experience other stuff? How do I get them to go on the Stratford Road? Places like that. So that's really important. It's a really powerful slide. And of course, the next steps. I'm going to have 7 minutes to spare here. I can't believe this. So we launch Tuesday. And we're doing a very different launch. We're going to make sure that people, when they leave that room, they know they've had an experience, because we are going to celebrate all the things we talked about today. So we've commissioned a few films. We've got a poet who's done a love letter from Birmingham. So if you're there, please come along and see us. If you can't, download the document. It'll be all out there. If you can't get to that one, come back to Brum. We're doing a local launch on the 25th of the same month, probably Highbury Hall or Cannon Hill. Going to be very much a family affair, because what I've showed you then, I've only given you a tiny, tiny snapshot, but I'm hoping that you get it, is that nothing's been seen at this scale for over 100 years in Birmingham. You know, you're in Joseph Chamberlain territory here. This is, you know, a game changer. You know, this is real legacy. And this is not about me and my ego. It's not about that at all. You know, like I said, I've been here man and boy. I'm here to serve the good people of Birmingham because they saw something in me, and I took that opportunity, and I want to give them people them opportunities. And the only way to do it is to spread that love and that opportunity. So we're going to engage. So we've got 8 weeks to engage. So what I really would ask you to do, get that document, look at it, and come back to us. Tell us you either hate it, you love it, have you thought of this, have you thought of that. We won't take it personally. We want to listen. We want to listen. We want our document for the next 20 years to be fit for purpose, not something that's just sitting on a shelf. So it's really important. And through, you know, the good people, Zak here today, you know, we can get that link through. So on that. So that's me. Birmingham forever.
Thank you very much, Simon.
No problem.
The Birmingham passion shone through that. Thank you. And you're ahead of schedule, which
Can't
is
believe
great.
that.
Fantastic. Simon will be here
I will, yep.
over lunch, so please feel free to grab him and talk to him if you have any feedback or if you have any questions for him. I personally don't have any.
It's fine.
So thank you again, Simon.
No, thank you. Cheers.
So the next presentation is actually by myself and by my colleague Stefan, who is with me here. Oh yeah, it's coming. So we heard a little bit this morning about prefabrication, and it's something that we are passionate about at Schüco. We put a lot of effort into it, and I would say undoubtedly still today, even though we've had unitized facades for quite a long time already, the state-of-the-art in reliable facade construction remains the unitized facade. And in this presentation today, myself and my colleague Stefan will show you 2 examples of turnkey facades, one office and one residential. Both will demonstrate the quality and sustainability of this form of construction. I also want to show that having access at early stage to the right know-how is very fundamental to deliver the quality aesthetically, as well as in terms of defining the budget correctly from the beginning and setting the standard for the project. So the unitized facade is built one piece at a time, and each piece embodies all the performance characteristics that are needed within it. The possibility to build something in a factory environment to a fine tolerance and to a high quality and bring it onto site and fix it in 15 minutes is a chance we should capitalize on. Of course, the possibility exists to make all manner of shapes and sizes. Here you see a typical prefabricated corner piece, or in this case, a rather humongous 8-meter by 3-meter trapezoidal piece with a round window in it. Prefabrication gives us the possibility to produce stuff in a good timeline, off-site, in a controlled environment, and store it, and bring it to site just when we need it. This gives us massive flexibility in terms of time and program on site. So I'm going to use this building here, which you've seen already on quite a few pictures this morning, as an example of an office building. And this was completed recently in the center of Birmingham, in Paradise Circus. It's a great study of collaborative work between the architect, which in this case is Eric Parry, the system provider, who's Schüco, and the facade contractor, in this case, Inasus. The building is really like a finely tailored suit. Has vertical terracotta features which are self-supporting from first floor level up to parapet and are simply restrained to the facade every floor level. Facade elements were prefabricated in Inasus's factory in Spain and brought to site and hung from the building in the traditional manner for unitized facades. Early engagement was a part that we went through with the architect from March 2016. And we developed the facade concept of using story-high elements, in this case 1.5, the classic 1.5 module for office buildings, and integrate all the architectural features within it. You can see the key diagram at the bottom right, where the plan shape of the building is shown. This presented a few challenges in terms of evolving a system that can cope with a straight geometry and then can have a reverse convex radius and a tight concave radius integrated in it. So there's different types within one floor plate. You see here in a bit more detail how we can do that. In this case, we're taking quite strong advantage of having this strong architectural feature, the terracotta column in front of the mullions, that we can open and close the mullions without having an impact visually from outside. And instead being able to use a standard system or a standard system with square cut mullions and transoms and accommodate the facet by having bent vertical gaskets within the system. So here you see the typical slab edge detail or vertical section at the slab edge, nothing extraordinary here, a standard type of unitized construction. You see here a bit more detail, the restraint connector for the vertical terracotta features, and I should give NBK a mention here because NBK supplied the terracotta for this project. And here the connector has a vertically slotted hole that allows the facade units to move differentially different to the vertical terracotta, which is supported, as I said, from level 1 to the parapet on its own central support. These are the vertical sections at parapet level and at first floor level, and you see here the horizontal terracotta feature which frames the facade. This slide gives you a quick overview on what is possible to accommodate movement-wise. In this case, we had to take movements of 18 millimeters downward deflection and plus 11 millimeters potentially opening up of joints. And that's quite normal range of movement for this type of construction. And finally, a quick 3D rendering that we normally produce as part of our design concept submissions that we develop with architects at the very early stage. And you can see the date there is June 2016. I hope that most of you will appreciate that this type of collaborative work represents a major de-risk for the project and allows the architect, the quantity surveyor, the general contractors to go out to market and get meaningful prices for the work based on near-finished facade system design. And this point, I think, is well illustrated with this image. When you look at the concept drawing from 2016 on the left, and the final construction detail from Inasus 3 years later, it's identical bar the shape of the terracotta. So I want to move a little bit to talk about how we can collaborate more with you as a system provider and to how we can bring project-specific solutions to the table. Most of you know us as a market leader in all systems, in all these product segments. But some of you may not be aware that we offer a lot more than that. Our colleagues in the architectural support teams, the APMs, and our PCS team are available to engage from the earlier stages, REBA stage 1 or 2, to help you achieve realistic facade design. The PCS team especially is dedicated to support large or complex projects. But in combination with our APM colleagues, we can support any project, so please feel free to reach out to us with any inquiry. Our service is tailored to your project and is supported with CAD drawings, thermal calculations, structural appraisals, renderings, acoustic data, and much more. We always start by sketching the ideas at the very early stage, maybe stage 1 or 2 of a project, and we're available to attend design meetings in person or online to evolve the design and bring the necessary know-how to the table at the right time. When the design parameters are condensed, and this is usually around planning submission time, we can develop the facade concept document. And this can then be also supported by early budget pricing by fabricators who can offer indicative or market test prices for the product. And this gives all the stakeholders a clear view of what to expect. At tender stage, we can further refine the design concept into contractor-specific proposal, and we work with companies such as Inasus to help deliver all the objectives of the project. Another important aspect is matching the right project with the right contractor. And as we always know, as project value goes up and technical complexity increases, the number of operators that can deliver a given project reduces. So it's important to know what is possible and who can do what in the marketplace. And we do that by having close link with a large number of facade contractors, many of whom are in the room today. So my final slide before I hand over to my colleague Stefan is just to give you a quick view on the faces that you can expect to connect with. Now, I personally am available. I love traveling out of, I live between Birmingham and London anyway, so please reach out to me, but also to my other colleagues that you see on screen here. So now I will hand over to Stefan to take us through the second case study.
Thank you, Stephen. Really good. Well, this is going to be one of these pockets about sustainability, but I think it's important, and mine will be a very short presentation because I want to give you a particular message. And the message is that we're not essentially building as well as we could. I believe that there are certain things that we are neglecting or that we're not working hard enough in order to make our buildings better and more sustainable. And we know that for some time now, embodied carbon has been the focus of the sustainability topic, because by reducing U values and improving our envelopes, the focus has shifted from operational carbon to embodied carbon. And with having said that, a lot of people just focus on using as much recycled aluminium as they can. We can do that, and we should be doing this, but doing only this is lazy. We need to be doing more, so we need to be looking at the whole spectrum of things that we can do, because recycled aluminium is only one small part of the whole puzzle. There are many other things that if we just purely focus on this quick little thing that we do, we're going to neglect, and ultimately that is not going to be very good for our building. And at Schüco, we have, at the BAU exhibition, we launched our current program called Carbon Control. And essentially what it is, it's a holistic approach. So when we get to look at a building at an early stage, like Stephen suggested, we want to look at all of these things. So that's our starting point. We don't only want to look at the material. We are still very much interested in the operational carbon, but we're also interested in how we can design the building to make it better, to utilize our materials in the best way that we can. So with having said that, our message today is really about this, and I'm doing this with one particular example, and every building is going to be a little bit different. So in some, we can do things to reduce the amount of aluminium that we use. by various methods. In some buildings, it's very good if we use very large units because we get the economy of scale. Material is more efficient when we have larger units. In other cases, like what I'm going to show you now, we can use external features to actually make the facade lighter and having less aluminium and therefore less embodied carbon. So that is the case here. I'm just showing you a good example of a contemporary building in Birmingham, and in buildings today, similar to what Stephen showed as well, we have various features. We have external cladding, we have fins, we have sun shading, we have all of these things. It's very rare now that we have a fully glazed facade. So when we have an elevation like this, which you can see it's fairly typical elevation, you've got some opaque areas, you've got some windows, and you've got glazing. And usually, when you look at a typical section, it's very easy to kind of automatically, by default, just do, okay, a unitized system, and then with a little bit of decoration in the front. And we've done that very, very often, but that is not necessarily the best approach, because when you look at it purely from a very fundamental first principle point of view, you can see that you have a unitized carcass, and then you're attaching something to it. By attaching something to it, you get the external actions, so you've got your wind load that you always have. Also on these projecting fins, you will, due to their exposure, you will have some additional loads that come from their orientation and how they're placed on the facade. And ultimately, all of this has to be borne by the unit frame. So that results in some structural challenges. So every time that we have such features, they always result in an increased material consumption. And I'm not very proud to show you this. I designed this facade, and when we have these fins, to bear the loads from them, we need a very substantial frame behind them. And only 3 or 4 years ago, this was considered fairly normal. But now, when we're counting every gram, looking at this picture kind of makes you go pale a little bit, because such a lump of metal in this facade, it's a little bit too much. So whilst it may be quite intuitive and easy to actually come to that conclusion, I still want to vocalize it and to say it to you. When we have such facades, we should always try and think about other ways to do it. When we have these external fins, when we have these external features, why don't we flip the facade around? Why don't we use a window-based system? Essentially, instead of having the unitized carcass that supports something, and that something imposes loads on the unitized carcass, therefore making it heavier, why don't we just flip things around and say, well, why do we need this stuff in the back? Why don't we just utilize the external feature as the structural bit and do a window-based unitized system? Can that have any effect? And essentially, this example that I'm showing you is from a building in Birmingham called Exchange Square. Architects were Stevenson, Hamilton, and Risley, and Fleetwood is building the facade. You can see here that we are using a window-based unitized, so essentially we have all the functionality of a window system. It's got the thermal breaks and the U-value performance with regards to operational carbon, but the structural bit is placed on the outside because we have these external features. There was, of course, some project-specific details around the opaque zones and all of that, but the the core message is that instead of having a big unitized carcass with a bit on the front, we're just having the bit of on the front, and we're just using it structurally. So if you make a very quick, I'm sorry, I just need to go back here. If you make a very quick calculation, you can actually demonstrate that for this type of facades, you can decrease the usage of aluminium by 40–50%, and that's just by design. So even if you are using recycled aluminium, which is all well and good, you should still do this, because this just goes further. And here is some drone footage from that building, kindly provided by Fleetwood Aluminium. And you can see it looks very, very good in terms of the unitized envelope. It hasn't suffered from what we did, and inadvertently we have saved a lot of embodied carbon by building the facade the way we did. And I missed your video, I think.
I think we have time to show it. Just go back one slide.
Okay.
That's it. So this is a quick video, drone footage as well of Paradise Circus. You'll see the city is a little bit different. This was done about 2 years ago, before the building was finished. And it also capitalizes on what Simon was telling us, that the city is really changing. So I think in that video you saw that the site for Paradise Circus number 3, which is currently under construction, and that will also be another project with our partner Inasus. Stefan and I are available for question. My colleagues at the stand are also there, so please reach out to us and ask us any questions if anybody has a topic to discuss. Thank you. So without further ado, we'll move on to our next presentation before we have our panel discussion. Really delighted that Frances came from London today to join us. Frances Gannon is a partner at Make Architects in London. We all know that Ken Shuttleworth has a strong connection with Birmingham, and the practice over the years has had a strong connection with Birmingham. So we're looking forward to hear what you're going to show us.
Thank you.
Let's see what you're going to show.
I'm Frances from Make Architects. Make was founded about 19 years ago, and I've been at Make for almost all of that time. And as Stephen has said, Ken, our founder, is Birmingham born and bred, so this is a city that's really close to our hearts. So I'm really pleased to be asked to speak here at the first Birmingham Zak conference. I'm also the first woman to speak on this stage today, and it's almost lunchtime, so please look around you. Next time you go to a conference, please maybe suggest some of your female colleagues come too. That would be really nice. So over the years, we've designed a lot of projects in Birmingham. And if you'll permit me a bit of nostalgia, I wanted to go through our greatest hits and think about how we design facades of the future by interrogating our designs of the past. It's easy to say that we should interrogate everything we do through a climate emergency lens. And I think, as Simon said, it's a climate, biodiversity, and social justice emergency. It's so complex and so enormous. It is a lot. So I find it helpful to break things down. So I've brought with me today 3 pairs of goggles, and they each have a very particular lens. My first is operational energy goggles. I've had these for a long time. I think a lot of architects have. These are very dark sunglasses for looking at energy. We prioritize energy. We think about facade performance, all about energy, and we've been using these for a long time. One of Make's founding principles is the death of the glass box, avoiding too much glass, too much solar gain, adding more insulation. It's one of our founding sort of starting points for all our facade design. My second pair of goggles is my embodied carbon goggles. And these were given to me in 2020 by Helen Hare of GPE. I should think a few people in the room know Helen Hare. She's an amazing project leader, and she always asks the difficult questions. So in 2020, I was presenting some facade options to her, and she said, "What's the difference in embodied carbon between the options?" And I didn't know. I hated that. I felt awful. I felt very challenged. And I felt very shocked at myself. Why don't I know? All of a sudden, I thought, I need to know this. I'm an architect. This is quite fundamental. So that set me on a journey of learning, doing loads of learning, loads of researching, talking to loads of very brilliant people, some of whom are in the room today. And once I felt confident that I had learned the basics, I went back to Helen Hare and I talked her through everything that I'd learned. I told her the difference in embodied carbon between the options. And she said to me, "Now you've put your embodied carbon goggles on, you will not be able to take them off." And it's completely true. Once you've got your embodied carbon goggles on, it changes everything that you see, and it's overwhelming, as Stefan was saying. The amount of energy and resources that go into our buildings and our facades is staggering. And at first, it's a bit sickening. As you were saying, it's a bit uncomfortable. But the way through that is to believe that buildings are worth it. Buildings are the solutions. Buildings are the way forward. And great buildings can give us hope that there were ways out of this situation. You might be wondering what my embodied carbon goggles look like. They are made out of wood, of course, English ash, which means they're a bit chunky, and then it's difficult to get my operational energy sunglasses on over the top. And I think that's a struggle that we have on every project. How do you balance upfront embodied carbon now with operational performance later? Is it right to spend carbon now to save energy later? And on every project, we have to tackle that problem afresh. We have to use our most agile thinking as we learn more, as the grid decarbonises, as new technology comes around. We've got to rethink that balance every time. No one knows the right answer. We've got to be agile and brave and thoughtful on every project. My final pair of goggles I've brought today are my circular economy goggles. These are circular. And they're second-hand, of course. And they are wide angle, because the circular economy is everything. It's the way we do everything, the way we source everything, the way we put everything together, the way we use things. It's everything. And so it's a very exciting pair of goggles. So, armed with these 3 pairs of goggles, let's go back to 2005 and our design for the Cube. This is a building that's just down the canal, 3-4 minutes walk. So if you want some fresh air at lunchtime, it's quite nice to walk out the lower doors here and wander along the canal, and you will see the Cube in front of you. I will start by saying that this is not a low-carbon building by any stretch, but what it is is different. It was different in 2005, and it's still different now. And we talk a lot about challenging business as usual, and I think this is a good example of that. The business as usual solution for a big building on this site would have been a tower, and we would have used words like elegant and sleek. And we designed the cube, which you would say is boxy and chunky and strange. And that is, and always has been, a challenge to business as usual. This was designed with our dark energy sunglasses on. This is all about operational energy, death of the blast blocks, lots of solidity in the facade. And it's a true mixed-use building. So we've got car parking, retail, restaurants, offices, 250 apartments, a hotel, some of you are staying there tonight, and the Sky Bar at the top. And what we wanted to do was to build a long-life, loose-fit community that had some flex in it. So already the demand for the retail units has been decreasing. The demand for office has been increasing. So at this, the level in between has actually already changed from retail to office. And we designed in that flexibility and the lifting strategy and the floor-to-floor heights so that the office could expand down into that zone. Also at the top, we can blur potentially in the future between the hotel and the resi, that we can open things up to make serviced apartments or expand the hotel. So by designing in a bit of flexibility, hopefully this will be a long life asset for the city. It's also the plant strategy is about making use of all those different uses and their different demands. So we have one plant building that serves all these different uses. So when the office workers go home and the people in the apartments come back, we're making the use of the efficiencies of that 24-hour building. And the job of the facade is unifying all those different uses and complexity with one very strong sort of image and personality to unify the community of the building. Excuse me. These are not makes photos. These are the photographs taken by people of Birmingham over the last 13 years since it's finished. And I think what people really respond to in this facade is the strength. You can love it or hate it. It's different, it's eye-catching, and people feel something about it. They have a reaction to it. And you can see in these beautiful photographs, mostly from Twitter and Instagram, that everybody who comes and looks at this building, they have their own lens, they have their own goggles, their own values, they make their own choices, and it's lovely that a building sort of soaks all of this up and makes it part of its personality. The cube has also become a sort of iconic part of the city's culture. It's on a tea towel that celebrates this wonderful city. There it is in the middle. Graphic designers love it. It's become a tote bag. You can buy this as your memory of Birmingham. It features in this amazing oil painting, this is in the Royal Academy, of a modern-day Tower of Babel, crowned by the spiky roof of the cube. And then that was used on this cover of this dystopian novel. So I think a strong building and a strong personality becomes kind of an asset and part of the city beyond itself. Most satisfying as an architect, it's been built in Lego at Birmingham's Legoland. So I think in terms of engaging the younger generations in the built environment, things like this are just absolutely fantastic. But I put my embodied carbon goggles on. How do we feel about all this aluminium? I'm so glad I'm following Stefan because it's exactly the same message. Aluminium is really difficult. As I said, with my operational goggles on, it looks good. We've got plenty of solidity. We've got good insulation, cutting out solar gains. Circular-wise, aluminium is a sort of infinitely recyclable material. This sort of kit of parts approach means you can easily switch out parts of it. You can upgrade it. It's easy to demount. But we're stuck with this upfront embodied carbon problem. Whether we talk about recycled aluminium, as you just have, low-carbon aluminium, there's just not enough of those to go around. The global demand for aluminium means we just are still producing a lot of virgin aluminium. And producing virgin aluminium means mining for bauxite, digging up rainforests, relocating indigenous communities. This is the real impact of us covering everything in curtain walls as, you know, the way we've always done things. So for all its circularity and all the technical, you know, we put our faith in high-tech solutions, we just have to reduce the amount of aluminium we are using now, today, on everything. So the next project, 1 Centenary Square for HSBC, is a building, a facade that uses much less aluminium. It uses masonry because it's fronting onto Centenary Square, which is just at the front door of the ICC. You probably walked through on your way here. So the beautiful Edwardian buildings, we wanted to pick up on that masonry detailing. And the weaving pattern is looking at another way of introducing that solidity in the facade to break down the idea of a glass box. It's flat on the north and the east elevations, and then in the south and the west it starts to ripple, and we're picking up the light and the shadow and giving a bit of shading to those windows. So looking okay with my operational energy goggles on. However, when we come to the western elevation, I just, in hindsight, think we could have woven in another layer to take out those floor-to-ceiling windows where we're getting those solar gains in the bottom. We're not getting any useful daylight. And I think that would have just enriched the facade. So this was designed 10 years ago, and obviously we did some solar analysis then. We're just doing more and more on every project. The technology is, you know, the sophistication of that analysis is just ever increasing and brilliant, but we need to make sure we've got the time to do that really thoroughly at the start of every project. We need time and we need the fees to do that. We need early engagement with contractors. We need to make sure that the first moves before we go to planning are absolutely as fine-tuned and optimized as they can be. So our next project no, actually, I haven't used all my goggles. So we've talked about operational goggles. Embodied carbon goggles, this is GRC on an SFS backing wall. So it's a window wall arrangement, so that's using much less aluminium. I kind of wish that the windows could have been timber-framed windows, and then we would have cut out a load more aluminium. And it's interesting to think that what that window wall does with the circular economy goggles on, because the wall is built up more complexly. We heard about membranes earlier, you know, membrane being bonded to a sheathing board. It's very difficult to take apart in the future. It's a different approach. But I think the circularity story here is that with a window wall, if we were going to upgrade the windows to something more energy efficient in the future, in 20 or 30 years, or we were going to change the insulation, we can get to all of that on the inside. We can change the windows separately. And so the frame of the facade stays there, and you can upgrade components. So it's a very different sort of circularity approach. Obviously, the GRC is not recyclable at the end of its life. I mean, maybe another architect would take these panels and use them as they are, but they're very bespoke. So I think the upfront embodied carbon here is much better and much lower, but the circularity story is a bit different. Next project is the Edwardian Bank at the heart of Arena Central. No, it's not. It's going backwards. It's our hexagon, our hive tower. This is an office workers' tower, an office tower at the heart of the Arena Central Master Plan, and it's made up of these hexagon windows. And with my embodied carbon goggles on, echoing what Dav said this morning, look at this form factor. Straight up and down, no messing about. Dav showed some diagrams of mine this morning illustrating how the shape of the building and the wall-to-floor ratio really impacts the embodied carbon of the facade. So the best way, the biggest way to reduce embodied carbon of a facade is to have less facade. Look at this wall-to-floor ratio. Dav showed us an octagon earlier. Mine's a hexagon. And the first time I saw Dav's octagon, I thought, wow, that's an even better wall-to-floor ratio. Architects don't normally get excited about wall-to-floor ratio, but I think we do because it's all about efficiency. And for a mechanically ventilated office building, minimising the heat loss envelope, minimising those solar gains is one of the most important things to make it as energy efficient as it can be. And so the form and shape of our building is even more important than ever. It's a building that has a lot of repetition with this hexagonal detail. So as we've heard from other people this morning, it's really great to be able to hone the way that's manufactured and to make it as easy and efficient to build as possible. The simplicity and repetition means, thinking circular economy-wise, maybe it could be reused in the future. We're back to the aluminium story where you have to put your faith in, well, it's recyclable, you know, it's a kit of parts, all of that. But my heart's not in that. We need to reduce the use of aluminium in our facades. So here we are. The next project is the conversion of this Edwardian bank, which faces onto Centenary Square. It's an absolutely beautiful listed building. And we converted this into the exchange for the University of Birmingham. This is a powerful little building that really holds its own against the much larger buildings of Centenary Square. And it does that because of the strength of its design. It has these very solid flanks with this central portico that was built in the early 1900s to be a safe fortress to deposit your life savings. So it's all about that strength, that security. So converting this into a building for a university, which wants to be open and welcoming, is a completely different sense of the building. We needed to make a new rear elevation for this building that never had one. So this was our opportunity to make a second front door. This is the south-facing elevation, which opens onto the new public square of our Arena Central master plan. So we wanted to encourage a flow through the building, and did that by following the principles of the front classical elevation of these solid flanks and these central portico, really having the courage to be as simple as possible and follow that classical language. So the low carbon choice here is the simplicity. These are the new cores for the buildings. We could have felt the need to add details, add windows, add decorations, add complications. And that's just adding carbon. It's also adding cost, it's adding time. And I'm really proud that these are the most simple elevations they could possibly be. My circular economy goggles here are obviously rose tinted because this is a retrofit project. This is looking after the heritage of the city, but also from a circular economy point of view, these simple ashlar blocks, you know, it's so robust. They're treated in a way they could be used over and over again for, you know, hundreds of years. Or it was more likely that we would have been able to find some reused stone if it had been available to build this with. So that simplicity is a low embodied carbon choice, and it's a really good circular economy choice. Our most recent project in Birmingham, which has just received planning consent, is the conversion of the John Lewis at Grand Central Station. This is a building by another architect, and John Lewis opened in 2015, I believe, and then it closed in 2020. So the fact that this flagship building has already become redundant is sort of a very stark example of the problem of empty retail across the country, and particularly department stores. So our transformation of this building from retail into office is to change the sign. And that belies the incredible complexity and reimagining on the interior. But as architects, I think the temptation to feel like we would have to signal this change in some outward way to make our mark, to show the change, was something that we had to resist because, you know, this is a functional facade. Why should we, you know, start altering it when we don't have to? Because this was built as a department store, the entire facade is fritted. Because for a department store, you wouldn't want views out. It's just bringing in some daylight. And in fact, most of this was lined out with plasterboard and retail displays. So for a workplace, obviously you wouldn't start with an entirely fritted facade, and we had to, again, really analyse the instinct to replace this with clear glass, to understand if we replace this with a new facade with vision glass and some solid, how much better would the operational performance actually be? Like, are we kidding ourselves that this would really need to be changed? So the benefit, the upfront embodied carbon saving of keeping this outweighs any future sort of small-scale improvement by replacing the facade. And the Frit's doing a decent job of keeping the light out, the solar gains out. So what we did do was dramatically extend the existing atrium. So we turned the building inside out. So all the need from those office floors to have view and connection and activity that you would normally get by looking out of the window, we create a really generous heart to the building that does that job. It also links up to a roof terrace, so it's a real focus for movement and amenity. And then the job of the fritted facade is really just to let the light in. So we've turned the building inside out by thinking, how can we conserve what we've got and come up with a new strategy? So, obviously, we all know that retrofit is just such, the most massive piece of decarbonising our built environment. And Drum, with its keeping the facade, turning it inside out, the new atrium, we can achieve the LETI bands of A+ for the upfront embodied carbon while still delivering grade A office. So it's really great for us to test our approach against the numbers that we're all getting used to seeing. So then I was thinking, what are my conclusions? What am I drawing? What am I learning from looking back at our last almost 20 years of designing in Birmingham? And I realised that all the conclusions I was coming up with were with my embodied carbon goggles on. That's my passion. That's the thing. I've put my embodied carbon goggles on, and as Helen said, I can't take them off. It's informing everything that I do. I wonder which goggles you would try on and not be able to take off. Maybe they would be biodiversity goggles, maybe they would be water goggles, maybe they would be toxicity, maybe they would be social value goggles. I think our best climate action is the thing we're really passionate about, the thing we care about, the thing we're good at, the thing in our role that maybe we have the opportunity to influence or advocate for. So if we all work on the thing that means the most to us, then collectively, through all these incremental changes, we're going to make a difference altogether. So with my embodied carbon goggles on, let's look back and see what we can learn. So first, we've got to challenge business as usual. We've got to do things differently and not be afraid of different aesthetic choices. We've got to use less aluminium. We've got to design as simply as we can, and we've got to enjoy celebrating our wall-to-floor ratios and our form factors. We've got to build simply, make buildings that are easy to build, and perform well, and maybe the most sustainable facade is the one that already exists. Thank you.
Thank you, Helen. We're going to use the couple of minutes we have while they set up the chairs.
Oh no, questions?
To have a chat. So thank you for that. It's a good tour of projects, and it's good that all of your buildings still hold up pretty well
Thank you.
against the test of time. On that last building, it looked like it had a massive floor-to-floor dimension, which was designed for retail.
Yeah.
How do you adapt that for office use?
I think it's just even better. So we're saying that rather than retrofit being a compromise, retrofit allows us in this case to create amazing workplace that is even better than a new build would be, because you're enjoying that retail floor-to-floor height.
Yeah. And you said the glass stayed in place.
Yep.
They're not changing.
Not changing it. You can't get that frit off. And also, I believe it's very difficult or impossible to recycle fritted glass. So we knew if we took it off, it's just going to get downcycled. So I think the use of fritted glass is a bit uncomfortable at the moment because it screws up the recycling process.
Yeah. And you talked a lot about embodied carbon of materials, and you talked a bit about aluminium on that topic. What's your view on glass and recycling of glass? Is that something you're seeing more of? I mean, I still hear horrible statistics about the volume or the tonnage of glass that goes into landfill every year.
Yeah. It's really difficult because we're all using more and more laminated glass, and that can, I believe, be recycled, but it's a more complicated recycling process. So, you know, while we're making, it has improvements for safety, but then if recycling's more difficult, we're really reliant on technology catching up. We're also talking about trying to get a circular loop of whether glass, you know, from an old building can be turned into the panels for our new building, but I'm not sure that sort of trophy idea of making one exemplary project is the most effective change. You know, we need to get those loops of recycling or circularity going more broadly and do more sharing of resources across all the projects.
Wonderful. Well, I think you're on the right track there, and it's good to hear, you know, from a design architect that you take all these things on board and you design for them. So
lovely.
Thank you.
Thank you.
We're actually 3 minutes ahead of program, according to this anyway. The next part of the program for today is a panel discussion. And moderating the panel will be Alex Carter. Alex, are you here? Alex? So Alex is a partner at Cundall's. He will moderate the panel discussion, which is going to focus if fabric first and high performance facades are the route to net zero carbon, how can buildings in Birmingham best respond? It sounds like a big challenge, Alex, so good luck with it, and I'll let you introduce your panel.
Okay, thank you very much. So if the panel want to come forward, we'll sit down and we'll introduce ourselves and get started. So very sort of briefly, there'll be a very sort of lengthy bio for everyone on the screen now, so we don't need to dwell on it too much. But yeah, so I'm Alex Carter, partner at Cundall. Historically, we've operated in the operational energy space for many years. Over the past sort of 5 years, we've really been moving into sort of embodied carbon and also circularity and all the things that means. So that's kind of where my background is. I guess local context. I was involved in getting Curzon Wharf. I got planning sort of recently, net zero sort of carbon bedded into that one. Also working with some of the panel here on 100 Broad Street, which Dav showed on screen earlier, and a few other sort of notable projects. So just Danny, would you like to introduce yourself and your sentences?
Yes, hi everyone. My name's Danny Hampshire. I'm Principal Facade Manager for Yates Construction. I look after our offices from Donington, Birmingham, Manchester, Leeds and Durham, in terms of looking at the commercial elements, delivery design, tendering, and legacy.
Thank you. Tom?
Hi, I'm Tom Bell, a partner at a business in Birmingham called Quantum. I'm a quantity surveyor by background, and we also deliver project management services. We're involved in a number of projects that you've probably seen and spoken about today, notably the Octagon Tower. We're working with Yates on a couple of schemes in Birmingham, high-rise residential. We've got a number of schemes in for planning, and we've recently started working with Lendlease on the Smithfield development.
Thank you. Rob?
Yep. So, hi everybody, I'm Robert King, a director at Howells. I mainly run projects out of Birmingham and in London, and most notably the 42-storey Mercian Tower that was completed last year.
Thank you. Ange?
Hi, I'm Ange Francis. I'm head of facades for John Sisk. We are predominantly, I cover the whole of UK, Ireland and Europe, so it's quite diverse. In regards to Birmingham, we've just finished the Mercan and we're just about to start the Great Charles Street.
Perfect, thank you. So we'll get started. So the kind of background to the question is, as we touched on earlier on, is the kind of, there's either a climate emergency or there isn't an emergency. Therefore, regulation is also now responding to that. Therefore, we kind of need to collectively improve what we design and deliver. Obviously, there's various cost and viability challenges behind actually doing that. Therefore, there's lots to talk about. Rob, if we wouldn't mind jumping over to you first of all. Fabric first is something which is easy to sort of drop into conversations. And it kind of, we touched on it earlier in many different formats with regard to what we're seeing, responses to that. Is the design, sort of exemplary design for architecturally going to change over the next sort of few years compared to, say, the Mercian?
And I think we've already seen this morning, both with what Francis just talked about there, Dav earlier, and it seems strange at a facade conference talking about it, but I think form is probably where you've got to start. I think, you know, particularly in tall buildings, we've got to be thinking from the beginning about, okay, what the function is and the purpose in terms of if it's a residential building, and then actually how does the form and massing of the building interact with its environment before we can talk about fabric. So, you know, for instance, wind modelling is something that's completely changed in the last 5 years and is really important for our cities going forward, so that we can make sure that the ground plane, the plane that the people enjoy, is fit for purpose. And then when we move up into the building, actually the form of the building, we talked about wall-to-floor ratios and the importance of those in limiting embodied carbon, but actually if we can interact with the form and get the orientation of the building right first, it will go a long way to limiting solar gain at first principles before we even talk about the fabric and the outside of the building. So I think we are, as an industry, having to kind of challenge ourselves on the direction that buildings are going in the future, and we need to be developing the massing and form at first principles. An example of that, actually, we saw earlier, the octagon. The octagon didn't start as an octagonal shape, and I think Tom and Dav, who were here earlier, will tell you that it was actually a square rectangular form to begin with, and it was probably the metrics and cost that drove it to have a rethink, and also aesthetically. So, you know, how these buildings appear from the outside.
So, sort of segueing into Tom, that sort of cost decision at the very, very, very start with regard to the real basics before there's even the design, is that something you're seeing more often?
Well, I think the first thing to say is it's so impressive everyone's talking about water-floor ratios, because for so many years it's been QSs have been buildings are developer-led residential buildings, and cost is then driving the viability of those buildings. And the facade is a massive element, along with the structure and the mechanical electrical of that, the cost and ultimately the viability. So I think a lot of the things we've also talked about can help, you know, reducing the amount of aluminium if there's less in price, you know, in theory. So it's about trying to get some of the benefits from the improvements we're talking about into the cost. But equally, I think, you know, there's a difference between cost and value. So when you move away from sort of a commercially led project into something that's more like a university, say, or a leisure centre, the fabric first approach has got to be different there. You know, if you're trying to reduce the energy costs, then actually the facade being more expensive might be a benefit to the project if you can offset it against, you know, operational costs and embodied costs. So there's not a one size fits all really. But if you are talking about, you know, pure commercial development, then of course it's probably one of the major.
Yeah, I guess we've always got there's always a cost, there's always a budget in the background, isn't there? Danny, is that washing through to kind of your involvement with projects?
Yeah, I think it certainly is. I think one of the things we're seeing is that the complexity of the design sometimes is being compromised, certainly by the budgets that are available. One of the really fascinating things I think that I'm seeing recently is, particularly with Dav and Francis just making those comments earlier today, is looking at incorporating practical elements that actually have a function, as well as having that aesthetic appeal. I think there is a danger that just looking at budget and just looking at cost can drive us in a particular direction. And if we ignore elements of having to have different styles of architecture and different elements that actually bring a function in terms of sustainability to the facade, I think that's a really key thing we need to start looking at.
And you think that kind of function of the facade being brought in to early stages?
We are starting to get much earlier because I work in Ireland as well as the UK, so we've got less D&B, the routes and everything else. So exactly as Danny said, is that we're trying very hard in the UK to look at things from a technical perspective, and the cost of doing a building that meets all the technical requirements is what the cost is, with a view then of looking at the VE. I'm sorry, but the money men tend to look at it much more. I mean, the amount of times I've got in meetings and constantly the first thing is, okay, so what's the VE? And it's like, well, wait a minute, we don't even know what's on the table. We can actually build it or anything else. It's this whole drive. Cost is massive for us, and particularly in residential buildings, because as you said, it's, you know, the residential, the developers, there's an element of it is, okay, we want to build it, we want to get it where it'll be, so we can get it functional, so we start making money out of it. And that's causing us massive issues in regards to exactly all the things that everybody in the room is looking for, with a view of us being able to build them. But as a principal contractor, we probably are constantly starting up here, and then we end up down here, and I'm sure you find exactly the same. I mean, I go into meeting after meeting after meeting, and it's like, okay, so where's the baseline? What are we actually trying to achieve? And 9 times out of 10, whether that's our own teams or external teams, is we just don't know.
Is that lack of baseline, is that client-led, or is that ambiguous tender documents?
I think it's a bit of everything. I think sometimes is, I've got, within John Sisk, we've got M&E, and I'm sure Danny's the same with them. And what we try and do is have a huge amount of interaction between us to understand, because I know with all the challenges of all the projects that I've got that comes across our teams and my desk, is basically that constantly the M&E side, it's like, oh, no, we need to cut the budget. So they constantly cut all of that out, but take no consideration as to actually what the facade has to do. And we're finding, and again, apologies for anybody that's there, but a lot of the schemes that we get involved in, we have your facade consultants and the M&E consultants, and quite a lot of the time there's no engagement between them. So there's this constant trade-off of one trying to do something that then causes a problem somewhere else. And I got a phone call last week where I've currently got that on a building that we've now just secured as a contract that potentially is going to give us a big issue.
Yeah, it's rarely a small issue, those kind of things.
No, they're not.
So, Tom, are you kind of seeing that kind of play between the fabric and the kind of operational MEP systems in very simple terms?
Yeah, and I think that's where, as sort of architects and cost consultants, or anybody that's involved in the sort of the early stage of the project, it's really important not to let that happen, or certainly project managers to what we try and do, which I'm sure is no different to a lot of people, is try and bring that team together and really understand the product. Yes, it's got to be cost driven, and yes, we might say, right, that it's got to be less than £1,000 a square metre, or whatever the number is that comes around it. But there's no point achieving that if the other elements aren't considered. With the recent change in Part L and the change in regulations, that's becoming harder and harder and harder as well. And I think on a lot of projects that are on the desk right at the moment, we're trying to deal with a lot of things for the first time, and there's a lot of products that are being discounted, and maybe discounted wrongly, because it's hard to make it work. Whereas I think, if you had a contractor sat around the table, yep, they've overcome those sort of problems on other elements of a build, and making sure you've got the M&E guys sat around the table telling you how much free air he needs to get the circulation in, etc., etc., etc. So the earlier you can engage on elements like that and get cost certainty on those elements, the better it is for everyone sat around the table, really.
I guess, Ange, you've got a very sort of large supply chain in the facade world that kind of you deal with on literally a daily basis. Is that engagement easy to achieve with all the people knocking on your door, or how do you get innovation into the kind of the architectural world?
I think it's difficult because there's a huge amount of innovation that's out there, but 9 times out again is if you go back to the VE side of things, is that if I go way back a long time ago when we used to, it's exactly what we're talking about now. It's looking at products, looking at projects. Can we do something differently rather than it just being this constant? Let's swap that product for another product for another product. And the problem that we've got now is all these other things. It's ensuring that the products that are out there that are saying what they're saying they'll do. It's checking the test data, etc. And it's not something that you can do very quickly. And if you've constantly got that the teams are bringing in something that you're not aware of, so what we're trying to do is look at our supply chain that we use and get that supply chain so that we've done all the checks and balances. We bring it down. So what you're actually then able to do is work with the manufacturers. It's like what Stephen and that was talking about, is with the likes of the Schücos and others that are out there to actually come up with smarter, cleverer ways of doing something, rather than it just being, okay, well, someone else said, oh, there's another aluminium fabricator out there, how about we bring them in? And I think that's the only way we can do it. We can't deal with the amount of stuff that's out in the market these days. We just physically can't.
Yeah, we're very much in the same place as you are, Ange, in terms of looking at probably not revolutionary kind of innovation. It's tweaking what we've got, our current sort of palette of materials that we use, and trying to ensure that we're trying to use those in the most efficient and sustainable way. I think there is a bit of a gap in terms of real, true innovation, doing things differently. And that's, because of market constraints, and also the demands in terms of making sure any new products have the integrity that you touched on about testing and certification, all of that thing. That is not a quick process.
No.
So we are trying to focus on really tweaking what's available to us at the minute, rather than doing anything differently.
How much latitude are you getting in your part of the world, Rob? With the you're clearly at the front end. There's innovation, and there's clients also, sort of obviously with cost constraints or program constraints, and trying to drive things forward quickly.
I think going back to something that Tom just said, with Part L changing, we are often going through this for the first time at the moment with consultants, and we haven't got an MEP consultant on the panel, but probably in the room. And it is what we don't want to do is be driven completely by solid to glass ratios, because if we do that, we're in a position where we've got small portholes into walls, and I don't think that gives people the best places to live and joyful buildings. So I think what we're finding is you have to be more collaborative from the beginning. You have to get that very early modelling done and test iteratively. And also, I think the way we work particularly is the first option isn't the only option, and it's about that testing, and back and forth communication with the wider consultant team that gives you the ultimate answer. And I think, coming back to some of the mantras that we work at Howells, we've got this clean mantra, and Dav touched on it before, and one of the acronyms for A is appropriate. Ultimately, what we can't do is design these buildings that overheat in 10 years' time. So that starts to lead us to, well, what are the other solutions? Is it about increased wall depth? Well, I'm going to get told by the QS that that's too costly. Is it about bolt-on other kind of solar shading elements? And I think that's where the industry is starting to go. We want to keep these larger windows and glazing, but we've also got to challenge how do we manage solar control and overheating.
And if there was a design crit taking place, is there kind of a need to understand that what was happening sort of several years ago isn't any good now? We need to do things differently, sort of over the coming, like properly differently, verticality of glazing maybe as opposed to horizontality and all that kind of thing. Is that sort of something which is sort of dragging things back or holding things back?
I think each project's assessed on its own merits, isn't it? And I think one of the things we are starting to see more now is a move away from more vertical windows into something that's more horizontal to limit that solar gain directly on the floor. So introducing an upstand gives you that protection. I think definitely we have our own internal design review process that challenges each project across the office. But I think there is a place within Birmingham particularly for perhaps an external design review panel which holds us all to account. We're definitely seeing that in London, whereby one of my schemes, we've had 3 external design review panels, and they're made up of architects, MEP, sustainability consultants that bring all their expertise and actually challenge the design team to say, no, you've not got the right answer, go away and take that cooling out of your buildings and design more passively, which is, I think, is ultimately to deliver on the future vision for the city, to get the best quality architecture in the city. That's where we need to be, is holding each other to account, I think.
Tanno, does that resonate with what you sort of see at the sort of tail end often on projects where there's presumably you sometimes pick documents up and you can see there's some flaws in there in many different ways?
Sorry, you addressed
Yes, yes, sorry, Danny, yeah.
Yes. I mean, it is quite difficult to sort of get to grips with where we've got to in terms of the process as we pick it up as main contractors with the supply chain. I think certainly in terms of sustainability, we've got to focus on it. We drive that through the supply chain and with the suppliers. But there's certainly a degree of missed opportunity that you can identify fairly readily in terms of getting through the delivery process and the final building. I think that's becoming more evident as the information that's available to us improves. By necessity, we're getting better information from the supply chain manufacturers and system houses, particularly with curtain wall. And we're able to kind of introduce that knowledge tentatively with their support in terms of getting these solutions right. I do like that idea of having that independent design review panel with people giving input from MEP and other areas. I think that's certainly something that we should look at seriously trying to implement in this region particularly. I'm sure you've seen the benefits of that in London.
No, absolutely. I was just thinking of another example we showed earlier for the project that we did in Canary Wharf, Wardian. It relies quite heavily on the external kind of shading of the balconies and amenity space. And I think that as a tool is something that we are missing in the Birmingham and more regional markets. And perhaps that's driven by cost and developers, struggling to kind of pay for these external amenity. But it does offer us another tool to limit kind of solar gains and also provide a better quality building for people to live in. And I think that's where we need to start being clever, actually. What's the cost of a balcony versus the cost of uplift on the internal MEP equipment that you might need to reduce your overheating?
I think you made an excellent point about the environment inside as well, because I think we've all seen developments quite recently where there's been a sort of U-value obsession, if you like, in terms of reducing the amount of glass on the external facade. And when you actually consider what it's like for somebody to be within that environment, particularly a residence with perhaps looking through a ribbon window, is particularly unpleasant. I think when you put people in that situation and get them to see what the consequences of their design decisions, which may be driven by performance, it may be driven by cost, there's a bit of a worry there that we're building some not very pleasant environments for people to actually occupy.
Well, if we do that, we failed, haven't we?
Yeah, exactly.
I think we're designing buildings for the next generation, our children, grandchildren, the youngest city in Europe, as Simon said earlier. I think we've also got to be making sure that we're doing the right things to provide the right environments for people to live in, and increase the density within the city centre. So,
I think that, to add though, I think the one thing we focus very much on residential, and that probably impacts people personally the most in terms of what your energy costs are, what your experience inside your property. But in regards to the sort of the question of how you achieve net zero carbon, manufacturing, logistics, industrial buildings are going to be way less efficient from a facade perspective and producing way more carbon energy. So actually it's more of a holistic view on facades across construction, as opposed, it's very easy to focus in on things that we do because it has such a big effect, but it has the same effect, water floor ratios on a logistics building, you don't do it, do you? Because it doesn't work. So, it needs proper consideration with the type and use of the building as well as the, products.
I guess that whole life cycle cost compared to the short-term sort of capex, are you seeing clients actually acknowledging that or using that as a consideration, or are we still in a sort of capitalist or capex up front, that's get that low, and that's what people are really, really concerned about when it comes down to it at the end?
I think again it comes back to the client, developer client. It's I've said before a number of times, I think the way that you make things happen, whether it be fire regulations, carbon regulations, is to legislate it. Because if you don't legislate it, then the developer angle will always take the lowest path of least resistance, and you'll end up with the absolute minimum that you can get away with. Whereas it's an end user, someone that's going to be in a building and occupying that building for 20, 30, 40 years, is going to have a consideration. And I think that's probably why we're seeing funds care more about ESG now than they ever have done, because actually they will hold the asset and they're trying to future-proof it, and they're trying to get in front of potential legislation changes. And so it's, you know, it's a real balance, and it's how do you then, you know, without being big government, et cetera, how do you, because you can put in, you know, targets and all those sort of things, but if it's a target and it's not mandatory, people won't do it.
I think having the, following the London example of just actually recording what embodied carbon is, not necessarily even having a target, but actually just recording that, having part of the formal sort of front-end planning dialogue, that you've got to start somewhere if you've got to start a journey, and we don't even have that at the moment, unfortunately. Ange, do you see that kind of big play sort of taking place when you're getting involved, because you're doing front end, or is it at the back end, this cost-cutting /
To be honest with you, it's everywhere. And we definitely see it from even once the building's complete and it's occupied, being called back because people are making decisions that potentially are not the right, because they're not fully informed decisions. So you were speaking earlier about buildings overheating. So the amount of times that we've built buildings, and you've kind of said up front is like, we're just, because it's all about the thermals, and it's like, okay, we're looking at this and we're doing what we're doing. But the reality of it is we need to be thinking a lot more long term just than what's currently going on. And I can tell you within the last 5-6 years, I've been back to so many buildings where the thermal enhancement on them has been fantastic, but they're overheating massively. And we're now going back and opening windows into buildings. And I think a lot of that is just because it is a balance, it is a fine balance of trying to work out how's something going to work through from a thermal perspective, from a fire perspective, you know, and everything that you look at goes on, it has a knock-on effect to something else and something else and something else. But exactly as you've said, unless the clients actually start getting a lot more on board with us, it just, a lot of the time it's a race to the bottom for cost, and it doesn't matter what we've done then, you'll always still end up at some point, hopefully not for me too much longer, but where we keep getting called back to buildings 5, 6, 7 years later because we've got issues, for example, where condensation, you know, we've got the wall build-ups, they've not been thermally assessed properly, the condensation risk assessment's not been done properly. You're then going back because someone thinks they've got dampness in their building, and it isn't, it's condensation. You open up the walls and all this lovely insulation that was there is now just a messy puddle at the bottom. So it is about everything being co-joined and how we get this together. But unless the clients start coming heavily involved in this, we're beaten before we start.
I think, I mean, semi-controversial maybe. I think that even though cost is the driver, we set out with the right intentions quite often. Yep. But it obviously gets chipped every stage. So once if it's design and build, as soon as we've in contract, we've got a fixed price. And then it's the main contractor that's then, you know, we don't know where you are, we don't know where you are with margins. And it's then, as it goes through the supply chain, so, you know, the client at times loses those decisions and they're made by other parties, you know, unless you've got a retained design team to support you. Yeah. It's how do we get over those issues?
I think it's even more than that, especially if you're doing repeat. We do an awful lot of repeat work for clients, and the amount of times we're challenged where we've built a building and we're now building a new building, and the client expects us to build the new building, you know, for the same price we built the last building, and we're now 3 years down the line. And again, it's heavily round the supply chain as well. So we all know that we want to use the best supply chain we can. However, this in the UK side of it is getting less and less, where we're becoming more predominant on using Europeans, for example, for doing unitized. So we're then back to, okay, where does your products come from? You know, where is it all? And it's the carbon footprint. So as much as we're talking about the embodied carbon, there's more and more where our carbon footprint becomes massive. I was looking the other day at ETFE roofs, for example, that we've got, and the if you like, the cake mix that starts the whole process off is Japan. So before we even start, it's like, you know, you've got this there. And the other thing is this whole, and again, this was new for me because we were talking about this whole footprint that they were done, and the chap turned around and said to me, it's okay because I've got a piece of paper that says I'm carbon neutral. And I was like, how can you be carbon neutral? Oh, we pay X amount of money to plant so many trees. And I'm gobsmacked by this because, yeah, it's brilliant we build all these trees, but can we really be saying that someone's got, manufacturers out there that have got money that can then say, okay, it doesn't matter what our processes are and all this, as long as we plant trees, we're fine. So that massively opened my eyes into, okay, I now need to really be looking at this in a completely different way than what I've been doing.
Well, I mean, it's really good, though, that you're having that conversation with suppliers and they've got information. Are you seeing, I mean, because you are talking to them, are you basing decisions, or are you seeing clients basing decisions on carbon, or are you basing decisions on cost, VE, etc., like we talked about at the start?
You try and make it a combination of both, I suppose. You're trying to get the best that you can physically get. That's from our side of it, from a department that we're running from, with a view of how does that then fit in with the cost. So before we even get to the client, I've got to get past our own quantity surveyors and our own commercial teams. So we're basically saying, no, you can't do this, you can't do that, you can't do the next thing. And then I'll get a phone call to say, oh, you do realise that project's just done exactly what you've said not to do.
Yeah, I mean, you have my sympathies, having gone through that process all the time myself. I mean, it has its limits. I think that's the fair way to put it. Where we have the option to do something more sustainable, we will always take it. We have KPI targets and company targets that we have to try to meet. And they're considered by the board on a regular basis. And if we're not doing the right thing, then we're going to have some serious issues. So I think as main contractor group certainly made some big commitments in terms of reducing carbon. I think one of the things that we really do need to consider, though, is this fundamental change in terms of the design and thinking more creatively with the limited palette that we have. It's good to see that Schüco have their low carbon aluminium. We have Hydro doing the same, and other people looking at low carbon glass and potentially even investing in new glass processing plants, which would be great and coming on stream. But if you're using it on your project, somebody else isn't using it on theirs. I think that's the key thing to identify. It's really important that the supply of low carbon products improves, just so we can maintain that and we're not just pinching it from somebody else's scheme to use on our own and patting ourselves on the back.
So that call out to the industry basically to innovate with more materiality options or more innovative solutions that reduce material?
Yeah, I mean, we've got an innovation team within Wates, as I know a number of other main contractors do as well, and we have regular sort of panel discussions and invite people in to do a bit of a presentation. It is tricky. I know I've made this point before, but I think there is a bit of a lack of true innovation in terms of what we're doing with facades at the minute. But that's not to say we can't innovate in other ways. Looking at the presentation, Schüco with reversing the unitized window system, looking at using different kinds of material in a different orientation is always a good option.
The kind of circular economy, which leads naturally on from sort of embodied. Rob, is that something which you're able to actually embed in designs at this point in time, or is that one that's one for the future in the too hard or not enough time during the design? The design program is a program; it's got a period. There's obviously a finite amount of time in it.
By that you mean kind of designing for disassembly and reuse. Yeah. I think it's embryonic. It's in its infancy in how we were approaching it. I think on taller buildings particularly, the modularization of components is helping because they can easily be disassembled. But then I think going wider, reaching, having opportunities for material banks and use of recycled material within other elements, not just the facade, whether that's through the kind of concrete aggregates or what you're putting in the ground, or recycling of the steel work from buildings that you're demolishing is perhaps a bigger opportunity as it stands than disassembling facade elements and reusing them elsewhere. I mean, I think it kind of segues into not just talking about new buildings, but also kind of existing and kind of refurbishment and retrofit. And I think there are a number of key buildings across the city at the moment that are primed for, rather than redevelopment, retrofit of external envelope as a better way to kind of give them a new lease of life, a new kind of function, but also deal with that embodied carbon issue. We look back at the Rotunda and we still see that in the city as a real iconic building, and that stood there for many years and has been refurbished. And we should be doing it to more of our building stock, I think, within the city particularly.
So if carbon-based decisions are driving that direction, Tom, is cost able to keep up with there's clearly a lot of material, a lot of values in what's been deconstructed. Are we getting the benefit from that?
Yeah, I think it's an interesting question. I mean, it gets split out quite a lot, doesn't it? The same supply chain that's constructing something at the moment often isn't doing the demolition rather than the deconstruction. And how you start to join those two things together, and how you start to look at the design and what can be reused and what can't be reused. I think, to Rob's point about the, refurbishing building and recladding building and vertical extensions, the amount of projects that we look at that start off that way, and then when you go through the cost and the client does the appraisal, the values aren't there in the city. So there's a wider question about how do you increase the values, because it would work in London, let's say, but it doesn't work here. And that comes back to all the stuff Simon was saying earlier about the investment in the city and growing the city. And so I think you could get there, but at the moment they're quite often cost prohibitive solutions, and will increase and become increasing so as the regulations become stricter. So the facade's got to work harder, because you haven't necessarily got some of the benefits of the new construction that you would be if you were building something from scratch.
Sure. And from a sort of, I guess, main contractor point of view, and accessing the deconstruction benefit, is that in the broad supply chain that you've kind of got, is that something which is happening, or is that something that's able to happen, you think? Or
I think it can happen. I think the majority of it is that a lot of buildings that we look at in regards to, and Danny, you're probably the same, is that when we go to look at a building in regards to potentially it being refurbished or something else, is the existing information just isn't there. And when you start going in and trying to do an intrusive surveys, etc., it then becomes harder and harder to work out how something's been put together, whether indeed you can physically take it apart or not. So there's a lot of the times, we've been looking at a building a few months ago where one of my team came and said, the client wants to keep this retained. And it was like, there was no information. So you went and took all the photographs, and when you start looking at it, you're thinking, there's no way you can retain that, because to actually remove it, you've got to demolish this part of it. And I think part of the way going forward now, with all the digitalised information systems that we've got and keeping a lot more of that information on there, it may make life easier. We're currently looking at a job where we're looking to use reclaimed bricks, heavily driven by the architects, which is brilliant, but then we discover the amount of bricks that we're actually physically going to need, where are we actually going to get them from, that will match. So there's things like that comes into play. So there is ideas, and certainly forward thinking going on. Are we where we should be with it? Is definitely not. And again, a lot of that potentially comes back to things that are cost driven. We lost out fairly recent to a refurbishment project, and then the project director came back and said, the guys that have won it, this is the product that they're putting on the building. And for me, it's like, we just shouldn't be putting that on the building. There's no point in us looking at things that have happened through Grenfell with a view of we're now going out there and refurbishing buildings and taking this on board, when we're then starting to put back on buildings things that we shouldn't be using, in my opinion. And that's where, so again, it's about people, it's kind of holding your ground, which isn't easy. The amount of arguments I have with our hierarchy, basically turning around and saying is, it doesn't matter, if the client's telling you to do something you know is fundamentally wrong, because your teams, whoever they may be, are telling you that wrong, should you be bound to the client and say, do you know what, okay, we'll do it because that's what you want. And that's, I think, where it comes from. And a lot of that is, and a lot of main contractors are probably in the same position, because ultimately, at the end of the day, someone will build it. And that's exactly what happened with our building. I'm telling them, no, you don't do this, we don't do that. And this isn't just about thermals or fire or anything else. It's physical buildabilities, health and safety, all of that has to come into play. So going back to looking at things completely holistically, we have to do it, whether that's as individuals or teams. But if there's always going to be someone out there that the client can go to who will do it, then that becomes really hard for people who are trying to do it in the right manner.
Danny, are you that person, or are you sort of...
Yeah, we'll build anything. No, I wholeheartedly agree with what you're saying there, Ange. It is a difficulty. We are working at the minute with extremely well-motivated clients and people who are, how shall I say, diplomatically, maybe not so well-motivated in terms of what they're doing with refurbs. We're having a look at a couple of refurbs at the minute for kind of headquarters buildings where, the finances may not be the primary driver. The driver is their own ambitions towards sustainability and replacing an inefficient facade with something more sustainable.
Right.
And I think it's really interesting that, when you can tell pretty much instantly once you start the discussions where their motivations lie. And it's really refreshing to work with people like that now in this environment, where they're really keen to see what's happening with the glass, what's happening with the aluminium that's being removed, what's happening with all of the other elements that have gone into making that facade, down to the bracketry and the gaskets and everything that's being removed. Can we close all of those loops in terms of understanding how we've delivered the new stuff? And is the old stuff going back into a construction process, going back into actually being reused on construction products? It's not always a guarantee when you're taking aluminium off a building that that's the case. So we're doing a bit of work at the minute in terms of closing all of those loops and really trying to give the client a bit of reassurance, because it's their motivation that that's what we're doing.
Robbie, are you able or seeing that being fed back into what the clients are thinking with regard to actual proper, genuinely, right, this building is going to be able to be deconstructed and we'll reuse the facade on one of our other buildings in the future, etc.?
I wouldn't say it's coming forward, in that way at the moment. I think clients are definitely, we've been, it feels like we might have been client bashing a little bit, but I think there's a lot of good things that clients are doing and developers are bringing forward now. You mentioned ESG. It is really high up on the agenda for funds, and I think that's now trickling down. Architects and design teams are pushing for kind of greater innovation. I think it comes down to little kind of material choices as well, in that actually going back to, can we use external balconies or amenity spaces to actually offset and make our buildings better? Designing from the outside to in, I think is really important. So I think that's how we're starting to see it. Questioning at an earlier stage before we get into planning, that are we absolutely 100% sure we've got the right solution? And I think that's really positive. I think the question we then get from QSs is, how's it all stack up, and can we make it fit on budget? And sometimes, in order to answer that, you do need a greater level of detail. So we all know that a lot of schemes get submitted planning at RIBA stage 2. It would be much better for us all if it was at stage 3, particularly on the bigger schemes, because we get that level of certainty on the detail. We'd be able to do those embodied carbon assessments and have more accurate data about what we're proposing. Whether that'll ever shift, who knows.
And is the supply chain there to support you in that? Is there enough quantity, enough depth, or even the sort of communication there?
We definitely see earlier engagement with the supply chain happening more and more, and it's better for schemes. So whether it's project teams going out and talking to those specialists to get upfront cost advice, whether it's kind of understanding their material embodied carbon, that's already happening, I think. So it's
Yeah, and Ange, you're involved in front end and also sort of back end, if that's the right description. Do you see a difference in the product that comes out from that process?
Quite a lot of time, yes. Yeah. And certainly it's been a challenge over the last few years, particularly off the back of COVID, because there was a huge amount where we would do cost analyses within our own department, because we kind of have an indication as per square metre what we'd be expecting to come out, whether that be a glazed facade or the cladding or the roofs as well. And then the teams would be doing theirs, and we're coming back. And I had 5 projects where the glazing budgets that we were going in on cost-wise were 50% less than what we were actually pricing them to be. So the problem that you've got there is that there was an element of where we seen there were certain subcontractors who were out there who potentially weren't getting the work. So there was an element of, we went back to this, buying the project. There's a sliding scale that I use with our team, and basically say, if you're 300 or less with the package you're in the ballpark. If you're hitting the point where someone's £1 million less than someone else on a package, there's a big reason for it. And we are now seeing that coming to fruition. I've got members of my teams that are actually out there helping to try and physically manage projects to get the subcontractors finished, because whilst it hasn't necessarily affected the materials we've put on the building, it definitely, we've found their management has become less and less and less. So as the project goes on, to keep the quality where we need to be, the only way I can do that is by having somebody go in and manage their teams. Now, that still comes at a cost, because it comes at our cost. So we end up then, we're not making the money on the projects we should be doing. So yeah, there is that getting that balance of if you like, chasing it at the beginning to get the work at the lowest price you can do, and realising there is a big reason why that is where it is, and that's been definitely a challenge, massive challenge.
Tom, so I guess that decision of the suspiciously low cost and that being chosen on a tender or not, is there something we can do to improve that and not go down that route, which we've all been down, I guess, in different ways over the years?
Yeah, I think what you stand really is, you know, the old adage, if it's too good to be true, it really is. I think, you know, the difficulty that we have, you know, is that our job in some ways is to moderate the process that the contractor's going through, and we can ask the pertinent questions, and we can ask you to take the risks, and you can either take the risk or not take that risk. But ultimately, the risk is sat with the contractor.
Yeah.
And some of those discussions and some of those prices may not even be visible to us at that point in time. You know, we may select a preferred supplier, and then, you know, we've all been there, and you go along, and then the contractor turns up and says, actually, we'd like to change out for this supplier now, and everything is the same, and that goes forward. And so I think it's just about openness and transparency, and trying to bring supply partners in earlier, as we've talked about. You know, if you've got the subcontractor sat there and they've put some effort in and some work in, and there's a confidence from the team around it, and the price is within the right sort of tolerance, then perhaps there is some benefit of talking about that.
I think that sort of recent developments with the Building Safety Act and things like that may make those occurrences less frequent, because we as main contractors, in fact everybody involved in the process, has got to be so clear in terms of people's competence and trust in what they're doing, which is something that might, you know, it's quite easy to reverse kind of sustainability back into that, even though we're talking about structures and fire principally with the Building Safety Act. But actually having that understanding of and the trust in the supply chain that they know what they're doing in terms of delivering things like that, then touch wood, that might not be so frequent the case in the future.
Is that actually evolving your supply chain, that spectre of the Building Safety Act and competence, as you said?
It's a welcome friend, not a spectre. No, we are certainly considering that very seriously in terms of our subcontractors' knowledge of the Building Safety Act and understanding what they need to know themselves. You know, we have a full range of subcontractors. I mean, we're delivering, you know, relatively small schools to 50-storey big unitized curtain wall schemes within the business. So it's quite difficult to get the people at the smaller end of the spectrum to take on board sort of commitments to understanding their competencies and things of that nature. But we try to support them where we can, because they're a critical part of the industry. We can't just neglect them. But conversely, where people do have the resources to fully commit to understanding what they need to do, then our expectations are very high of them at the minute, shall we say.
Does that, the additional resources that they carry to kind of have that sort of, not competence, but have that sort of high-end horsepower, is that actually, does that mean they're used less because they're less competitive, Andrew, or is it used? I
think it's exactly as Danny said. Is, I mean, parts obviously not just since Grenfell, but obviously with all the changes that's been made as well, is that we've been looking heavily at validation processes, and those validation processes within John Sys themselves is a view that certain people are not who, if you don't have the competence to be making those decisions, you're not allowed to make them. So the idea is now that pretty much when we're projects are going through at whatever levels, a validation's got to be signed by a head of a department, so that them that are making the further decisions up know that those checks and balances have come in place. And we're just trying to take that down through the supply chain as well, to understand how they're doing what they're doing. And as Danny said, is that we have very good supply chain who maybe don't have the resources, so how do we actually then support them so that you're getting them over the levels they need to be, with a view then that they can then move on and do that themselves.
Cool, thank you. And I think that bell means that we're very close to lunch, which is to sort of hold people back from the food. Very, very quickly, if we look at the context of the original question, what could we as an industry be doing differently tomorrow to improve the, I guess, carbon intensity of our facades in every way that means, which is talk about operational, embodied, etc., etc. What should we be doing differently, Danny?
Well, I think it's just taking on board. I think that the previous speakers this morning have put it really more eloquently than I can in terms of understanding the design of the building. We shouldn't be neglecting the interesting nature of the facades and a diverse nature of facades. I think that there are certain things we can take on board reducing the amount of aluminium, looking at the orientation of the windows, looking at those. I think a critical thing is looking at the functional elements within the facade that can improve it, as well as contributing to the aesthetics.
Thank you. Tom?
One thing that hasn't featured hugely this morning, but education, the next generation, what are they going to do? The facades 20 years ago are completely different to facades 20 years now, and 20 years later they'll be different again. So we've got to start encouraging younger people to think about it, give them some challenges, take it into the universities, come up with different concepts and look at what the rest of the world's doing.
Thanks. Rob?
I think simply form first, fabric second, but then I think also holding each other to account. I think that's really important. As an industry, we get together and we challenge each other and aspire to drive each project forward.
Thanks. Ange?
I think it's a combination of everything that everybody's been saying, but buildability. One of the things that we find is that the earlier that a principal contractor is brought in to look at not just what's been designed and how all it works together, but how buildable is it, because that in itself can become challenging. How that you look at building the building and making sure that the health and safety all comes into place. We find that where we get that earlier, the projects definitely become much better because you can focus on the right things then, rather than it being at the end, everybody's got this lovely building, then we say, sorry guys, but we can't build it the way you're trying to build it. So.
Perfect. Thank you. And I think that we need to wrap up there. So if everyone joins me to show our appreciation to the panel.
Thank you, Alex, and thank you, panel. Stimulating discussion. I think everybody's got an appetite for lunch now, so please enjoy the lunch and be back at 2 o'clock for the afternoon session. Thank you.
So I'm going to start off with some stuff that we've been doing in around Derbyshire. So when we're kind of working in areas such as these, you end up with quite rural and sensitive locations. Now, they're brilliant to work with, but they're also extremely challenging to work with. You have a richness, you have a history to it, you have particular regions and areas, which are characterised by local materials. And this results in, between, say, the likes of Derbyshire, Leicestershire, Birmingham, everywhere, despite them being relatively close to each other, the way in which you deal with each of these areas can be extremely different. So it's very important that when we're looking at those, that we exist, it's important to respect the existing context and the heritage of the area. Starting on, I'll go through Derbyshire. It says it's got quite a unique heritage and style. It's due to its location, it is very much led by its industrial heritage, particularly this area here, which is just down from Matlock, which was during the Victorian periods, a spa town. So it had a huge amount of grandeur, but within the area, traditional sandstone is one of your primary materials. And it's something that even when we're looking at modern elements, it's something we need to see about whether we can bring it back in and how we can use it to create a contemporary building within what is a very traditional landscape. So, take me through, this is Meadowview, which is a care home. So it's a site for dementia care patients. The site itself is quite interesting insofar as it's an area of outstanding natural beauty and also an area of special scientific interest, which when you're working in that context and you want to put something quite contemporary in it, does create some issues or some constraints, but also quite a lot of opportunities. So one of the biggest things that we looked at was how we could provide something that we created a really striking contrast between both the old within the area and with the new. And we did this an awful lot through using traditional materials. Now, something I will put down and be quite honest about is what you do have to be careful of is VE. And I think as everybody is aware, it's very easy to start looking at a traditional material, particularly stone or something in the area, and we're looking down and going, do you know, actually, how do we get this material into the site? And then the contractor comes on board, there's cost issues, and all of a sudden something that's come from 2 miles up the road is suddenly coming from China, being exported to America to be cut and being exported back here. The one thing we were quite keen on this one is everything within this building has been taken from the Stanton Moor quarry, which is a couple of miles up the road. That does come with complications. It means you have to get involved with the client very early. They need to understand the product. They need to understand the restraints of it. And also, most importantly, you have to get involved with the suppliers. So we started from day one. We actually sat down, if I go back one, and we met with Stanton Moor Quarry. We went and reviewed the site. We worked with what could be done with the stone. Now, this whole building has been done pretty much as a traditional build for the majority of it. The stone is load-bearing, and then it's fixed back with lateral restraints back to the substrate. We have a mix of Asher stone, our smooth elements, and we also have our more traditional wall element. But what we have done is, from the day one working with the quarry, is going, right, how can we take all of the offcuts, all the elements that we're not using on the ashlar, and put those into our traditional stone wall? So how do we make sure that, one, all of our materials become locally sourced, and two, when we do take them from that quarry, that all of our waste product is being reused? And that is a lot of the element between, if I go back up one, two, this element of your traditional stone walling is coming down and through the site. Now that says, if I just carry on, wrong way. So you can see here what we have done is the majority, while it is load bearing, we do have contemporary features. That means we have large overhangs, and we've got elements where we've had to work with the stone material, thicker panel, and hang that off it. The key element was, when we were looking and working with the quarry, that all of the stone, regardless of whether it was load bearing or it was hung, came from the same location in the quarry, came from the same cut, so that once they were all combined, it didn't read as if it came from two different areas. And just some more examples of how that got put on. And this is the side wall is all self-supporting, and then the return along the roof is all clad and hung. Now, we've continued working quite a lot with Derbyshire. Off the back of that, though, we've spent a huge amount of time with them. The second project we're going to go through is, again, looking at how we use traditional materials, but this is within Belper. In this element, you've got a site that is a UNESCO World Heritage Site. Again, we need to sit down, we need to sit with the client, and we need to make sure that what we do, they understand the importance of the material and what we're using. This one had a slightly different constraint. We had an awful lot of lessons learned as to how we source the material, how we cut the material, the ideal sizes, how to get the perfect finish, how to actually speak with the contractor to make sure we got that quality of finish. So there was a lot of lessons learned in the first one that came through to the second. The second one, the elements we had, if my pointer works, I don't know if, it does, are these elements. We wanted some really thin stone columns. We looked at, I don't know how many different options and how we did this, from traditionally stacking them as being load-bearing, whether we had a more traditional post and really thin cladding, and we ended up with notched stone around that. The best thing I can tell, again, it's going back to having the strength of your client to support you, is that when the contractor first saw that, the first reaction was, well, we're not going to do that in stone, can we do that in another material? When we're working with traditional schemes and we're working in traditional areas, keeping that local material and keeping that through is vitally important. So I'm just going to take you through is the examples of some of this put in. What it did mean then was that these stone fins actually became the last element that got installed in the building. Everything else, all the load-bearing ones went in, your steel went in, and this was the very last element that went through in the build. So you can see our concept drawing against what became the final element. We also had to spend a lot of time coordinating with the structural engineer, with the facades, with the client, with other subcontractors such as the glazing, because we've got a full glaze set behind this and you need to be able to get in to maintain it and clean it. So the offset distance, getting that clarity so we're not having excessive amounts of lateral restraint between them. So I'm going to move on. That's, as we mentioned, the rural areas, the outskirts, is something in itself. It's a very particular style of building. Once you come into Birmingham and you're coming into denser areas, you end up with a completely different language. You have the same issues of how do we bring traditional materials into a building, how do we use them in a sustainable manner, and how do we fix them, particularly once we're going high-rise. So Birmingham, as anybody's aware of, you tend to get four main materials through the city. You've got brick, which probably carries probably a good 85-90% of the buildings. Then you've got a use of stone and terracotta. Those tend to be our focal buildings and our details. And lastly, you'll end up with an awful lot of concrete, which is our post-war legacy. All have a vital element within Birmingham. Looking at this site with the heritage and the areas around it and the tonal things, we chose to go for terracotta, and we wanted traditional terracotta. It would have been quite easy to take a concrete panel and have that coloured concrete, or take a metal panel and have that changed. So what we ended up doing is we spent an awful lot of time, again, working with facade engineers on how we could create a unitised facade around these terracotta panels. For an element, once we're going high-rise, we need to start looking at how we unitise elements, how we bring in smaller panels, and how we make sure that something can be easily built. We can have minimal wastage on it. We can get our sustainability credentials, and everything will come on site and be fitted in easily. So we went back and forth, and I think if I go on, you'll see a site of how it is. From what we understand, it's the largest size panel we can find. Terracotta is used quite extensively, but it tends to be in smaller panels. This is 1.5 meters tall by about 1 meter wide. And all of how this got put together was, again, working with a supplier. What is the largest panel that you can take and physically fit in a kiln to fire? What does that mean from a weight point of view, particularly when we want to put texture in the building and movement through it? Well, that's going to add weight. How do we create hollow ribs in this? How does that then get fixed back, going back to our supplier for the unitised facade? How do we fix that in? What is the maximum or the optimum size for them, both in them placing the panel themselves to get it to work on the building, and also from a weight point of view, what can that panel hold and still give us the build-up that we require? So that is, if I go back one, that is currently on site. I think just go across, we are up to probably about the 7th story at the moment with the terracotta panelling, and then a couple of elements coming through that. Now, I mentioned before that there's a number of materials that Birmingham are known for, and if we're going to continue with how we deal with modern elements and how we deal with new construction and unitised panels, it's only right to acknowledge that Birmingham is also known for its post-war legacy and our concrete buildings and our brutalist buildings. And they're not to everybody's tastes, but they are a vital part of Birmingham. They're a vital part of our history. So we're currently looking and working really closely with a team on this scheme, which is the Essington. Now, all of this here is working with an element of reconstituted stone. So again, looking at our unitised panels, how can we actually recycle existing materials that we know are in the area and put them back in to create the unitised stone panels? How do they put together? Again, what are our ideal proportions? So in the whole of the elevation, we've looked at going, well, we want variance. You don't want the same thing going around the whole of the building. How do you create your variance? How do you create a number of panels? What are the optimum size for these panels, and how do we integrate those between? So looking at how each one of these can be fixed and placed together so we get our variance through and we create a rhythm in the facade. And once we're looking at it, so this one's still a planning stage, once we submit to planning, the key thing is we have worked with our facade engineer, we've worked with our structural engineer, we've worked with our fire, we've worked with everybody else. So when we're submitting something, we know this can be built. We've already spoke to the panel company. We know the correct sizes. We know it can go in. So we're not putting forward something that cannot be delivered and cannot be delivered on cost. So we're not going back to the council 6 months later going, yeah, we showed you this lovely image, but we can't physically deliver it. Or the contractor coming on board and going, that's great, how do I build it? So we've been through, and I'm sure everybody has been through, we're building a lot of new buildings. Let's be honest, but actually we have a large stock of buildings that are existing, and we need to start looking at what we can do with them and how we can reuse them. So I've taken 2 examples on this as well. One is 12 Calthorpe Road. So this is a John Maiden building, not listed, close to a conservation area, but actually one of the better examples of his buildings, his choice of materials, the use of the mosaic tiles, how he's placed stuff, all works extremely well. So we thought that actually it would be an easy solution to drop it, but it is actually a good building. It has, don't get me wrong, quite a lot of work that needs doing to it. But what was really important is that while looking at it, we actually keep the original panelling. So if I go back up one, we have existing mosaic tiles, which are located between all of our marble surrounds. And what we've looked to do is encapsulate these. So we're not looking to take anything down, we're not looking to get rid of, but we're actually looking to maintain as much of this building as possible, keep it, encapsulate it, but actually have it so, one, it's usable for future generations. This can be adapted, it can be extended. If you want to take it off and you want to go back to the bare bones, that is still there for 15, 20, 50 years down the line. And we're just working through some of the details and how this is all being put together. So as you end up with the final building that really keeps the ethos and the design of what was there originally, which is really important when we're looking at our heritage. Not all of our heritage is 100, 200 years old. In another 50, 100 years, these buildings are going to be just as important as the ones that are more commonly accepted. Now, we haven't been quite so lucky with all of our buildings that we've looked to retain. We've also done quite a bit of work in Worcester, and we've been looking at 3 Counties Medical School. It used to be an old printworks. Brilliant building, just completed on site now. Unfortunately, it did suffer quite a lot of damage from the concrete. So we looked at it. We were looking at keeping as much of the existing structure as possible, and again, over-cladding. Keep the carbon. There's an awful lot of carbon that's gone into the concrete of these buildings. There's a lot of embodied energy already in them. How do we keep them? How do we improve them? And how do we create a facade that can either be adapted later or reused? And in this instance, we've started looking at the use of metal. Which brings us on to the visual at this point. Unfortunately, when we got on site, this wall had to be completely taken down. The concrete was in such a bad state of repair. However, anywhere we could, we have kept as much of the existing structure as possible, and then we have insulated and overclad with this. The idea being that when we get to the final building, actually the form remains the same, and anywhere where we've actually had to remove anything and replace it, it has been done so it follows the same lines and the same idea. And I'm aware that I'm running out of time, so I'm going to skip through one and end up on the last one. But the big thing is that we work with what materials can be used, what can we retain, what can we keep in our embodied carbon, and when we're looking at new materials to overclad, actually, can they be recycled themselves, or can they be taken off, can we improve the structure behind them, and can they be reused again afterwards? So apologies, because I am running out of time. It's not like I don't talk fast enough. Okay, I'm going to go to the final one. I've made a mention already that we have a number of heritage buildings and we're looking to retain. We also have to look at infill sites. There's a lot of brownfield sites within the city, and not all of them are easily worked. The low-hanging fruit's gone. It is gone. But we do get some absolutely beautiful examples as a result. So looking at 52 to 52 Newhall Street, the biggest issue we had here is we're sat between a Grade 2 and a Grade 2 star-listed building. The site itself's 4.5 metres wide. How do you build in this space to create a home, but more importantly, how do you construct that without impacting the listed buildings? So in this one, we have looked at creating a bit of a lightweight frame that sits in, steps back, and we're moving the elevation so it works with it. But most importantly, we're actually taking elements from the original building. So the stained glass window is come out of the staircase. And what we've looked to do is kind of create that in a pattern in terracotta. Again, a material and a product that's used in both those buildings, so it speaks back to them. This couldn't be done in individual panels. You would have ended up with so much bracketing and so many elements, we would have cluttered the facade. So again, we're working with the client, we're working with the engineers, and we're working with the facade consultant very early on. Instead, what we've looked to do is we're casting it into a concrete back. What this means is we can then take this on board and we can create a lightweight structure. This facade can be completely manufactured off-site. We don't have any wastage. It can come prefabricated, pre-ready, and we can put it in place without impacting any of our existing and our important heritage structures. Again, just looking through some of the details that are associated with that, and then another view through from it. I managed to go through that one very quickly. I think the biggest key thing that we're finding when we are looking at this, if we want to continue working, either whether it's new build, whether it's refurbing existing buildings, or anything in between, we need to start speaking to the suppliers from day one. If there is a design ethos on what material you want to use, we should be, where possible, using natural materials that we can reuse, we can break down and we can use them again. But we cannot do that unless we work really closely with our engineers, our consultants, and most importantly, our suppliers. So we bring through our optimum sizes, we bring through the best way to fix it. We look, and when we get on site, we can build it. And also, we can recycle it afterwards. We know what the impact is, how far the material is having to come, how we deal with it, who's going to supply it, and what the implications is if further down the line that gets chosen, whether there's a requirement for VE, whether that's from the client or the contractor. It gives us a basis to have a meaningful conversation and a meaningful argument as to why it should be retained. And that is me. Thank you.
Thank you very much, Lisa. Considering you missed the morning session, you were dead on script. It's amazing. All the points you made are... Right, if you stay for a minute, I have a couple of questions for you.
Oh, lovely.
I'm surprised a little bit because not having worked so much with Glancy Nichols before, was imagining you did a lot more glassy, modern buildings. And I'm surprised to see the kind of more sort of heritage almost type work that the practice does, which is great.
I think there's always a couple of modern buildings in it, but we have been rooted very much from day one that it's all about local context, it's local materials and how we bring them into use. Now that is, as I says, is going to vary, and we've worked all over the country. So obviously the stuff in Derbyshire is all stone-based because it's stone and brick predominantly, if I'm completely honest. There are brick elements in there too. That's what's local to that area. We have worked further down south where actually you start looking, you are using brick, but it's not red brick. You start looking at buff, you start looking at yellows. We do, in all fairness, actually brick probably appears quite a bit. We use an awful lot of stone, we use a fair bit of terracotta, but we also work a lot with local authorities and we work at universities, so we work an awful lot within heritage elements. Now those are listed buildings, and that's a completely different manner. You can take in an element of a modern, because you always want that bit of a contrast, but they need to speak to each other at the same time.
Great. So on those projects, it almost reminded me of kind of a Roman procurement route, which is, develop the building type to suit the local environment and then source local. That's effectively what the Romans did 2,000 years ago, which is amazing. Your Essex Street project looks incredible.
Thank you.
A lot of large terracotta pieces.
That was a challenge.
And you say the project is on site now.
On site at the moment.
Is that going to be on the SFE tour? That is worth being on the SFE tour when you do the city walk.
New edition.
And it's also interesting that you emphasized more than once the pre-engagement, early engagement, and to develop technical and cost certainty before you invite a main contractor in. I mean, our panel before lunch was talking about main contractors being sort of handed a kind of a bag of bolts and go and make a building with it. You painted a different picture there.
I'd suggest this even before the main contractor gets involved. I think when you go to planning, you need to know what that material is, how it gets built up. You need to be confident that you can build that building. And if you're not confident on the technical element of how that's put together, all that's going to happen is the design is going to get watered down. The contextuality of it, the materiality, is going to get watered down.
My final point, you'll be pleased to hear, was I think this is the first time we saw an example today of overcladding. It's a concept that probably people haven't appreciated, that it's a real option that's available for you. If the building is nothing wrong with it, it's largely right, just suffers from being out of date or whatever, or the concept of overcladding is also quite a good concept. How did that come about? Where did that...
I think it's acknowledging where we are. There's an awful lot of emphasis put on new buildings and how sustainable they are. Within the UK, and if I take away the larger elements, we've got the oldest housing stock in the whole of Europe.
Yep.
I think actually potentially in the whole of the world, the wheels being particularly worse, we need to look after our existing stock. We need to see how can we adapt that. There's so much energy in that. What can we do to make that better? And insulating internally isn't always the right solution, because that can bring its own issues with damp and cold bridging and everything else. So actually being able to take this element and bring it outside is a really legitimate solution to try and get across a lot of those issues.
Wonderful. Thank you so much, Lisa.
Thank you.
Really good. Our next speaker is going to be Iain Gray. Iain is from BB7. He's going to talk to us about fire and facades, covering everything from the ugly, the bad, and the good. Hopefully more good than bad and ugly.
Try our best. There we are. Hi, everyone. Thank you for the introduction, Steve, and thank you to the Zak team for organising this event in Birmingham. Fantastic to see it here, finally. My presentation is going to be on facades and fire. I've been in the facade industry for the best part of nearly 16 years now. And September last year, I took the plunge and decided to try something a little different and jump into the fire side of the industry, still in the facade world, but housing myself in a facade consultancy, well-established BB7. Essentially what I want to talk to you all about is what I've learned over the last 8 months and where we are, the ugly, the bad, and the good, alongside my new brand ambassador, Mr. Eastwood here. Jumping into it the wrong way round. I started with the good, the bad, and the ugly, and it kind of felt more appropriate to do it this way round. And I'm going to start with it sounds very boring. I'm going to start with risk, because it is the ugly side of the industry. Because whenever I speak to someone about coming into BB7, they go, oh, that's interesting. We've never really done that before. Why? And it's about risk. I always like to throw this into a presentation because I do feel it just kind of sets the tone. And it's something that Premier Guarantee put out in 2017, just after Grenfell. And it is that however you would define failure, 85% of all failures occur in the facade line over the course of a building's life. Now, how you would define that failure could be anything from the extremes of something falling, something burning, all the way to some condensation or broken glass. But if we look at the bad stuff, and we look at the facade side of the world, we look at some of these examples, recent examples. So, Angel Gardens, top left, the Edinburgh schools, if everyone remembers that, in 2017. There were kids about 15 minutes prior to this collapse underneath. Oh, I wanted to try this. Brilliant. There were kids here about 15 minutes before this wall fell down. Terrifying. The Corniche, you can see in London, that vent fell and tragically took someone's life, also in 2017. And then, I don't know if you can see, well, obviously the red circle will nicely highlight it, but there is a broken panel that fell out of the Radisson Blu down on Pagola Island in 2020. And I think probably the only good thing that came out of the pandemic, or one of the few, is that the street was empty because everyone was in lockdown when that panel fell. So very lucky from that perspective. And that's facade risk. But then we look at fire risk. And that's obviously, this is a lot more obvious. Now I've taken a few extracts of key fires that have occurred and have shaped the industry from a fire perspective over the last 400 odd years, since the Great Fire of London, all the way through Summerland and on the Isle of Man is the one you've got here on top right, and that's a very classic fire. And also the Valley Parade Stadium. That fire progressed to that state in 4 minutes, and that was a full stadium. So, terrifying. But that's fire, not necessarily considering facades. But what happens when we blended the two? Well, recently that has happened, and again, we've got sort of the tragic effects that have happened from 2003's Telstar House through to National House, through to the obvious Grenfell Tower, which sadly took 72 lives. And that's a blend of both fire and facades. But whenever we speak about risk, the thing that comes up is always PI insurance. And it's the thing which, sadly, seems to be driving those two industries, which are affecting each other more and more apart. And actually, the top left is one I wasn't even aware of until I started pulling things together for this presentation. And it was a legal precedent that basically said that even though the contractor had designed a building entirely in connection with the standards that form how this building should, it wasn't a building, it was actually a wind turbine, how it should have been built, the equation in the standard was wrong, and the contractor was still found to be liable. Quite scary if you're thinking about how we design buildings and how we go, oh, that's in the code, that's how we should do things. And then we have all the other examples which are in here, including most notably the Developers Pledge of 2023, which has extended liability to 30 years. You can imagine that PI insurers are pretty terrified by all of these things happening since 2017. That's a hell of a lot to be going on. And therefore, they're pretty reticent to want to give much or any cover or blend things. And that's essentially where we've been moving towards. A steady sort of march towards protecting position and separating. And it's just feels wrong. That's the ugly part. The bad part is where we are in terms of what I would call conscious ignorance. I think it's a term that's sort of used in some sort of training schemes and all of that. And actually, I think quite a few people in this room actually helped to contribute to this part of the presentation as well. Thank you for all replying to my LinkedIn poll. And it was basically a series of 5 questions I asked everyone in the industry, or as many people as would deign to answer me, which is very nice of you. And it was asking questions on how comfortable the facade industry felt about fire and how it relates to what we do day to day. And I've got the results. They will go on LinkedIn as well, just to share to the rest of the world, but I thought I'd give you the sneak preview. And without going into too much depth on the questions themselves, what essentially we got to was that we feel like we've got a pretty good grasp of how to design our facades to resolve fire. One key note being that we are somewhat less confident with a traditional masonry facade. We're not so keen on how that should be designed. We're much more comfortable with the modern facade design, because I would say that's what the majority of us, certainly in the sort of the professional services side of things, are used to on a day-to-day. But it is something that's of a concern. The other part, quite glad that on question 4, nobody said runaway. That was lovely. That was all to do with fire-rated glazing. As 38% of people surveyed were either fully or heavily restricted against working on anything to do with fire in the industry. And that really relates to our PI terms. So nearly 40% of us are really sort of like, oh no, we can't talk about fire. We don't do that. What I also did was I did exactly the same thing in reverse to the fire industry and said to them, okay, brilliant. You guys are what we are by virtue of our system being asked to look at from a facade perspective in order to advise us on how we should be designing these things for fire. And the results were a little bit more concerning. There was a good percentage of people who had a reasonable understanding of what the facade details are, how they go together. But equally, there was up to 25%, nearly 1 in 4, in certain cases, who felt they had no knowledge when it came to facades and the facade detailing, which actually reflects my experience since telling people that I work for a company which started in fire, and they say, well, there's fire engineers, and they're very different qualities that you can get out of one versus the other. The other, probably slightly more concerning thing, is that in the latter half of the questions, we focused a lot more on the technical performance, and 63% of fire engineers felt that they didn't have sufficient knowledge on how a facade actually worked. And we're talking about movement, structural support, all of those things which happen and sort of like technically do their job beyond fire, but also interact with the fire performance elements that we're putting in, which is, I think, quite a scary statistic in there. The bad, as we would put it. But we aren't taking it lying down as an industry. And I would say, without wishing to be the proponent of lots and lots and lots of regulation, we're doing a lot of good things with regulation because we need to, because we're not sorting it out ourselves. And so the golden thread, the Building Safety Act, the new Building Safety Regulator, it's all pushing us in the right direction. I think in the panel, we said, I think it was Danny from Yates, it was like the welcome friend, not the spectre. And I think that's perfect for describing what this is. This is welcomed. We need this, and it's going to force us down a route of doing things better. We will get more robust oversight because the building control system is going to change. We will get safer building designs, in theory, and we should, because competence is within the core, get more experienced and competent teams. But if I go back to what I was saying before, we still need to collaborate. It's the universal message. We need to collaborate more, and we need to share our knowledge. We need to be telling people what we know and what we don't know, but sharing that knowledge so we're all better at it. And now I'll give the little shameless plug on BB7. Because we want to be at the forefront of it. We realise there's a problem. It's one of the reasons why I joined them in the first place, is because there's a problem here and we need to fix it, and we all need to fix it. So what we're aiming for is a truly inclusive fire and facade consultancy. It's specialisms as their own right, and that's our focus, so that we're not missing things. We don't have gaps in the system, things that will slip through the net because PI won't allow us to. We're trying to break that mold and be a bit more innovative. I think Ange in CISC also said something about challenging engagement between consultants. That's the point. We're trying to eliminate that. Lisa put this building up earlier. We're actually working with Glancy's team on 19 to 97 Broad Street as part of our Stage 2 works. And although we are appointed for facade work only, we have brought that fire knowledge into the service that we're providing. We're doing the traditional stuff that a facade consultant would normally do. We're looking at architectural optioneering. We're looking at the thermal engineering assessments. In fact, we're doing things a lot earlier than how I've ever seen in my career thus far. Starting to look at bridging that Gurprit was mentioning before, right at Stage 2. But in addition to that, we're also engaging with and supporting the fire engineering, going, we know your struggles, and we know that you're flat out. Let's work together to get this right. So there is the north elevation of this building is actually quite close to the boundary. So what we did was we took an informal review of the performance of that and actually did the calculations to say, like, right, okay, right at the start, do you need fire-rated glazing? And then we can advise our client of this right from the off, because we know this as well as you do, and we can help you to deliver this sensibly and quickly, and we don't need to be waiting sort of for everything to get resolved. We're also, I've got to sort of like go for sustainability and sustainable practices. There's going to be that part of it. I don't think we can get away from it in our industry anymore, but we're also looking at this. It's something we're going to drive a lot more now that the CWCT's methodology is out. Thank you, Dave. And that's sort of really driving in now, and is going to be really reinforced in REBA 3 when we get into that as well. I'll come on to that in another couple of slides. The other thing we're doing is we're looking at combining our knowledge. Now, this is looking at supporting traditional construction, and it's something we did as a study for a SFS PIR, handset brick, block of flats. Nice, boring stuff. Lovely day-to-day stuff. But cavity barriers are not installed correctly. It's a nightmare, and it's prevalent in the building stock that we currently have. And the advantage of having facades and fire under one roof means that we can look at that, and we can look at it from the fire perspective of minimizing the progression of hidden fire, whilst at the same time also being able to consider durability, slumping, water uptake. I mean, if you look at blown insulation, it does uptake water. So how do we deal with that? And the solutions are there, but it's having the ability to do a stitched-up, joined-up approach under one roof that's really helped drive this forward. And we're actually in the process of looking into this and driving it forward. We're proposing a whole bout of testing that's going to be coming in the next couple of months. It's going to be about a 6-month testing program, really robust, but I think we'll have a solution which will hopefully mean that we don't have to start taking bricks off buildings in order to fix these hidden but prevalent problems. We're also doing a lot of knowledge sharing, as I mentioned before, at the minute in-house, but looking to get it out at a lower level, out to external audiences. And we're really looking at sharing our knowledge. The fire guys have taught me so much already, which is absolutely stunning, and they're teaching their own teams from graduate to senior over all manner of things. But equally, that knowledge sharing is in reverse from my side and also from external partners. It's a really great scheme, and when we do roll it out, I'll be shouting about it on LinkedIn. So yeah, you will be aware of it, I would hope, if you're in any way connected to me. But it's a great initiative. Sustainability again. We are keen on making this one of our most important driving elements in what we do. And everyone says fire and sustainability, well, that's like water and oil. They'll never mix. Like anyone who says, oh, let's build a timber building or a green wall. No, we can't do that. Fire says no. We don't believe in that. And in fact, we are desperately keen to prove that that is not the case. So we're currently partnering with Ecology, which is where you get these lovely metrics of where we are currently at the minute. But we're also driving, and this is across the business, environmental purchasing strategies and things which are driving how we operate as a business. It's not mentioned on here, but this is all part of our drive towards becoming a B Corp company. And really putting this at the heart of what we do as a business. So it's safety, but it's also ethical and social and sustainability, embodied carbon, operational carbon, the whole 9 yards. We want it. And what that means in a fire strategy is things like considering, well, do we need mechanical extract? Could we not get away with, I say get away, that's the wrong word, but could we not suitably provide natural ventilation instead? Could we look at the embodied carbon in materials which operate towards fire safety? There's basically no information out there. I mean, the guys at Siderise have been very excellent in early engagements on talking about embodied carbon in cavity barriers, but it's not something that in the fire industry is really ever talked about because it's all about life safety. And we want it to be about life safety, but also about ESG. And the ideal, when we get there, is that we want this to be a reality. Now, we had that wonderful City of Nature image that came up from Birmingham, from Simon earlier. And things like this. This is a building in Manchester. It's a Make Architects building. We sadly weren't involved in it, but I want to use it as a demonstration of where I think we should be and where we are engaging with the industry to get to, which is putting this on a building where we can actually say, okay, all right, brilliant. We are also, in addition to making everything fire safe, we are encouraging biodiversity. We are creating means of sequestering carbon. We want to be able to do this in Birmingham. We want to be able to do this UK-wide. It's fantastic. It's a wonderful idea. And like I say, we are engaging with the supply chain, the suppliers who created this green wall, and that is an actual picture on the right. of what is going on. This is Eden in Manchester. Advise you all to go and have a look. Very, very impressive. So basically, that's the sum and total. I think I'm like very slightly early. But basically, yes, there is an ugly truth out there. There's bad situations where we currently are. But what I would like to think is that we're all heading in the right direction to deliver something good. Thank you very much.
Thank you, Iain. You said only 63% of fire consultants don't understand facades.
From a technical performance standpoint.
I thought it was much higher than that. Sorry, fire consultant. Thank you very much.
No, thank you.
Thank you. We'll move on to the next presentation, and it's going to be from Miguel Silva. Miguel will talk to us about saving lives through non-combustible membranes.
Yeah,
great.
Thank you, Steve. Really nice presentation, Iain, and sharing some figures about our facade community. And I don't know if it's not going through. Yeah. So good afternoon to all. First of all, it's really a pleasure to be here at Birmingham City, being part of this facade community, and Birmingham as well. So today we'll be speaking. My name is Miguel. I'm FS's head of specification. Today we'll be speaking about technology breakthrough on facade weatherproofing, and we'll be speaking about who is FSS, how can we help you. And we'll have an insight on non-combustible breather, also on non-combustible airtight vapor control layer. I'd like to introduce a massive technology breakthrough combining elasticity, elongation with fire. And then we'll be speaking about the importance of having a really good surgery and a design review in early stages. Okay? Ephesus is knowledge and experience, a lot of experience in different types of facades, in UK, all around UK, and even worldwide. Ephesus, our DNA and our culture are very focused on the client, We work to the client, we fight to the client, we brief to the client, and then we cross, based on our knowledge, our experience, we breach, we clash a specific need, and then we deliver, we try always to deliver a disruptive and high-value solution. This is what we did with the fire subject, bringing the non-combustibility to the facade weatherproofing. Okay? These are some pictures from different fires, and then it's important to highlight that the fires are happening almost everywhere, almost every month. Okay? So, but careful, and it's something that I need to say. There are some situations that bringing non-combustibility to a product means that we are losing some technical performance, that we are doing a compromise. And not with FSS, and I'd like to say here today, we are able to control water, air, and water vapor with a high confidence, okay? And this going into the products, FSS Breather FR, it's a waterproof, very vapor permeable. It's important to highlight that means breathability, and we should be looking for a value below 0.12 meters. Also, air tightness. It's such important, and we see today that the importance of having air tightness and minimizing the heat loss on the facade. And it's possible to control water, bringing air tightness to the breather membranes. The Breather FR is also Class A1, highest class in terms of a fire, looking for the product itself, and also as the overall system, and today I'll explain what it means system for us, has achieved A2, S1, D0. The membrane has a very good tensile and adhere, behave, very important take into consideration due to the fact that the membranes are exposed to the wind, so the wind load will hit the membranes, and also UV, it is something that we should be looking for, and this solution could be permanently exposure to the UV. FSS Vapor FR is an airtight vapor control layer. It's a membrane classified, the membrane itself A1, as a system A2, also airtight under 600 Pascal, including all the ancillary items. Sustainable, we have achieved LEED BREEAM exemplary level, and it's important that it's not only the membrane. And I have this slide that membrane is a small piece of a big puzzle. Membranes are installed with the tapes, single side, double side, are installed with the sealants, with adhesives. If we don't treat them well, if we don't consider them, we may have a fail. And then the entire system will fail, okay? So here are some pictures, and for instance, an example on the concrete. We massively use single side, double side acrylic tapes, and then they will fail on the concrete. On the concrete, we need something with adhesion, something with volume. And then otherwise we will miss, we may have a water ingress, we may have a heat loss, energy loss, and we may have interstitial condensation, okay? Tested. So it's very important that we officers, we tend always to challenge ourselves and replicate as much as possible, and using the standards to replicate the reality on site. And this is two examples, one of them on the tightness and the other one on the fire. And we replicate, again, not only the membrane, but the membrane including all the ancillary items, replicating, very important. We should be looking for a fire test and a product that replicates my project, replicates my facade, okay? This is what we should be looking for. And then approved, such an important complement of the testing that generally are made for the independent local, in this case BBA, one of them. And again, we have the BBA certification not only for the membranes, but the entire envelope with all the ancillary items, okay? Installed, we are using the membranes all around UK, London. These are some projects from North, Manchester, Sheffield, Liverpool. And then this is passing this confidence that the material is complete, membrane system is complete, it's well tested, replicating, approved by independent organizations, and confidence that the material behaves, okay? Then, this is the second need, that FSS interface is still a challenge, and it's a location that we should be looking for a membrane or interface membrane that manage well water, air, and water vapor, whilst having fire performance and whilst having elasticity and elongation, okay? And we are FSS, we are happy that after 7 years of intense work, we are able to deliver disruptive ProFlex FR, a very disruptive technology that combines elongation and fire. Okay, ProFlex FR is a membrane watertight, W1 the highest, tested under 2 kilopascal, very robust. It's a membrane with 1 mil with a high tensile in the tier, very critical in these locations. It's also very airtight and vapor, sustainable, color white. We decided the color due to the fact that to be, first of all, distinguished from EPDMs, okay? And it will allow the Q&A, the supervision, the guidance to easily identify the seams, easily identify the overlaps, easy to identify if there are a crack, okay? And also it's possible to customize in different widths. And this is one of the main features of the product that has a really nice balance between elasticity, elongation that accommodate building movements and combining fire performance in a very, very robust membrane, okay? And as a system, we were missing the last piece of the puzzle. Now we are able to deliver a full entire facade weatherproofing envelope, externally breather FR, internally on the warm side of the construction VCL, airtight VCL, and now treating well the interfaces. These, as you could see, it's not only the membrane, there are a lot of accessories. We are able to simplify them to minimize the quantity of accessories and will allow us to have one source, one design in early stages with the architects, with the facade consultants, one quality control, coordination at site, and one project warranty, okay? And then consulting, we feel really important. And today we spoke a lot collaborative work in early stages of the project, and we believe that we could collaborate a lot. We could bring our knowledge to the detailing in stage 2, stage 3, stage 4, and then this is what we do. We detail, again, not only the membranes, but the membrane systems. We do surgeries, project-based. We do a compatibility assessment, understanding what are the substrates. Then we make sure that all the accessories are well designed. And here there are 2 examples, and allow us in that stage to identify what are the tricky locations, what are the locations that we need a different solution, perhaps. Okay, this is one of the projects, a curtain wall, a prefab perforation, and then we decided to develop, due to some sequence of installation, to produce a half sleeve. The same happened on this project. It's a normal project that we work with our client in ASUS, very good, and then promoting also prefabrication, and then we come up with a 3-dimensional piece to solve a very complex intersection, okay? Also, we use this work in early stages to produce documents at site that will help to guide not only the site installation teams, but the Q&A, and then we use them to train well the teams and supervising. And again, it's very important. We could, having the good company, we could have the right product, we could have the right design, but in the end of the day, it doesn't work. So it's very important to have a coordination, end-to-end process from the day one on the execution side. Also, this is what we believe. We are against to send standard method of installation. We prefer to have individually a project-by-project approach that we produce method statements, very, very simple, with small sentences, step by step. This is what we believe, and then they are able to understand that site and deliver next day when we are not there. Okay? As a recap, so FSS really could help you on your projects. We could use the entire full envelope system to save and to minimize fires on the facade world. And then we spoke about the importance of having a really good consulting from stage 2, stage 3, stage 4, follow through, end-to-end process, and very good coordination, okay? And to be honest with you, there will be architects, engineers that will choose something, and will be professionals, very good professionals that will choose the right products on the right application, protecting the end users, the future-proof, and in the end of the day, individual. Now, Building Safety Act will come into action, then protecting the individual liability and corporate PI. So, thank you so much. It was a pleasure to be here, and have a nice day. Thank you so much.
Thank you, Miguel. Well delivered and in time.
Thank you, Steve. Thank you.
Bye-bye. Our last speaker before we have a coffee break is going to talk to us about powder coatings. Naveen has been around the block a few times now, knows everything there is to know about powder coatings. So I leave it with you, Naveen.
Appreciate it. Thank you, Steve. Afternoon, everybody. Hope everybody's well, enjoying the event. Yeah, as Stephen mentioned, I'm the UK specification manager and Ireland, for my sins, of AkzoNobel powder coatings. And today I'm going to start off with a rather gloomy picture. rather representative of what's going on out there, unfortunately, but also representative of a period in architecture where facades were somewhat conservative, lacking in vigour, and much like this scene, rather grey. Yeah, as I said, unfortunately, it's what happens out there today. Okay, screen has not malfunctioned, don't worry, okay? This, in actual fact, is the evolution of the most popular powder coating colours over the last few decades in the UK. And as you can see, we had a bit of a lull period from kind of 90s towards the middle part of the last decade where the market started to veer away from colour, okay? You couldn't walk down the street without seeing a building in anthracite grey, unfortunately. But in the last year or two, things have started to change. We're just coming out of that cycle. Shackles are coming off, and it's encouraging to see that that's happening. Right, yeah, interesting take here from our friend Matisse. Yeah, ultimately, colour is able to characterise and shape its subject. It's able to give, hopefully, a first impression and also a lasting one, and it's able to stamp its own unique imprint on the building. But as we know, it's quite a collective process to try and agree at colour. It's quite challenging because it's quite a subjective field, yeah? And that process can be quite drawn out, quite lengthy, and yeah, you end up having too many conversations just about colour. But it evokes a lot of emotions in people, okay? Now, we're just an hour after lunch, so the carbs are probably going to start to kick in for you now, right? Okay, so I'm just going to make a little bit of a game, just a little bit of interaction, so just to ensure that you're still with us, okay? And all it is I'm going to show you 3 pictures, 3 different buildings. All you got to do, just guess the colour. That's it. That's simple, okay? So, first one, relatively easy, hopefully. What do we think that could be? Any guesses from anyone out there? Pink, yeah. Okay, well done, yeah. I started with this one first. It's hopefully quite recognisable. That is our dear friend King's Cross R7, the unmistakable King's Cross R7. Yeah, a building which has become a source of inspiration for many that we see out there today. Okay, well done. You got that pretty quickly. Right, next one is 3 variations of one colour. Any guesses what we have here? Anybody? Oh, this is getting a bit tricky now. Nobody? Any colour? Bronze, blue? No, you're all wrong. I'm not sure whether Ange Francis is still in this room. She should recognise this building. This is, in fact, oh yeah, you can see, right? Yeah, yeah, quite bold, quite dramatic, and certainly stands out in Rathbone Market if you know that area. Okay, right. Last but not least, just a single tone of this one. What do you reckon this one could be? Oh, yes, well done, sir. It is gold. It's a cinema complex in Hounslow, of all places, would you believe? Okay. But no, look, simple exercise just to prove a point about how big of an impact colour has, okay? So the message is, embrace it. That's all I can say. But in the world of powder, colour doesn't just operate in isolation. You know, it has a couple of accomplices which bring an extra level of dimension. And one of those is texture. Yeah, that's quite close, isn't it? But it can either be fine or coarse in nature, rapidly growing in adoption over the years, one that gives a more refined feel to the substrate. But it also has the beauty of hiding a lot of sins on the surface, which we like. We like that sort of thing. Yeah. So that's texture, but it has another partner in crime. And that partner in crime is metallics. Okay. And immensely, hugely popular finish choice, and one when viewed under the microscope looks like this, almost extra stressor-like, you could say. But these particles that you see here, they play a massive role in the behaviour of the applied component, particularly when you look at it from different daylight conditions, different angles, and I've got a short illustration to show you shortly. But before I do that, yeah, there might be some puzzled looks in the room right now. Yeah, we're way past breakfast time, but bear with me. If you think about those metallic particles, they're like a cornflake, okay? And you think about a cornflake, relatively irregular, rough around the edges, and they're certainly not flat. So when powder gets applied, the metallic flakes, if you want to call them, they don't land and deposit on the surface in a linear fashion. And that causes some interesting results. Okay, so I've got this illustration to show you. So let's just take a surface profile of a texture where you've got your peaks and your troughs. You then start to embed some of those flakes, metallic, and what starts to happen is this wonderful random refractions coming off the surface from the incident light, which also could be the borrowed light sometimes. And what this does, it creates sometimes a subtle, but sometimes a quite dramatic shift in the tone, okay, depending on where you see it and the angle of that incident light. And we've got a couple of examples just to give you a flavor of what we're talking about. So here we have a fine textured black metallic applied to these undulating panels. We've got 3 images, 3 separate sides of the elevation. So in certain lights, you start to see it kind of almost absorbing the light. In others, it kind of starts to reflect it a little bit. And then in other parts of the build, you're getting this kind of weird gloss, sort of shimmering quality to it. It's a bit of a trick of the eyes when you see this, and this is why we always stress the importance of looking at finishes in different daylight conditions, because you can get some pleasant surprises or shocks. And here we've got another fine texture metallic combination for this leisure centre. You get this kind of dramatic, quite dynamic shift in the tone from one side of the elevation to the other. So just a few kind of examples as to what we're talking about here in terms of the role that metallics can play and textures. So talking of metallics, as I said, hugely immensely popular finish choice, and the one that tends to be the go-to in the market are those which mimic anodized aluminium. But it does so without the associated pains. Okay, so it's giving better finish consistency, peace of mind when it comes to repairing on site effectively, and doing so without breaking the client's budget, which is always helpful. And it's leading to installations like this, where you're kind of getting a more, natural feel to the surface, to the aluminium, again absorbing the light, but still keeping that key characteristic of that tonal shift, which is obviously what people are usually after. And in the spirit of a project like this, we've got a couple of projects at the moment that we're working on in Birmingham, one of which Dav covered earlier this morning, the Octagon Tower sitting at the apex of Paradise Circus. So we actually worked closely with the Howells team, I've got to say that right today, Howells team, and we were tasked with creating a bespoke finish to try and really enhance and elevate these large feature spandrel panels and columns. I think what we've come up with is something which really befits it, gives it that kind of premium quality that it deserves, and yeah, can't wait to see that going up later this year. And then what these metallics are also able to do is able to change and help the transition from a more brutalist architecture to more contemporary. So I'm saying the word brutalist. If anyone's local to here, this is opposite New Street Station. You know exactly what I'm talking about. Those concrete buildings will soon be transformed to what you see here. And you've got this combination, these really low gloss metallic silvers and charcoal greys combining really well and bringing things to the 21st century. Right, last few years, we have entered the world of masonry, okay? Some laughs in the room there. But if I put forward that notion, let's say maybe 4, 5, 6 years ago, probably would have been laughed out that door or that door, okay? But times have changed, okay? And when you take a step back and really think about it, for most people, moving to aluminium is a bit of a godsend. Almost every concern is eased in most cases. And there's no better illustration than the first project to kind of fully adopt this approach. So this is a building where you could easily just walk past it, unless you went really close up to it and interrogated it. You probably assume that was GRC or precast or recon stone. But it's not. It's free mill aluminium using a stone effect finish. And this is almost what we call our project's genesis. This kind of kick-started the whole market, proved the concept. And the key with all of this is the devil is very much in the design. You get the design right, you configure it properly, you keep that sense of mass, that sense of bulk and solidity, and you align it with a strong finish. You're on to a winner. And that's because the value proposition is so strong. It's ticking so many boxes for so many people. You're making huge reductions in material weight and material cost. The installation journey becomes far more straightforward. Replacement journey, if required, becomes more straightforward. And you don't really need to rely on big, heavy machinery or as many people as you normally do. And you look at this, and it makes quite a compelling case, which is getting harder and harder for people to ignore. And off the back of that, we've had many projects following the same footsteps. Again, another project which Dav covered this morning, the cool towers at Wardian. You can imagine the savings made across these two towers. QS would have been having a field day with this. But it's doing so, really, without compromising aesthetic integrity or durability. It's actually enhancing it. And it's also helping something more closer to home. So this is a former bomb site, which has been underdeveloped since the Second World War, soon to be transformed, and will soon house the first stone effect installation in this city. So again, something we're really looking forward to see. Okay, where are we going? Trajectory, I think, as I mentioned, I think the impact of colour, the infusion of colour will play a bigger part, for sure. As I said, shackles are coming off, patinations will be kind of sought after, and the clamour for us to mimic other building materials is only going to grow, whether that's timber, whether that's copper, terracotta, much more besides. So that's certainly where direction of travel is. But for us as a business, Axel & Bell very much committed to sustainable architecture, and one of our key focus areas is to reduce the urban heat island effect. On a day like this, it's probably not the best day to talk about this, but this is obviously where inner cities are experiencing much higher temperatures than surrounding areas. And obviously those buildings in those city centres are using much more energy to keep themselves cooler during the summer months. So we've actually got a technology which essentially contains these kind of reflective pigments, which deflects the infrared light from the sun, which is the main heat buildup, cause of the heat buildup, and it essentially makes the part that it coats cooler, and any interior spaces that part coats also become cooler. And when you compare this to a standard powder coating technology, you could be looking at up to 7 degrees difference in surface temperature of the component, and up to 3 degrees room temperature. And when you think back to last year, that really intense period that we had, experts obviously saying that's going to become more and more commonplace. So we very much see this as a solution which is really going to help going forward. So obviously for us, very important to be transparent when it comes to carbon emissions. We do that through our EPD. Now this is something which is independently created and recognised, and it shows the impact of our operations from us, our upstream suppliers extracting the raw materials, us producing the powder, sending it to an applicator, and then pre-treating it, applying it and curing it. So it's like it's a cradle to applicator gate summary, I guess you want to call it. And now we're into our third EPD, and with each passing one, embodied carbon is getting lower, and that's obviously what we try and strive for all the time. But just to end on, there's obviously got to be some substance to all of this. How do you ensure you create a lasting impression? Because what we see in installations like this, from the 80s, from the 90s, from the noughties, you're starting to get this premature breakdown. If you're the building owner, you've only got 3 choices here. You can either leave things to get worse, or you go down the cumbersome route of recoating, or the even more cumbersome route and more costly route of replacing. That's a choice they don't have to make if the right grade of powder is selected from the beginning. Okay? And when we're talking about the right grade of powder, we're talking super durable powders, or class 2, some people call it. So it's a more enhanced polyester technology. Probably best way of describing it is it's like a factor 50 UV protection. That's probably the best way of describing it. So this gives you your aesthetic longevity. Great, box ticked. That's only half the battle, guys, right? 'Cause there's certain fundamentals beneath the coated surface that you really need to look out for. So this is very much talking about your pre-treatment of the surface. That's the lifeblood, that's the oxygen. That dictates the whole coating performance. So you've got to make sure that's robust, and you've got to make sure it's done at the right place. In the UK, you've got 3,000 people that can powder coat, but only about 50 or so are approved. And there's some in this room right here. So really make sure the work gets channeled to those guys. And almost like your car, you've got to semi-look after it as well. The odd clean down here or there, kind of mitigating any cut edges and drilled holes at the start. And when you combine all this, this is when you start having a puncher's chance of meeting your design life expectations. whether that's 30 years, whether that's 40 years or more, this is what you need to do. Because ultimately, there's nothing that's more sustainable than something that lasts and getting it right first time. Right, so, okay. So this is our friend, Charlie the chameleon. So kind of like adopted mascot, you could call him. But Charlie the chameleon here is quite an apt technology for what, an apt analogy as to what powder coating is all about. You know, it's colourful, it's versatile, and it's able to mimic a number of different things, okay? I guess I've got to put it out there that no chameleons were harmed during the making of this video. I guess I have to say that, but yeah, you kind of get the gist of what Charlie's trying to do. Yeah, I think we're getting to the end of that video. There we go. And yeah, obviously we've got our table set up outside where you can see a number of these samples, and based on what we talked about today, we've actually got a few design spaces in and around the Birmingham area where you can get further inspired, and a team of people on hand talking to you about the facade detailing. So yeah, it'd be great to see you out there by the disco lights, you can't miss it, or in one of these spaces. And that wraps me up. Thank you very much. Any questions?
Thank you very much, Naveen. That's well delivered and very clear. I'm sorry, I misled you earlier. It's not coffee break. There's 2 more presentations before coffee break. We have Aneel Kilaire from Ramboll first, who will talk to us about Revolution Residential.
Thank you. Thanks, Stephen. Okay, everybody, I hope you didn't need that caffeine hit, and you can stay awake for this one. So, Revolution Residential is going to touch on a lot of the themes from this morning of how we're going to navigate Part L and lots of other regulations that have been coming. I just mentioned it's put together by myself and other colleagues in the office, where we've been arguing a lot about the right way forward. So, a little history of Part L, where it's come from, some of the consequences of Part L, and then the big issues of the day, of overheating, whole life carbon, and that whole compliance route, and then some ideas that we've been thinking about of how to solve this issue and maybe start again. So, it started in 1984, Building Act, where they sought to just secure the health, first thing, the health of people, their safety and their welfare, and then the conservation of fuel and power. So those are the key ideals that they sought to achieve. And for the conservation of fuel and power, as most of you know, it's reasonable provision for limiting losses through the thermal elements, through the building services, and efficient building services. So that was the starting point. And over time, that's changed and it's become more sophisticated. We initially just had elemental methods where if you had a U value, I think it was 0.47 initially for the opaque walls, nice and easy, and everyone went through that. You've got your backstop values, which were the values that you needed to achieve. Small builders, super happy, great. And then 2006, there was always an alternative method, and then that became mandatory, where you had to do a whole building carbon emissions calculation and compare it against the notional building. And that created this whole army of SAP engineers for every single dwelling. It needed a SAP assessment to show how it complied and it conserved fuel and power. And over time, that was made a little bit stricter. And 2013 is when we had fabric energy efficiency targets. People were a bit worried about if you start adding PV or you start adding more efficient technologies, the fabric won't perform as well as it should. And that sounds great. I've got no issue with that. That's all good stuff. Let's make that fabric work as good as it possible can. And it touches on, these are all with, I like the expression, the operational carbon goggles. Those are the only ones that have been available up until this time. And 2021, even more stringent targets. Let's make this even more difficult to achieve. Isn't this fantastic? We are going to conserve lots of fuel and power in our buildings. And at the heart of it, since the SAP assessment came, was the notional building. This is how we design the fabric. This is the way to do it. You've got your external wall values, 0.18, which we can't do for curtain walls, for unitized. Very difficult of achieving that. You've got windows and glaze, now we're up 1.2. So that creates other issues that we need to look at. And then the thermal bridging approach. And that is now, as Gurprit mentioned, you've got to have a linear approach. So for our development of 300 dwellings, let's calculate all of those psi values. So let's have another army just to do psi values. Yes, more work for us. And this notional building, this only one notional building, can we do the balconies that are supported from the ground on 24 floors? It's very difficult, but it's just still one notional building. Doesn't include for the parapets, doesn't include for the balconies really that well. But that's how Part L's telling you to design. That's the comparison. Let's do it in this way. So it drives you down some strange roads, really. It can drive you down triple glazing, which okay, fine. It can drive you down having no openings. We were like, oh, telling the curtain walls, all framing. Let's have bigger units. Let's take out the ventilation. Let's get that U value down. Yes. You give me a U value, I'll make it work. I'll put insulation behind there. I'll put insulated linings. We can get that U value down, no problem. Might have a condensation risk. There's no fresh air coming in, but we've got that U value. Give me a challenge, I'll accept it. But that's the consequence. I think on the panel they mentioned buildings have been overheating. It's not a new phenomenon. Our buildings have been overheating for some time. And we just haven't accepted it. We've seen the acoustic reports. We've all seen them where they say, you can't open windows. It's too noisy. Yet it used to be the case, the overheating strategy said you could open the windows, but the two weren't aligned. So it's not a new problem. It's just been under the radar. And now everyone's like, yes, we've done something about it. We've got Part O. Part O's here, and it will stop us overheating our buildings. Congratulations. Well done, government. You stepped in. That notional building. Damn it. That notional building does not work for overheating. It doesn't work in Nottingham, doesn't work in London, doesn't work in Leeds, doesn't work in Southampton. It doesn't work anywhere. And if you use IES, it's probably not that bad. But if you use other software, TAS or Energy Plus, which has come out from some of the post-occupancy stuff we've also been doing, it's even worse, so we're probably under-egging the amount of overheating if you're using IES. And again, on this building, which I can't specifically mention, there is also this phenomenon of the apartments nobody's in during the day, they're really heating up, and there's additional gain into the apartment. In the model, it's adiabatic, no heat transfer. So it's even worse than the worst models, this notional building. So that's what Part O's done to Part L. It's really, really, really difficult now to align those two. And it's just come from nowhere, just like that phantom punch Muhammad Ali gave Sonny Liston. But it's the right thing. Part O is a good regulation. I think it's really well written. It considers lots of things like security. It considers the noise limits, and it's got a reasonable G value of 0.4, but some of it is really interesting. 95% of glazed area openable in a high-risk location. So if you're in a city, London, your glazing has to open 95%. And then some of the glazed areas that they recommend, this is just on the straightforward approach, quite low glazing areas if you do that. And then you've got the G values of 0.4. So the two don't marry up, and in a lot of cases, they're not really achievable in London. So this is where we've got to, and I think a lot of people have experienced this with the new SAP methodology, the new version of Part L. It's back and forth, and different people are doing different bits. There's someone doing the SAP assessment, there's someone doing the overheating, and then we're looking at ventilation, the purge rates, the mechanical mechanical ventilation. And then the architect's got to resolve the windows. We've got 100 millimeters restricted because we're worried about people falling out. So it's really confusing. What do we do? And just to illustrate, this is what we've done on Canada Water, where we're the facade engineer. Our are doing the a lot of the thermal assessment and the MEP. But just to illustrate, that G value, that is significant. If you change 0.63 to 0.4, you get an increase on 9% of your dwelling fabric efficiency. So that's bad. It's using more energy, okay? So what do we do? Now our apartment is using more energy. And where's most of that heat loss occurring? It's in the windows. We've done really well on the thermal bridging, GURPS. We've done really well. But it's the windows. So what should we do about the windows? Okay, why don't we use triple glazing? Okay, sorted. Triple glazing. Let's get an extra pane in there. And that's resolved it. So we're going triple glazing. Another scheme in-house, they're actually adding cooling. But I'm going to leave that to the side for this presentation. But they're using cooling. We've gone the triple glazing route. So here is an illustration of how much operational carbon we've saved in 1 year. And the other is how much extra embodied carbon we need for that glazing unit. And that's done to the CWCT latest methodology, which is very good. I don't know if Anna's here, but Dave's here. But it's very good. It includes production of the unit, the PVB interlayer. And that's harmonized across everybody. We're talking the same language. So what that means over time is this. So in 5 years, we've paid some of it back. 10 years, we're not halfway. 15 years, just over halfway. And we get to 25 years, it's probably time to change the glazing unit. But we've not paid it back. That extra embodied carbon, as people have touched on, is really significant. It takes a lot of energy to make glass. And maybe that will change with recycled glass and things like that. But then we've also got the opposite, that the grid is starting to decarbonize, and these are based on current grid factors. So did we really achieve what we set out to do for Part L? Did we conserve fuel and power? I don't think so. I think we have passed this point. I've done a similar thing with the opaque walls, but I really think we have passed this point. And this is, Simon Sturgis wrote about it years ago, targeting zero. We keep putting extra energy into the facade, and we're not saving very much. And I think we all know that now. Well, everyone in this room knows that, but that's not reflected. Now, this is a bit different. This is something that Adam Sandler's really passionate about, and this is this target fabric energy efficiency. So that metric for saying that you've got a well-designed facade. So if you take different dwelling typologies, your detached house, semis, mid-flats, you have a different target, and that's related to the form factor. Obviously, there's less facade. Why not have a more stringent facade target? Okay, so on the flip side, that means you build a flat in the city centre. You don't take up much space from the surrounding landscape, but you have a higher target to achieve. I'm sorry, a more stringent target to achieve. Your facade has to perform much better. Okay, and then the other things that we really don't like is this Y value. You know, maybe technology will resolve that, but that really damages a lot of the development as well. We're building at Canada Water a load of apartments, 6 blocks on top of Tesco Superstore. Okay, so it's a great use, great urban design, great use of land, but that does make the structural design really difficult, and we've got to have continuous slabs for the balcony, and we have to wrap those slabs. So we're really penalized on thermal bridging in that area, which again is pushing us to more fabric energy, more fabric measures to compensate. So, yeah, that's something that is not really taken into account. I don't really know whether that can be resolved with modifying the notional building in some way, where can we have a bit more leniency on apartments given the typology that they are. So hopefully I've shown you how Part L has really made things very difficult, and when you add on the other regulations, then we're in a very difficult spot right now. And there's some things that we've not really discussed, and they are on some planning applications, but does it affect the views? Does it affect people's health and comfort not having a window? Does it affect the daylight factors? Do we really want to rely on that MVHR system? On Canada Water, we are supersizing the MVHR system, and we're adding an additional fan. So there's an additional maintenance requirement, potentially additional noise for those specific units. So it's not all good, in my opinion. And it's really challenging the overall viability of this scheme because of those moves to triple glazing, looking at all the thermal bridging, all of those kind of things. So I'm really confused. We started off securing the health and safety and welfare of people. Now we want to open windows 95% for people to fall out of. And you might think first, you put your engineering hat on, think, no problem, I'll put a screen on there, I'll put a perforated panel, it will take the barrier load. And the security guy comes, says, is that past 24 tested? Okay, I'll get it tested. It goes, and that's sorted. Oh, it goes back to Part L. Right, we had G value of 0.6, Aneel. Is it 0.6? With your glazing and that perforated panel. I was like, 0.6 with a perforated panel? I don't think so. I think it's going to be about 50%. Before you even look at the glazing, the perforations are going to have to be around 50%. So it doesn't really work anymore. And I think we need to start reviewing it. And I'd like to stop there, but I won't stop there. Because we've been debating what to do about this in the office. And I think one way is, shall we go the other way around? Shall we start with ventilation? Adam Sandhu, he's the passionate MEP, thinks ventilation is the key to allow people to open the window. And you start from there. And you prevent people falling out. You make sure the overheating is resolved. And then you do something with Part L to reduce the energy usage. It can't be the current notional building. Maybe that can be changed to make it more project relevant. So you're still driving a high performance facade, but you're not endangering the other key issues that you have. And then, that could be the 2025 future building standard. It can't be a further tightening of those standards. That will just make it even worse for us. But the key requirements are missing in this route. And those are, as we said, life cycle analysis, that whole life carbon perspective. And it's the daylight and sunlight. So version 2, let's add those in. Let's put those in, and everyone comply with that. Okay. Now, who's not from Coventry and has been on the ring road in Coventry? Okay. So my fear is, so if you ever go on this Coventry ring road, you have no idea when to get off, which lane to get in. You are just so confused about what to do. And I've a lot of family in Coventry, so I visit there regularly, and I still don't know where to position myself on the road. And I fear that if we add those 2 regulations in, this is what's going to happen. We'll be even more confused about what we can do. Maybe, maybe not. Maybe we can make all sense of it. But the thing for me is there's a model, there's a SAP model, there's an overheating model, then someone else is doing a daylighting model. And it's just a bit of a car crash. It's taken us the best part of a year on Canada Water, and I know Broad Street's got similar issues, to try and resolve all of this. So what else could we do? Now, for that, I think we need a perspective. Everyone talks net zero carbon. Let's 2050, 2030, let's get this net zero carbon, our buildings perform to net zero carbon. But for me, if we get to net zero carbon, we're not going to have any dent on the carbon emissions. Where we can have a bigger impact is if we set an example for other countries or other developing countries, other markets, say this is how you do it. And I don't think you're going to do it by, and one regulation, another regulation, another regulation. This is how you do it, guys. Take that, and that's the way to do it. I don't think that's a coherent set, a coherent process for other people to follow. Another part of the work that we do at Ramble is this Happy Homes initiative. So they've been looking at 2 developments. You can have a look on the web. But they've compared some development in Denmark with some in Birmingham. And this is what they found. If people are happier in their own environment, they live longer, they're more healthy, they're more productive, they're more engaged, they're more social. And that's the key aspect of what we need to provide in our homes. So can we come back to this? And that for me is almost where I started in my career, building services, where you got out CIBSI Guide A, and I was told to just read through all of that. What does a comfortable environment mean? And back then, it was building services did all of this, yeah? But now I think we need to go back to that and say, okay, we need daylight, sunlight views, thermal comfort, acoustics, ventilation, the right amount of space for people. These are minimum standards. You don't go away from those. And then once you've got those set, you then get away, forget part out, forget all of that stuff. You do your whole life carbon optimization, and you apply reasonable provisions to minimize CO2 emissions in that way. And you also have a cost payback approach for every single measure that you try. Let's have a look at that cost payback. So for markets like Birmingham, where we've got a housing shortage, we're not building enough housing, that can be key to just get development going at a faster rate to house people. And that can be done with parametric tools. We've got a shoebox model where we can take lots of different parameters and we can change them very quickly rather than the SAP approach where, right, let's try that U value, let's try this air permeability, let's tweak this, You can do that very quickly with parametric tools in Grasshopper. And that's what we've worked on. Oh, I've gone slightly over. But yeah, that is the last slide. So yeah, that's it. Thank you very much.
Well done.
Thank you.
Thank you, Aneel. I think you've confirmed to us what most of us probably already knew, that we are over-regulated. A lot of these new regulations are conflicting, and it will probably take us another 5 years to probably cancel a lot of these new regulations or modify them in some way so they are usable.
Yeah.
But thank you for explaining that so
Cheers.
eloquently. And final presentation before coffee break is from Drew Fentiman. Drew is from OBEX, and he will talk to us about compliance, Class A compliance through wall construction.
Thank you very much, everybody. Welcome. You've got this far. Well done. No, I found it very enjoyable and informative so far, so I hope you all have too. My name is Drew Fentiman from OBEX. We produce fire-rated membranes and through-wall system. And today wants to just do a quick, brief focus session on membranes used within facades. And the big question, I guess, that's in all of our minds is how long until we can achieve a fully Class A through-wall build-up. Just to touch briefly on where we're going and the reason why we exist. It's focused on creating safer, higher performance buildings with longevity. That's our purpose, and we're very, very, very focused on it. Today we're going to cover just 3 specific areas, just a little bit touching on the regs. I'm not going to try and teach my grandmother to suck eggs. You would know, most of them here would know more than I do. But we'll touch on that, and then the importance of specifying for fire and performance, both elements, and then finally the missing piece of the jigsaw. So understanding the regs. I think it's clear there's been a lot of confusion around them, and we're here to try and tidy that up. And I think most here would know that Reg 7 is applicable to interface ceiling membranes and the facade industry, and most also know that the headline regulation for all materials is the external wall is to achieve a fire classification of A1 or A2. Now, we know there are some exemptions from this requirement, and although not all items are exempt. Approved Doc B, as we see it, states that membranes must achieve a minimum of Class B S3 D0. This is a performance requirement set by the government. Now, in our day-to-day having to do with the industry, we often hear people saying, well, we've had XYZ products signed off by the client, the contractor, the consultant, and so on. But the fact is, the simple bare fact is that no one other than the local authority can give the dispensation to move away from what is stated in approved Doc B. So we're in a dangerous area. The danger is that focus on fire classification takes precedence over the membrane's primary function. The industry, unfortunately, is tending to force the emphasis onto fire classification. Much as we know it's important, whilst it's critical, we hope that it never has to be proved in anger, as we say. The reality is that the weathering performance will be tested on a regular basis almost immediately. So it is very, very important to remember this element. The costs associated with legacy issues far outweigh the initial outlay of using high-performing, correctly specified interface ceiling membranes. And that's the point we'd like you to take away, is that value engineering only has so much value. So where will the onus for these costs lie that we talk about, the legacy costs? The industry is still feeling the pain of huge change since 2017, and we feel that product innovation is at the forefront of this process. We see plenty of breather membranes out there, posing as interface ceiling membranes, being used on a daily basis, which is scary. Disregard for water tightness, it's not innovative or smart. So water tightness, clause 5.5 of EN 13984, as we all know, requires a pass under 2 kPa of water pressure for 24 hours. It's nothing to do with W1, W2 or W3. It's a pass or fail. Up until now, it's only been possible to achieve Class B for EPDM replacements, alternatives, as interface seals. That's been so using our 0500 EPDM alternative membrane. But today, we're bringing to the industry Cortex 0200 FR interface ceiling membrane, which completes the fully Class A system. You would have seen it around today, and there's samples and information available on our stand, just on the left as you go in the room. And there's plenty of information to take away, and we're very happy to consult and come and sit down and talk to you about it, and talk you through how you can achieve a fully Class A system using our membranes and through-wall system. Thank you very much.
Well ahead of schedule, Drew.
Well, keep it simple, that's the aim.
Well ahead of schedule. Well done. Thank you. As Drew said, the team from OBEX are outside. They can help you with Wi-Fi as well as good information on membranes.
Thank you very much.
We are going to take the coffee break now. Welcome back, everybody. We have sound at last. Welcome back. We're going to start our final session, and we have Michael is mic'd up and ready. Michael is an associate at BDP, and he will talk to us about old buildings and new beginnings. So, Michael, over to you.
Thank you. Do the long walk to the screen. Okay. So yeah, thank you for the introduction. I'm Mike. I'm an architect associate in the Birmingham BDP studio, and I'm here to talk today about Old Buildings, New Beginnings. As the title suggests, it's a focus heavily on refurbishment and the work we do around it, and how we can inject the new life into our existing building stock. I'll talk across 3 key projects, one in Canada, one in Cambridge, and a very local one down in Digbeth. Okay, so who are BDP? So we're a collective of engineers, architects, designers, urbanists. We design at every scale, from city master plans down to individual buildings and even specialist bespoke lighting and acoustic installations. There's over 1,200 of us internationally. We have a 60-year history as a multidisciplinary practice, and with that comes obviously inevitable collection of great projects and great stories behind them all. So we offer cross-discipline design thinking, so we don't work in these silos, we truly do work together, architecture, acoustics, right down to wayfinding and project managers. So today I'm going to talk largely from an architectural perspective, because being an architect, that's what I kind of focus and care about, but I'll bring in some of the other disciplines and inputs that we incorporate into our projects. Okay, so as part of this, we recently had an entire series on this subject, with podcast talks, presentations, and there's a few key headings from that I'd just like to share with you today. So first one is designing age-defying buildings. What can we do, and what experience do we have as BDP, and how can we share that with you guys? So it seems like an obvious one, but learning from the past. We have a rich history of projects that we work on, and we use that to design and develop better buildings and places for the future. But also it's taken from the view of when developing a building, developing proposals, really getting to understand the building itself, because there's usually a few mistakes that have been made along the way, and it's starting to unpick them, to understand it, and it allows us to make bigger changes. Making maintenance easy is a key one. If you can keep a building clean and tidy and look after it and replace bits, it will last longer. Some of the biggest problems we have in heritage schemes is late additions that prevent access to areas. Those areas become broken and unloved. Okay. There's technology. It moves faster than the building does. So yes, we can incorporate technology, but also allow for future expansion technology, appropriate material choice and selection, and getting that right at the very start of a project, because that's how you can really then dive down into the details of how that works and responds to the building that you're working with, and allows you to have a bit of fun around it as well. And I'll illustrate that in a few projects. Okay. Sorry, clicked ahead. And then designing for disassembly, but at all scales. So there's always a bit of an argument over aesthetic in our offices, as you probably imagine, being architects. And the drive for this seamless kind of clean aesthetic, and whether that is the right thing to do. So we're constantly debating, does this aesthetic meet the challenges of either disassembly or sustainable building practices? And for example, with lighting schemes, we consider integrated light fittings versus surface fixed. In areas those are appropriate. It allows for demountability in the future, greater adaptation of the buildings you design. If it's integrated, obviously, you've got to start smashing it out, which is not good. Okay, and basically, headline of that is make a building people are proud of, and they'll look after it. Okay, so adaptive reuse in a climate emergency is the next kind of headline to share. And obviously, many professions, including architecture, have declared a climate emergency, and it's really something we need to address today and in all our projects going forward. And basically, we don't see it as a restriction, we see it as a presenting opportunities, but we really need to be sensitive to the cultural drivers behind these projects, and I've given our most extreme example of that on the screen, which is the refurbishment of the Palace of Westminster, which is obviously a building ingrained in the hearts and minds of many people, not just in the UK, but across the world, but actually refurbishment of that presents a huge challenge of the cultural significance of every element of that building, but also it's next to a river. The sea levels will rise in years to come, so we've got to consider that and how we can keep the world-famous reflection of the building in the river there for another 100 years plus. Okay, and then as part of that, it's recognising a sense of place and understanding community values. So obviously, existing buildings are there because they've either been good in some way or liked in some way, that they've stuck around. So you've got to really understand that and understand the value that's placed on that. And by quantifying what those values are, it gives you the opportunity to identify change, or the potential for change to happen. Okay. And then last one, bringing old buildings back to life. So it's an important fact that existing building stocks are there. They're really useful, and they're also very well placed, both just from a location. They're usually well connected, transport-wise, services-wise. So there's a real benefit to using them. Don't really need to sell that idea, but the difficult challenge is the balance between the functional requirements of modern-day thermal performance, all kinds of environmental requirements and accessibility, and how we integrate that into a building successfully, and identifying those and responding to that so we retain the character of the building that's there currently. But that doesn't always necessarily mean that the valuable elements of the building are the beautiful ones. Sometimes they're fairly mundane details, and how can we celebrate them? So the next project I'll talk about will have a little bit of that in it. And then particularly, because most of the building is there already, you have very little kind of to engage with, and your focus becomes heavily kind of trained in on elements such as windows, because without windows, obviously a building is just a box. So they need to work harder, and it's these little elements actually play a bigger role, so the details become really crucial. But ultimately, when bringing old buildings back to life, consider, what does the future look like? How does this building sit within that future? And that will answer most of the questions for you. Okay. So with that, let's talk about a few different projects. So this is the Battawa Lofts project, which is in the town of Battawa in Canada. It's a couple hundred kilometers east of Toronto, and it was delivered by our Toronto office. So if anyone knows the history of the Bata Shoe Company, it was a Czech-born family who left and set up model villages with a heavy modernist aesthetic and drive behind them across the globe. There's one in East Tilbury in Essex, if you want to go and visit it. And this was, prior to its refurbishment, a shoe factory. And as you can see, some images of people working on it. And it's basically the model village, but not the Bourneville model village you get down the road. It had a very different kind of approach, aesthetically and construction-wise, probably given the fact that it was another 50 years after Bourneville. But it still had everything the workers would need there, and it was an idea of everyone lived on site, lived sustainably, and contributed to the upkeep of the town as well. Apparently you would get hauled in front of the office manager if your grass wasn't cut in your garden, so pros and cons, no doubt. So with the decline of shoe production, the factory inevitably closed. So Sonia Bata, the wife of the founder Thomas, conceived a new use for the building and wanted to really expand on the people living there and give them more opportunities and get more people to actually move and live here. So the factory became the centerpiece of a sustainable community. So it was reworked into residential units, upgrading the facade, provision of balconies, and then it was all heated with some geothermal heating. So inherently a sustainable building. And as we went through the design, the value of the building, as I mentioned earlier, what is the value of the building? It's not always the most beautiful element, and as you can see, tastes always split on this kind of design. I love it. I think it's great. But once that was all stripped away and it wasn't a factory anymore, it became the structure itself, became the heart of the building, and it sets out a rhythm across the facade, and it therefore gives opportunities how to play with that rhythm and add some interest, as well as get a very functional kind of generously day-lit residential units into this space, because the floor-to-ceiling heights here are way above what you would get in a new build, and no one would just build like that nowadays, so not for residential use, so perfect for the opportunity. So valuable was this structure, actually. You can see, I'm going to try this pointer. There you go. So the balconies that were on the windows, original design had the steels coming straight out of the column, because structurally that's a nice, easy place to fit a new steel. But Sonia Batter gave the architects a stern talking to and said, you can't do that because you're in the way of my beautiful structure, and that's the most important bit, not your balconies. So the design was eventually redeveloped to give a bit of an emphasis on that. So you can see the vertical lines of the columns are retained, and the balconies neatly slot into that. So it wasn't a huge change, but it's a subtle hint that retains some of that character and that value of the building. Okay, so details for anyone who's interested. So we, just on screen here, just how we developed the detail. It started out, again, it's still a steel balcony, still supported with a new bit of steel fixed back to an existing slab, but just that careful detailing of bringing the steels inboard of the existing structure, expressing the concrete on the exterior of the balcony, and then you can see the work we did around the interior to make sure obviously it performed thermally, allowed us to do a nice intervention in what was a fairly rigorous facade. Okay. And then the difficulty comes around the detailing of this. So, this is where I'm saying get the materials right early. You can dive straight into this stuff because there's not a lot there that's new. It's a couple of windows, there's an existing column, and then there's a bit of boxing out for the ventilation system. So all we've done there, though, is as part of that detailing, is a very careful little detail. Oh, wrong button, there we go. Is all focused within this zone, which is probably 150 mil, 200 mil deep. So it's heavy. It's insulated as best we can. Canada, this part of Canada doesn't have very strict U value requirements, so you can get away with slightly less than we'd be expected to in the UK. But just providing that curved flashing keeps the character of the curved pier outside, so it's just bringing a bit of that subtle detailing in. And then, as you can see, the balcony comes in and just sits next to that column, doesn't touch it, doesn't get in the way of it, and it's all these minor little details that really count when you're doing refurbishment. And we continue that idea across other facades, so as we hit columns again, we've got the curved interior with the insulation. But it also gives us the opportunity then, well, we've done all that, that's easy. We don't have to worry about the structure so much, not as architects anyway. So we can start to talk about the really small details that make it a bit unique. And one in particular was, let's have a look at the glazed balustrade cap and make it a bit unique to this factory. And it becomes a very tactile bit of the building. It speaks a bit of its heritage, its manufacturing, the curved columns of the building. And then it's something that you would almost miss on site unless you knew about it, but when you're standing there holding a handrail, you know, oh, this is a bit different. So I hope you'll agree that although it's relatively light touch, it is quite heavy in terms of what it's done, it becomes quite a beautiful building to look at. Next project is a similar kind of vein. It's a refurbishment of a building for the Cambridge Institute of Sustainability Leadership. So it's a course about sustainability, encouraging people to take leadership roles. So obviously, as a building, it needed to hit very high sustainability aims. So of all these different criteria the building was targeting, the highest or the most complex to achieve was probably the NFIT standard, which is passive house for existing buildings. But in doing so, the building has an average energy consumption about 80% less than a typical building stock on site. So for a refurbishment, it's a fantastic, step forward. But tied into that, there was a number of steps you had to get through to get there. So it was internal wall insulation, obviously, because it was a solid brick facade. Into that were triple glazed windows, which used to be lots of small lights. We went for big, clear opening glazing. That's a passive house kind of driver there coming through, because getting as much solar gain in the winter reduces your heating demand. Obviously, in the summer, they're sized appropriately so we don't overheat as well. Smart services and systems, so task-based lighting, zoned ventilation controls, and we also had, obviously, very keen air tightness detail, because passive house tries to get you down to a very low permeability of the building, because you want to heat the building up, you don't want to lose it. But as a result, actually, the insulation U values were just at minimum building regs. But even with minimum building regs, we managed to achieve an 80% reduction in energy. So it shows how all these systems can play together to provide a very energy efficient building. So at stage 3, we had this kind of design of aspirational insulation here, just dry line it, quite simple, using timber instead of steel studs because of the embodied carbon and so on. But getting to learn about the building and know more about the building during the demolition process, it's not the same building you thought it was. It changes during that time, and actually you uncover new things. So as a result, the details had to change. And it was found that brick was obviously a lot more porous than had been anticipated. It was a bit wetter, so a combination of cork and clay plaster lining was used, which provided a thermal uplift, but also allowed the walls to breathe to a greater extent than the previous system proposed. And then on top of that, additional insulation, and then standard plasterboard lining with a service zone. And as a result, you end up with an office that looks pretty nice, I think. It doesn't look fantastically different. It doesn't scream eco-green credentials, but actually in the background is a building that's performing with 1/5 of the energy it had previously. And there's always opportunities. You're going to put some PV, why not stand it up and make a canopy and actually introduce a new roof top use that wasn't there before. So always take these opportunities. And then just to finish quite quickly, is obviously just down the road, Taifu Wharf, you may know it. It's the old Taifu tea factory. And it's a project we're just starting on, so hopefully we'll get to talk again about it in a year's so time when we've gone through all that pain. And it's a refurbishment into the BBC's new home in the Midlands. So they're going to move from the mailbox into this building when it's complete. And again, we're looking at what's the value of this building, what are the bits we want to retain, and how are we going to make it perform. And unlike the previous projects, the BBC have very high performance requirements they want to hit, so it's going to be super insulated. So it's going to present some challenges to that, and we're gradually starting to unpick the building, learn all about it. So we've got the Art Deco Blendon Tower here, which is quite iconic. It's been used in films recently, so if you haven't seen it for yourself, you'll see it in movies. But then it's also got all this character inside, and how do we, obviously that's not a place you would work, but it's a nice place to look at. How do we retain that character and move it through? So which bits of these buildings are most valuable? Again, it largely falls down to structure. There's high embodied carbon in structure, so the more of that we can keep, the better it is for us. And then, as a result, you'll end up with an unusual and interesting building. So we've got lots of gritty images. And we've just started to peel away some of the graffiti, which is of a lower standard. There's some good graffiti and some bad graffiti. And then we've got our building physicists team to actually start to analyse the build-up so we can know exactly what's going to happen with the brickwork and develop some proposals that we know will work. So when all is done, it'll look something like that, and everyone will be very happy. So that's one to keep an eye on with us. It's still in its very early days for us, but yeah, thank you for your time.
Thank you very much, Mike. Great work.
Thank you.
And looking forward to see that BBC building when it's finished.
Great, thank you.
Thank you. Final presentation for today is from Rob Nield. He's an associate director at Webb, Yates Engineers. He's talking about form following fuel rather than function, which seems quite apt in today's environment. So.
Thank you. So, fair play to all of you that are still here. I've seen some lost souls walking through Centenary Square with their head full of facade information. So, well done. And just to warn you, there are no code references, no U values in this talk. It's pretty pictures, so you can rest easy as you roll into the last thing. Where's the clicker? So yeah, I'm Rob Nield. I'm a chartered structural engineer, and I run the Webb Yates office here in Birmingham, and we're up in the Jewellery Quarter. And I'm going to talk to you about how access to cheap energy has helped shape the buildings that we build over history, question if we actually build in the right way, and also cover some projects to show how we're challenging the status quo, and hopefully go in some way to trying to answer your wife's question from this morning, Stephen, about why we don't build buildings like Westminster Abbey anymore. So who are Webb Yates? We're a 65-strong multi-disc engineering consultancy. We do civil, structural, MEP design across offices in Birmingham and London, and we've got a very strong sustainability ethos. We work across most sectors, so we'll tackle anything from a bespoke back extension to a £200 million infrastructure project. This is the Kilo box at Heathrow Airport, which is a 200-metre long, 11-metre deep baggage handling facility that's right under the taxiway, and this finished last year. So, yeah, these days, typically facades are kept separate from the building structure. As the design has become more specialist, so is the complexity, as I can tell from some of the talks earlier in the day. So yeah, I want to show you how with some innovative thinking, it's possible to bring back some functional, aesthetically pleasing, load-bearing facades into our buildings that are going to save time, cost, and money, and carbon, sorry. But I want to start by talking about energy. Energy underpins everything we build. It helps us produce our building materials. It helps us construct our buildings. It helps us run our buildings. Let's go back thousands and thousands of years before the fossil fuel era. All we had was simple human muscle as our energy. One human in an 8-hour shift can probably exert about 1 kilowatt hour. It's actually a little bit less, but to make the numbers easier, we'll go with 1. So back in the day, we just used to build really, really small buildings. Okay, and we would use locally sourced material. We'd use mud, we'd use straw, we'd use wood. It was the Egyptians that were the first agrarian society to really harness this energy resource, and it was really the first energy revolution. They managed to get a labour force of tens of thousands to help build the pyramids. Although with humans, they're weak, you need to feed them and keep them motivated. They also had wood. So just to say that the reason they managed that was energy surplus. Okay, before that, people used to farm to feed themselves. And that's all they could do, that's all they could spend their time doing. The fertile soils of the Nile, the favourable climate, allowed them to yield enough crops to both feed their and sustain their populations, but also start to do other things. They could sell the surplus, and they could start making tools, and they could start extracting building materials, and start specialising in some other things. So yeah, they also had wood. Wood was great. It was relatively expensive, but you get 3,000 times the energy of one human. Okay, but wood, timber, forest compete with land that you need to grow crops from. But it's also quite sustainable. You know, it only emits into the atmosphere the carbon when you burn it that it took out of the atmosphere in the first place. And you can regrow a forest in a couple of decades, you know. So a good renewable resource. It wasn't until the 1850s, that was the next energy revolution, the advent of mass coal extraction. Coal was brilliant. Gives you 3 times again the energy output, so the equivalent of 9,000 people days of labour. That was shortly followed by oil in the early 1900s, mass extraction in North America. Oil is even better because it's in liquid form, so it's easier to extract, easier to transport, and it's very useful for internal combustion engines. With global oil production around 6 billion tonnes a year, That's the equivalent energy output of an additional 200 billion people working each year. And really, it's because of that, I guess, free and cheap energy that we've had, we've been able to upscale production of buildings globally in the way that we have. Okay? So to put that in cost terms, a day of labour will cost you about 200 quid these days. If you can find anything cheaper, let me know. A ton of wood, maybe 300 quid, so 10 pence a kilowatt hour. Coal, super, super cheap. We use it for our steel blast furnaces, we use it for our brick and cement kilns, 1 pence a kilowatt hour. Oil a bit more, but still under 5p. Now look, these are rough back of the fag packet numbers, but it gives a bit of context to how we've been able to upscale production in the way that we have. To the point that we're now building the equivalent of one New York City every single month globally. And along with that, all the concrete and steel and glass that goes into those buildings. And yeah, there's no denying that this energy revolution has improved the lives of millions and millions of people globally. But ironically, it's the same energy revolution which is very soon going to make life a lot worse for millions and millions of people across the globe. With climate change, rising sea levels, rising temperatures, droughts and famine. The most recent IPCC report, I think, was called A Survival Guide for Humanity. So it's about time we started doing something about it collectively as an industry. So the problem with brick. Any brick suppliers left in the audience? Good. I'll walk on to the pub. This is a Neolithic tell. This goes back about 7,000 years, and this is probably one of the first organised settlements that we have on the planet. It's basically a man-made hill made up of millennia of construction, build it, demolish it, build it, demolish it. And within these tells, there was evidence of brick construction, standardised brick construction. And these were mud bricks. So locally sourced, you dig out some mud from the riverbank, you can mix it with some straw, and you can dry it in the hot sun. So it's all very locally produced, very, very low carbon. Very weak, though. So instead of digging out a whole load of clay and making a very, very thick mud brick wall, they discovered that actually if you cut down a forest and burn it and fire the clay, you can create fired clay bricks. Wonderful. They're stronger, they're more durable, and you can build a thinner wall. You need less material, but at an energy cost. This is a typical Tudor building in London. Timber frame, wattle and daub walls, and often some load-bearing stone masonry as well. All well and good until 1666, when about a third of the buildings in London were burnt down in the Great Fire. And at this point, Charles II mandated that all new construction in London must be fireproof brick construction. Okay, so very good reason, big kind of seismic event in the industry and a change of regulation. This also kind of coincided nicely with the advent of cheap coal from Newcastle, and it was energetically expedient to actually ship cheap coal down from Newcastle, fire the locally sourced clay in the kilns to produce all the bricks to feed the growing demand to house the population of London. It was much cheaper than using stone, so that's why we started using bricks. So here's a typical Georgian terrace in London. I took this photo walking through London a few weeks ago. And here you see the masonry is providing quite a number of functions here. It's the load-bearing function, it's the architectural finish, it's the fireproofing, it's the weatherproofing. So one building element doing a lot of jobs. But as time's gone on, and we've had to increase U values, that's kind of changed and become more, we've added more complexity into the system. So we've had to split that single leaf apart into two leaves. That's weakened it. So then we've had to add wall ties, masonry wind posts, reinforcement. We now favour steel lintels over arch lintels. There's all manner of membranes and other fixings and connections required. And we've hugely increased complexity. And this is how we build today, apparently. This is the building across the square from the beautiful Georgian crescent. And this is a frame building, steel or concrete, and we're hanging bricks from it just as a decorative finish. Heavy, heavy bricks going back into the structural frame, adding more load to the frame. So you wonder why we're building coal-era buildings in the same way to look the same when they don't serve anywhere near like the same function. Is it we're stuck in our ways? Is it local planning requirements? Perhaps we should move on. So at Webb Yates, yes, we do design brick buildings. This is Barrett's Grove. This is a 5-storey residential building in Dalston in East London. It's actually a masonry building, but with a load-bearing timber structure within it. It's got CLT floor plates, it's got CLT walls. Now, what we've done with the facade, it had to be brick because of planning requirements. So what we've done, rather than support the brick halfway up on shelf angles and add that load back into the frame, we've just gone 5 stories straight up, stack loading the brick off the solid base. That negates the movement joints, all the extra steel angles, and all the extra details that you would need in that. Now, the code will tell you, I wasn't going to mention code, but I will, guidance is to go 4 stories or every 3 stories put a movement joint in. So we had a little look, and we just calculated how much the timber would shrink over time and how much the masonry would expand over time due to moisture absorption. And we just detailed the movement joints accordingly around the window detailing. It wasn't difficult. The other thing about this building, because it's just a rain screen to the protected timber facade behind, it can be hit and miss. So we can miss some bricks out, we can make it perforated, and again, using about 65–70% of the bricks you would normally have if you had a solid wall. So further savings. And this was pre-Grenfell, so the internal of the building was totally exposed, so no additional finishes, again, saving more time and cost. Here's masonry another way. This is York House on Pensonville Road, and this is part refurbishment, part new build. And here we've taken a cue from Eladio Dieste, the kind of famous Uruguayan architect engineer, where we've looked to use sectional depth. We've added a serrated pattern to a single leaf of masonry. That adds strength and stiffness. It's like folding a sheet of paper. And that allows us to fully self-support the wall off the base, but also allows it to span between restraints at floor levels without any extra structure. We haven't added loads of steel wind posts into this, it's just the brick. But how can we use a holistic approach to our building design? At Webb Yates, a lot of what we do is fundamentally based on, I guess, a deep understanding of the materials that we use, the properties, the strength and the stiffness, and importantly, the embodied carbon. So this is a very simple graphic which compares the primary building materials, but rather than comparing a kilogram with a kilogram, we're just looking at how wide a beam do we need to support a 1-ton car over a 2-metre span. Okay, let's compare concrete with softwood, so the first column with the 4th column. Concrete's a lot stronger, so you need less of a beam to do the same work, to support the same load than the equivalent in timber. However, stiffness is very, very similar. Once you've taken account of concrete creep and shrinkage and cracking, they've got very similar stiffnesses, and most structures are stiffness governed. So you end up with a very similar section size in timber as you do concrete. But the thing is here, if you look at embodied carbon per metre run of beam, the timber is far, far lower than the concrete. But also, if you account for the sequestration, so that's the CO2 that the timber absorbs during its growing cycle, you can actually offset a lot of the positive embodied carbon in your buildings. So here's what we've done at Upper Street. This is in Angel, and this has a load-bearing concrete facade. I've just told you that concrete's not very good, but here it was used for a number of reasons. It's got good load-bearing capacity, but it also gave us the flexibility to create this finish. And the story behind this building is the site was a bomb site, so it got bombed in the Second World War, and it lay empty for the subsequent 70-odd years. And the premise behind the building was to put back an exact replica of the building that was once there. But there were very few records, very few photographs. But incidentally, the opposite corner of the terrace had exactly the same building that was on this corner. So what we did with the architect, we LiDAR scanned the existing building that remained on the other corner, turned that into a 3D file. We were then able to use that to CNC cut polystyrene formwork that went in the face of the concrete formwork. So the picture on the right is the polystyrene formwork, which has the detail and relief of the facade cut into it. Got the reinforcement, there's an insulated layer, and then there's an internal concrete wall. So it's essentially an in-situ concrete twin wall. The internal frame is a wholly timber frame. This is CLT and glulam, and we're also supporting the glulam the CLT on the facade. And the end product is a fantastic amount of detail for pressing a button on a LiDAR scanner, programming a CNC machine to cut the formwork. So all that detail was done with actually very little in terms of manpower and labour. And the process was so successful that we've even embossed the wallpaper on the inside. So as a finish, there are no other internal linings, no other plastering, no painting. That's the bare finish. I told you timber's quite good. Here's an example of a project we're just about to start on site with. This is the Heritage Quad at York Minster. This is a really cool project that we're doing with Tonkin Loo Architects and will be one of the most significant buildings built in York for a generation. The concept behind the building, it has this kind of undulating radial roof made of exposed timber members. The architect was extremely keen to be able to read the facade rhythm with the rhythm of the roof members. So we've got glulam studs to coincide with the roof joist spacing. Now, the function of this building, it's got some office, it's got some accommodation, but it's generally a stone masonry workshop. Lots of dust, lots of dirt. So actually, the inside of the building will be wet more often than the outside of the building due to having to wash everything down periodically. So what we've done here, it's a bit of a nod to kind of Japanese temple design, whereby we're using timber externally in a facade, but it's being well detailed so that it doesn't decay or deteriorate or have too much moisture on it. We raise it off the ground on a masonry plinth. We're detailing connections to have ventilation around them so there's no ponding of water. And we put a nice hat on the building so that we're taking away the driving rain that might hit the structure. And if all that fails, then it's quite easy just to chop out a bit of timber, resplice a new piece on over time. And that would actually add to the character of the building over time. You know, if you see any of these old timber buildings, you'll often see new bits of timber kind of spliced on to keep the integrity. But probably worth sharing with you at this point, a new wonder material that we've discovered it, but we're using more and more of, okay? It's got 2.5 times the strength of concrete. It's abundantly available in the Earth's crust. It's inherently beautiful and variable. And it's also extremely low in embodied carbon. So are we entering a new stone age? You know, we like to imagine the trajectory that construction would have taken had we not had the fossil fuel era and the widespread use of concrete and steel. If we took the last 100 years out of the equation, where might we have got to with our construction? So we started our journey in stone about 15 years ago, designing traditional, what they call cantilever stone stairs in mansions in Mayfair. You know, we've been pushed sort of year on year by the architects, by the stonemasons, the contractors, to design ever more weird and wonderful stone constructions without supporting walls. So we've developed reinforced stone constructions, and this is a post-tensioned stone stair. So this is the first helical post-tension stone stair that we designed. We photograph it before the balustrades go on because it just doesn't look as good. But we're actually starting to design whole building elements out of stone. This is my new favourite piece of furniture. This is the stone bench that we designed for our office in the Jewellery Quarter. So this is a 4-metre span. It's 1 inch thick at the edge, and it's 3 inches thick in the middle, and that's designed for full commercial loading. And that's trusting the product to get your whole design team kind of up on the bench. And here's our first stone building. Again, we collaborated with Amin Taha on this building, and it was originally conceived as a fake masonry building, like a lot of the other buildings in the close, frames with some masonry stuck on. If any of you have seen this building, there was obviously a huge planning issue with it. It had a demolition order on it. That's all now gone away, and they don't have to demolish it, which is good news. But essentially the conversations were, why are we putting fake masonry on a building? Why don't we get the facade to do what a facade historically would have done? It's the finish, it's the load bearing, you know, getting one material to do more than one job. The trick here was, I think, Dav was talking about 1 centenary way this morning, which is a steel exoskeleton. So getting the thermal bridge detail right was very, very important, but that's just a very simple plate cast into the concrete slab internally, and a piece of plastic, a Farrat pack, does the job quite nicely. The construction sequence was really interesting. In order to stop competition between a concrete contractor and a stonemason, it was actually decided to build the whole concrete frame with stability core at the back corner, so it didn't fall over, and backprop the whole building. Everyone thought we were a little bit mad to go down this road, but actually it turned out to be quicker. We build the whole frame and back prop it, then the stonemason comes in, has a totally clear run to put the facade up, tie up all the connections, deprop, and there we go. The stone building is there. The exoskeleton is also very good for solar shading. It helps reduce the solar heat gain, so then reducing cooling demand in the building. And if you look closely, you can see the 3 stone finishes that we have on the megalith columns. You've got the circular saw marks on the sawn bits of stone. You've got the rough finish is the tooled finish. And then you've also got on the left-hand side, that's the original drilling and splitting finish. These guys do this by hand. They drill down, stitch drill, they put a wedge in, they hammer it, and they split the stone off. So it's a very raw, it's a very honest building. Love it or hate it, it's fortunately still there. And that's not the only one. This is the next iteration. So this is a 10-storey version of the same that we're currently building in Finchley Road. I think we're just still waiting for the stone. The concrete frame is up and back propped. But this uses basalt. It's a much stronger stone. So the limestone on Clerkenwell was maybe 100 newtons a millimetre squared. Basalt, you'll maybe get 250, which is 2.5 times high-performing concrete. It's been fire tested for 3 hours with the BRE under load, both external fires and internal fires. And in this iteration, it's going to be the vertical load carrying capacity, but it's also the stability system for the building. So it's going to act like a moment frame. The joints, again, have all undergone very intensive analysis and testing to prove their strength and stiffness. But if this is all a little bit much for you on a Thursday afternoon, I guess we've got one simple alternative. If we're going back to where we started in this talk, and we're still wedded to using bricks, I've been carrying around this in my bag all day. Back is killing me. But this is a stone brick. Simple, right? So it's cut to the exact dimensions as a normal UK brick. It's stronger. It's got the strength of an engineering brick. It's more durable. It's a third of the embodied carbon. So this brick comes out of a French quarry in northern France, Massengy. And the reason they started making this was because the amount of wastage in quarries, because of architects and clients discarding stone for visual reasons. It might have the wrong tone, the wrong veining, the wrong shade. A lot of it gets wasted. So if we actually use, this is a waste product, if we actually use the waste product and build it into something simple that is usable and transferable, then the embodied carbon of this will just go down and down and down. And the best thing about it, and I'm not a salesman for this, I just think it's great, is £2 a brick delivered to London or Birmingham. So it's comparable with a lot of architectural bricks that are used. So yeah, I'll leave you with that thought. Thank you very much.
That's great. I might get you to stand there because I have to use that microphone. Thank you. Can you hear me? Yes, you can hear me. I want to say, first of all, congratulations, Rob. That was really inspiring, and I don't say that lightly. Really inspiring.
Thank you.
Back to first principles engineering. I love it.
Yeah.
Absolutely love it. I think the words I wrote down, innovation, original thinking, and that's what we need, absolutely what we need in this day and age. I love your argumentation that we create savings in the building structure, but then we end up adding heavy lumps of concrete externally, which are just there for aesthetic, or bricks, which are just there for aesthetic. I think if you're going to build a lightweight structure, clad it with a lightweight facade, because that makes a lot of sense. Mm-hmm. I think if we're going to put materials like concrete and brick on our buildings, we ought to make it do more than just be there as an aesthetic finish. So I commend you for all of that. It's absolutely fantastic. I also was caught by your comment that the regulation said don't build a brick wall more than 4 stories high without a movement joint, and let's look at it and we'll go 5 stories high. And that's kind of against what we've heard earlier today. A lot of the time the regulations are tying us into knots. It's all conflicting requirements, and no one's going back saying, well, actually, the regulation is wrong. I can engineer this, and I can make it work, and I can take responsibility for it, which is a key thing. Yeah. And so that was another piece of original thinking that I found really inspiring as well. So well done on that. Does anyone have any questions for Rob? Because I'm sure some of you have been inspired by what Rob presented. So if anyone has a question, please raise your hand. It looks like
I'm off the hook.
You're off the hook.
Thank you very much.
Just a clarification that you were looking to dead load all of your facades right down to ground. Is that correct?
Yeah, I guess that's the premise of those buildings, and we've done a study on the back of Clerkenwell Close to actually say we think we can get 30 stories before the columns get too big that it becomes quite hard to kind of permeate the ground floor. We're not saying that's the solution for all the buildings. Obviously, there's people that have been presenting on huge high-rise buildings, and we're probably not talking about those types of buildings. But I think we can all do a lot more with the medium-rise buildings that we design, with a bit of holistic thinking. And I think just pushing the boundaries, the great thing about being an engineer is a thing called engineering judgment, okay? So we do a lot of testing, we do a lot of development. That stair, the curved stair, we broke 3 of those before we tried it for real. So everything is underpinned by extensive analysis and research and development, but that's the fun part of being an engineer.
Absolutely well said. Thank you again, Rob. Thank you so much. I'm just going to invite Alina White, please, who is our moderator for the final session of today. Alina is an associate at Fielding Clegg Bradley Studios, and she will introduce the panel that will have the final panel discussion.
Okay, yep. Can I do that? So thank you very much for staying to the end of the afternoon, everyone. And we have had a couple of change-arounds on the day today, so thank you for the people who stood in for other colleagues who couldn't make it. But welcome to the stage. Alex Housden is the development manager for MEPC. Come on. And then Paul Chatwin is joining us from Cundles. He's just being mic'd up. Lefteris Simiopoulos, I hope I said that correct, joining us as well. Nick Buxton from SRM Contractor, come and join us. And Javier Garcia from Inathas, who the subcontractor involved in 3 Chamberlain Square. For our panel discussion today, we've got a couple of things we're going to go through with you, and particularly it's all concerning 3 Chamberlain Square, which is not very far away from here in the centre of Birmingham. And Alex is going to talk us through a couple of aspects and the aspirations and how the brief formed for the building.
Thanks, Alina. Hi, everybody. Great to be here. 3 Chamberlain Square started almost exactly 3 years ago today. In the depths of the kind of COVID pandemic, I was with Argent at the time. Argent, who are now MEPC in Birmingham, are the developer and asset managers for the Paradise development, along with a number of other city centre regeneration schemes up and down the country. 3 Chamberlain Square, and Dav will have talked earlier about 1 Centennial Way, our neighbour, another of the Paradise buildings. 3 Chamberlain Square is situated on the southern flank of the building in a really iconic civic location right next to the listed Birmingham Town Hall. So we take our obligations incredibly seriously in terms of being the custodians for that site, and we always had in mind to deliver a building of real kind of exceptional architectural quality. But also going back to that COVID era, we were trying to take our specification with the buildings forward to deliver a building that really delivered new kind of levels of sustainability, in particular well-being, and responded to what was at that time a really emerging new trend in occupier expectations. And that trend is still not settled yet, so we still have heaps of data coming in about office occupancy levels and what occupiers and tenants are expecting in the building. It's a building which is taking Paradise to a new level. So on the screen here you can see some of the sustainability-driven targets, which will be firsts for the city. So we'll be the first BREEAM Outstanding building in Birmingham. We are going to achieve wide score Platinum, an active score Platinum, which is all around active travel. And also, we are on target to achieve a really good upfront embodied carbon rating of under 600 kilos of CO2 per square metre, which for a concrete frame building is setting a new standard for us and really in line with that kind of LETI-C rating.
So given the aspirational brief that we had from Alex and the MEPC team, how did we respond to that? Well, we've taken inspiration from nearby aspects in Birmingham, but I'll just go through a few points of how we came to address the brief, really, and particularly the low carbon aspects of it, the flexibility, the well-being, and the adaptability. A lot of that does happen internally, and one of the big aspects of reducing the overall embodied carbon came in the frame, and reducing the grid to reduce the thickness of the frame. But going back towards the outside of the building, as we're all here for facade-related aspects, although building must be considered in a whole, we took some key inspiration from the town hall next door, taking that kind of base, middle, and top aspect, and then how we interpreted that in a modern way. We also looked around at other inspiration here in Birmingham, and we took particular inspiration in the sort of curved OG arch form and terracotta as a material that is used on the other aspects of the Chamberlain Square and Paradise development, but taking it in its in a terracotta colour and unglazed form rather than a glazed version that we've already used on the overall development. We kind of have the advantage that form factor-wise, we almost have a cube site. So we take that cube, apply our base, middle, and top. We're pushed in at the ground floor to give back public space and give the building a better relationship to Chamberlain Square and the surrounding public area around it. We then chamfered off on the top. So the sort of, rather than being a classical sloped roof, we have slightly angled facades, and they address the different aspects of the building with a steeper angle to the town hall. We then took the town halls, some of the verticality aspect of the clear columns in the middle, and we have applied our version of verticality, which runs up the building and then across onto the inclined planes as well. And finally, we took that OG motif and put it into the arches and the way they curve across the overhang on the ground floor and up on the top as well. So that's the kind of our base, middle, and top. And this was our starting principle with the OGs on the base, the terracotta flowing up the building and up onto the roof, and then a repeated form of the OG up on the top. We'll be talking about how we've worked with the rest of the team in order to develop how that OG form came to be. Even samples made, which was absolutely amazing to see. It'll have a really dramatic presence here in Birmingham when it's finally built. At the moment, it's still in the ground, so it's early, but will be coming up. And how that set back and the relationship of the darker metal OG forms in relation to the town hall, although it's a different scale, it still has the kind of presence of base, middle, and top through it. And that's the terracotta we've used in the piers that project forward to create more of the hierarchy of the vertical and then the plane, the surfaces coming back, the infills of aluminium, the flat aluminium, and the glazing. I suppose just to say, in the facade industry, things we need to consider, and construction as a whole, reusing buildings, that kind of follows on from what Rob was saying, what Michael was saying before, and then which materials you use where and when, and using materials wisely on their properties. So that's where we've come to.
Alina, just going back to that kind of start point a few years ago, I mean, I'm a developer, I'm not a facade expert, and that's probably the same for the team, the small team that I work in. We felt that getting that the ethos of the project right from day one was really critical. So choosing that team, you'll remember the design competition we ran, which you obviously were successful in. And when we I think, had a real aspiration for this building to be stretching, but we accepted that we were going to have to learn lessons along the journey and perhaps compromise in certain areas as we took the design through those various design stages, because we didn't know everything and we still don't know everything. But it started with a team with FCB, world-renowned, sustainability-driven architecture practice. And then we brought Cundall in as well, who are sustainability experts, and we've really built that team around this central ethos of low carbon, both embodied and operational. And I think it's fair to say, when you look back on those targets that we're achieving now, that whilst we've had some serious headwinds around cost challenges and so on, which everybody's aware of for the last year in particular, we've still maintained, and we're pleased to say we've still maintained those really stretching targets as we move into the construction phase now. And McAlpines, who will be building the building for us, are locked in to those targets, aren't they, Nick?
So, as the design developed, obviously we came up with an aesthetic, but that did become modified with input from all of the team. As Alex said, actually it's been quite a significant team effort. And although we've had different people come and join us today, they're all part of the companies that have made this happen. And Paul, your team at Cundall have been involved in, well, setting some of the targets, but also digital modelling of the building. Do you want to say a few words?
Yes, I mean, it's really refreshing when you have a client right from the outset, 3 years ago, saying, right, we want an exemplar building. And from a carbon, both operational and embodied perspective, is what is the right targets to be set. So there have been lots of modelling at various stages, from early stages on whole life carbon appraisals, as well as proper operational energy modelling. So we're not just looking at compliance modelling for EPCs and Part Ls, it's really pushing beyond that to make sure we tick the certain boxes that are required around the BREEAM outstanding position as well. And there are challenges, and we are looking ahead at the future regulations and what they may impose. So we can already see here on the charts in front of you the kind of the governmental aspirations for reducing carbon and how some of those budgets are off track currently. So there is a big, strong emphasis on the buildings and making those buildings better. And we even had EPC rules changed last year and throughout that. But what we've continued to do is take the modelling from the early stages and then carry on working with the contractor to try and make sure, and the supply chain, making sure that those measures can be met, maintained, and what that impact is on the commercial side of things as well. I mean, we know that this is a facade, and the facade kind of impact on operational energy has been discussed. But we know that if we get the mix of ingredients on glass or solid and insulation and air tightness, that facade impact does have a significant contribution to the operational energy going forwards. And this is in the context of an office building. So one of the biggest things is if an office is well occupied, you've got a lot of heat internally, how much impact does the glazing have on that? There are guidance out there from the LETI, the London Energy Transformation Initiative, which gives those kind of ingredients as to what targets you should be looking at, like 40% glass as viewed from internally as a starting measure. But then you've got health and well-being. You may want more glass from a health and well-being perspective. So sometimes you get these conflicts between different kind of criteria, and that sets challenges.
That was a key point, wasn't it, Paul? Actually, I remember when we were going through that 40% glass conversation. And I remember Alina and the
what
team
does
all together.
40%, when viewed from inside, glazing actually look like? How would that feel to be in? And is that 40% target actually correct? I think as the design has developed, obviously a previously classical office building would have had a lot more glazing than 40%, maybe even floor to ceiling in quite considerably more. But here we tried the 40%, and we just felt that from a well-being and internal perspective of how it would feel to be in it, that felt a little too mean at that point. We probably ended up with something that just over 50 towards 55% of glazing. But I think it's something that's an interesting discussion to have as to that balance between internal well-being and not getting as much energy gain in through the glass as you might have, which...
Yeah, you've got to look at everything in the round, haven't you? Because we've got neighbouring buildings, they will impact on the daylight, so you may need larger portions of glass for health and well-being. If you've got a deeper plan building, you're only going to get the daylight benefits so far into the building. So it's always a challenging compromise, making sure, and with the modelling being carried out, you can assess the impact that embodied carbon as well as operational energy over a whole life cycle has.
One of the other key points that was discussed on this building was whether to go with triple glazed or double glazed. And Left Terrace,
yeah.
Can I ask you on this one?
Yeah, of course. So one of the initial discussions we had when the project started, we started with a LETI target, 0.15 U value for walls, 1.2 for windows. What does this mean for a unitized facade? Because that's a unitized facade. Or we explored a few options, and we said in order to achieve this average area weighted U values, we need triple glazing. But what does this mean from a whole life carbon perspective? And we calculate the embodied carbon, we calculate the operational carbon based on DGU and TGU, and then Kandal did a whole life carbon analysis. What would that mean with the different decarbonization scenarios that the government has? So in this diagram, what we can say is the comparison of the additional DGU emissions that we'll have compared to the TGU in terms of how much operational carbon more we're going to spend with the DGU. And we can see if everything goes according to plan and the decarbonization of the grid proceeds as per the government's Green Book, the DGU will be beneficial from a whole life carbon perspective because the operational carbon will be much less because the grid will have decarbonized. So it doesn't make sense to spend a lot of carbon early, a lot of carbon now, in order to save something, because we won't save anything in the end.
And that might be a different story with a house development, where you probably want the triple glazing will have a better benefit for a domestic situation compared to a commercial because of the operational energy associated.
And this graph was actually produced kind of almost about 2 years ago, and how the national grid is moving has changed it, but actually I think, am I right, Paul, it pushes it more towards the double glazing being the right answer for this project.
I think, yeah, generally as the grid decarbonises and we get more accurate figures, then yeah, it will be more beneficial.
Nick, do you want to say more?
Yeah, I suppose we're kind of going from the operational side as well, the embodied carbon side. So kind of when we got involved with McAlpines and into the projects, we looked at in terms of the facade build-up. And like I said, at the top there is a big learning curve for the SRM project team. It's the first development that we've been involved with where carbon was really up at the top in terms of operational and as well as embodied. So lots of new terminology for ourselves, LETI, REBA design guide. In terms of as well, the Hermes Design Innovation Standards, which is a client developer driven standard. So trying to understand what was involved in that. And then also looking in terms of the facade factors itself, in terms of how it was designed, materials that had been specified on there, and looking in terms of the buildability. So up at the inclines was originally designed as a stick system. So with our early involvement, we got involved in the stage 3 part of the development. So we were there to help and work with the client's team during that stage to help make it more buildable construction. So obviously with a stick system up at the top, we would have had a lot of external access, increased programs, prelims. So with our input from our supply chain, so we went out to tender during this early contractor involvement stage in stage 3. And
that's when you brought Inasis along.
Yes, and that's when Inasis came on board with us ready for the start of the PCSA. So once we got to the end of the early contractor involvement and the end of stage 3, ready to start stage 4, we concluded our tender period with our supply chain, and it kind of changed our perspective of how we tendered the facade works as well. Sustainability was really high up there kind of heavily weighted. So we pushed in terms of embodied carbon calculations, looking at deconstruction or disassembly, asking for different variants of materials, glass supplies, double glaze against triple glaze, as well as cost, as well as embodied carbon factors as well to help weigh up.
It's a really interesting point, actually. On this project, it's not just program time and cost, but also carbon impact that is to be assessed on anything that changes, and things will develop through the project, but carbon has always been there as a third aspect that needs to be reviewed on what the impact might be. So you also brought up in your slide about the impact of the double triple glazing.
Yes, so obviously the decision was made to go with double glazing, and we've saved just over 34,000 kilograms of CO2 on that change from a embodied carbon point of view. So obviously with the fact of the operational, that it hasn't kind of from day one you think changing from double to triple, from triple to double glaze, you're going to affect the carbon performance or the performance of the building, but actually shown that from an operational point of view it's not affected it, and also we're managing to save embodied carbon obviously up front.
Okay, sorry, didn't flick through those ones quite fast enough for you.
Okay, to go back.
Go back.
Go back to another one.
This one.
Another one. Yeah, so obviously in terms of other materials as well, so we had a real high U value designed, obviously as part of the operational side. We've actually reviewed in terms of reducing material. So we had 100 mil of insulation and an aluminium internal liner sheet on the back, and we interrogated this in terms of, well, what is the embodied carbon saving of having all this additional material against the operational side. So it was done, Paul's team did some calculations, and in terms of it didn't affect the operational side, we were still within, it did affect the operational carbon performance of the building, but not that greatly, and we still remained within the targets, and it meant that we could save over 136,000 kilograms of CO2 from a body factor, but yet we're still able to hit those targets for the operational side.
That's quite an important factor in terms of the team and the collaboration. The fact that the initial set kind of U value that we wanted through the wall was readdressed again in time to use materials efficiently, and the less you use of high carbon materials such as aluminium, the better, but the detriment that it balances out against and the overall, when you take the building as a whole, when you look at the carbon across its entire lifetime. So we've been able to get rid of that lining and insulation whilst looking at the balance of how that will be throughout the whole building. I think if we haven't had a collaborative approach, we wouldn't have come to the same conclusion.
No, definitely, and all this has happened kind of early doors, so within kind of stage 3, stage 4 period. So we've kind of got to that point where we've done a lot of this work kind of upfront and early because of that early engagement and that early collaboration that we've had. Obviously bringing on board then our supply chain as well, then to properly interrogate this in terms of material quantities, getting a kind of definitive amounts of quantities.
Your final point kind of on this slide relates to terracotta. Obviously, for us, aesthetically, the terracotta is quite important in terms of the setting and the position and the aesthetics of the building. But also, the understanding the balance of where we use terracotta as wisely as possible in the vertical fins to create the best expression of the building, yet not having it at 100% of every part of the external solid facade is terracotta. We've used it in layers.
Yes. It's
a material that has an extremely long lifetime, and we'll have bespoke extrusions, just a couple. We try to minimize them for the project, but to make it unique. But then it can last a very long time. So its environmental impact takes energy to make, but lasts a long time.
Yeah. Yeah, and in terms of obviously looking at the spandrel zones where we have changed the terracotta to aluminium profiles, that was kind of more of a, okay, we've said that we can have a saving, but obviously that's using a very low carbon content aluminium with high recycled content. But in terms of the position of it, with the external strategy of the building being rope access for cleaning strategy, that terracotta in that spandrel zone was very much exposed to external loading. So we felt that, and obviously we worked as a team to agree that changing that to aluminium was kind of more as a robust than terracotta, so in terms of risk of damage and replacement. And also in terms of bracketry and support, and with aluminium being a lot lighter weight in those zones, the bracketry was reduced as well in terms of reducing the amount of metal. But yeah, kind of with that early engagement as well now, so up here is the overall impact of the stage 4 for the upfront and whole life embodied carbon. So as we can see that the facade after the stage 4 design is equated for 25% of the upfront embodied carbon. Obviously, when you look at the Letty design guide, it says that the facade for commercial buildings at 16%. So obviously, Free Chamberlain Square has got a higher carbon factor kind of up front, but I think that is due to the fact that we have targeted carbon in other areas of the building. So if you go
With that also brings on to kind of the question that relates to how these targets are set, and is there, if there's a guide on how it should be broken down across the building, but what's most important is that the overall addresses it. And do you think that the targets, this is going to be a question to you, Left-Terrace, and Paul, in a way, that should we have these targets and they're set, does that prescription give you the flexibility to spend the carbon where we want, or do you think there are benefits to having it set per area of the building?
I've got a view on that.
Go on then.
Go on then.
I mean, the targets are really challenging, and sometimes you're given a target blanket, and you might have a tall building. We talked earlier about how the facade is 30%, and we're talking here about 16%, and what is right number. And I know there's a big piece at the moment going on with the UK net zero building standard to try to get a level playing field over what is the right number. I think the key thing here is that if you don't measure, you don't know. Once you measure, it's a bit like the thermal bridge one this morning. If you identify which are the high thermal bridges, you can challenge it. If you identify the high embodied carbon aspects and look at it from a whole life cycle perspective, you can then focus on, well, should I change the building services strategy, the air tightness, the fabric U value, the G value? You can start playing around with what has a big impact over the whole life. So this facade has got lots of reasons why it is from an aesthetic, an architectural, but I don't know, how do you feel?
No, I think on that building we've been lucky. Most building targets we get in terms of embodied carbon for the facade are very, very low. Everybody focuses on the Letty guidance, that we don't know exactly on what building this guidance comes from. On that building we have an excellent form factor, I think 0.33, as good as it gets pretty much. And then we have
close to a cube.
Yeah, and we have as a decent embodied carbon budget for the facade. And even if we didn't meet, even originally I think the target was 20%, we hit 25%. But that's what we can do with the unit curtain walling, with aluminium, that's what we can do with terracotta. If we don't have that budget, we will end up with more boring facades. So you won't end up with a unique building. So people need to keep that into perspective. I'm working in a lot of projects where
That's
the target...
a really important point, is that if we just push the facade design only down the route of carbon, then there will become very few solutions that will work low enough. Exactly. And a building has to be of its place and has to have a presence to it. It has to be loved and used to be able to be adapted to last for a long time, or else it will only have a building life of 60 years. And that's really critical, that we build buildings that are going to last into the future.
No, 100%. And that's important. We need to focus, as Paul said, to the parts of the buildings that we can get easy wins, reduce the embodied carbon a lot, and not focus on, I don't know, like removing a bit of material here and a bit of material there, and make marginal gains over the whole building.
We did take a couple of early decisions that I think were important, which we might not have done a few years ago. So one of them was around the structural grid. So typically at Paradise, our buildings are 9 by 9 structural grids, which is what you might 5 years ago have expected an occupier expectation to be. You know, it's very good for planning layouts. It gives you relatively clear open spans on floor plates in a concrete frame. We, with the advice from Cundall, to be fair, at the time, decided that 7.5 metre grids would be appropriate for 3 Chamberlain Square. So that's a new one for us. It will have a slightly different look and feel to it. We tested it with the occupier market and through our agents, and it was all felt to be an acceptable and wise choice. And it's helped us achieve, I can't remember the quantification of it, but much thinner columns, much thinner floor slabs and lighter columns. And when you put some GGBS replacement into the concrete mix as well, we've got about as lean a concrete frame, I think, as you could probably do for a building like that. Yeah. There's also things like recycled raised access floors and so on, which we've considered, which all, you know, it's all part of a mix. But I think that flexibility on the embodied carbon build-up has been pretty critical, rather than being too prescriptive over the facade's got to be this number and the frame's got to be this number.
Yeah, because I think it shows kind of over the different design stages. So on the graph that we had on the previous slide, it kind of shows, as we've gone through stage 2, stage 3, stage 4, you can see that the frame, where we have focused on those areas, has come down, but the facade has increased. But I suppose over those design stages, the facade designs become more developed. We're more aware of all the different material quantities that we have in there. We've got more specific EPDs that we've been able to review on. And kind of, as we put there, that there is opportunity for us to reduce the embodied carbon within the facade by 58 kilograms a metre squared. We have that opportunity by using low carbon aluminium, so we do have scale in there to further reduce the impact of the facade.
It's worth also saying, actually, just on the choice of terracotta, that I mentioned the historic location of the building. We have a design code from our outline planning consent back in 2012, which has quite prescriptive requirements for what 3 Chamberlain Square, or Plot F as it is, should be on that site. So the terracotta choice goes way back to the former Joseph Chamberlain building that was on the site there before. The use of terracotta in this kind of Colmore District Conservation Area was very much behind the decisions that Aline and the team came to with terracotta, and it was a kind of natural choice for us in that design competition. We had 1 or 2 slightly more radical approaches in the design competition, but they weren't right for that plot. And the conversations with Historic England and the other consultees through the planning process, I think, justified that decision, because it's being given so much scrutiny in terms of that facade choice, that our ability to do something far outside of that design code, I think, would never have really been acceptable to the city, and rightly so.
Javier, your team joined us, and kind of following on from some of the things that Nick said, addressing embodied carbon and addressing carbon in the facade and your systems was something that was newer to you, but do you want to say a couple of words on how you as a company have addressed this, and in relation to this project, how it's brought you forward in your understanding?
Yes, in fact, this is one of the first project we received with high standard specifications in the products about sustainability and environmental. But we've been dealing with environmental management since 2009, when we certified our management system following the ISO 14000 and EMAS standards. Then in, I think it was 2020, we became signatory of the UN Global Compact. So we set our objectives for 2030. And among those objectives, there are sustainability and environmental objectives, which are followed yearly, because we have to issue a document following all these objectives. Then we measure our carbon footprint following a Spanish standard approved by the government. So we know the carbon impact of Inasus. We were to reduce it through, for instance, these low carbon products, but also to compensate because there are certain impact impossible to reduce. So we compensate, for instance, with an agreement with a local forest community, trying to produce oxygen to compensate this CO2. So with all this background we have dealing with environmental management, we got involved in an early stage of the project that is great also, and we were able to produce an EPD for the system even during tender stage. So you can know the impact of of this whole system, and we also are able to deal with all the supply chain and to translate all these objectives through the supply chain. And for us, the most important thing about this is that we want to be sure to go through the correct steps, because it's very easy to fall into these low carbon issues as a marketing tool, and it's the worst thing for the environmental finally, no? So we want to go through these small but sustained steps in order to avoid the greenwashing that we can really see in the market.
So we've not got too much more time left. I'm going to ask a couple of questions. Alex, how important do you think the environmental criteria of the buildings for offices are going to become in the future? And what direction do you think the industry is moving in?
I think it's inevitable that they will be top of, if not almost top of the list of criteria, both from we work for Federated Hermes, who are the investors behind the BT pension scheme, and the conversation as an investor is all around stranded assets, and the buildings that we have custody of, we will own for 60 plus years. And we have a portfolio in Hermes which ranges from kind of 1970s offices to the buildings we've delivered so far at Paradise and what we're planning to deliver elsewhere as well. And I think that we see there being a kind of a two-tier market almost, with these best-in-class buildings will retain and increase their value over time, whereas if you're not delivering to the kind of level of specification that we're aspiring to here, then I think you really risk assets becoming stranded over time. And then from an occupier perspective, I mean, you know, the requests for proposals that we have from our occupiers, generally speaking, the first question or the first few questions on the list are all relating to what we're achieving in terms of amenity, sustainability, circular economy, flexibility and adaptability. So people aren't looking for, you know, 1 in 8 kind of occupancy anymore. They want external space. They want to be able to persuade their people to come to offices that offer really healthy and sustainable workplaces. And I think that we wouldn't be, I mean, we're already talking to an occupier on 3 Chamberlain Square, thankfully, and I'm fairly sure we wouldn't be in that position if it wasn't for what we're promising and confident that we will achieve in terms of the particularly the sustainability goals for the building.
I think I suppose there are questions in terms of how the facade industry should aspects that it should be addressing further down the line to improve sustainability. And I suppose I'm going to ask a panel what they think should change in the industry and where we should be heading. I'm going to start with I think that we should have better ways to reuse materials as they come off a building with a minimal reprocessing before it can be reused again. So that might be terracotta that comes off an old building. How can it be reused and hung onto a new building with only a minimal amount of reworking rather than crushing it down to completely recycle it? Or even if stone comes off a building, how it might be cut into bricks to reuse rather than having to take something down and painstakingly record where everything is. How can it be reused with minimal amount of reworking. I'm going to start with a question to you, Lieutenant.
So I think, continuing from what you said, it all starts with the building we're designing now. So it has to be made dismantleable, easy to dismantle, easy to reuse, and it's not always the case. So maybe engineers in the future are more clever than us, and they have find better ways of reusing materials. What we find is it's easier to reuse bricks, stone, and this kind of modules that can be cut or be reused as a shape. It's very difficult to reuse aluminum mullions, which are project-specific in most cases, glass, which is, again, certain sizes. This becomes very, very difficult. So I think we need to have the new buildings. We need to know what materials are on the new buildings. So we need all these kind of material passports, digital twin, and whatnot, to be able so people in the future know exactly what materials are there. And then whatever we can reuse, we should reuse. Whatever we can recycle, we should recycle. And hopefully technology will help on that as well.
Paul, do you have any?
Well, we talk about high-performance facades and the future and them being more challenging. And challenging can be switched around to more exciting as well, because I think the tools that we've got now, we didn't have going back a few years, can do these simulations quite quickly, more efficiently. And even if the data isn't 100% accurate, it can be used to compare different cases and different options. So we've got tools called pollination, which can do thermal comfort, energy, and daylight analysis quite quickly, taking in early stage models. We can play around with these tools to really find out what is a good holistic approach early on and carry on developing it with the supply chain. There's lots of exciting things I feel happening using the PHPP tool, the Passive House Planning Package tool, for certain types of buildings can be a really good, simple tool to use. And again, making sure those facades perform as well as they can do from a health and well-being perspective, as well as from an operational energy, embodied carbon, circular economy, dismantle. So lots of exciting things to do.
Nick, you've got a minute.
Yeah, so I think the biggest thing is it's kind of missing at the moment. I know Aneel was mentioning earlier, there's lots of different regs out there. I think in terms of a body carbon point of view, there is no legislation out there from the government at the moment. It's all best practice within industry. Industry is leading at the moment, so there's no real between, especially working with a main contractor, you're going between different developments of different clients, different consultants teams. It's always kind of different approaches. So I think until you get like a consistent approach in between of set targets of, right, this is what you need to do, and kind of drive and a real, so it's not really a best practice kind of nice to have situation. It's you need to, by law, to do things, or by legislation to lead this. Until that happens,
you want more of a stick.
Yeah, I think
there is a balance, isn't there, kind of between setting legislation and prescribing values versus flexibility to use your carbon wisely across the whole building. We're almost out of time. Alex, do you want a final say on anything?
I mean, you were going to ask, I think, what we've all enjoyed about the process so far. And I kind of, I suppose for me, as I said at the beginning, I'm not the expert in the room here, but what's been really refreshing is when we started the process and elevated sustainability from probably kind of fairly low on the design team agenda to probably top of the list, and seeing the team that we've worked with kind of really embrace that brief. There are one or two people, more than one or two, the whole team has responded to it, but there are some real kind of stellar individuals who've come through on 3 Chamberlain Square and taught me stuff that I didn't think I would learn in my career, and just seeing it kind of brought to life or will be brought to life and realise that vision, I think is something I'm really
the collaboration has been very refreshing, and it's actually really lovely to have representatives from all of our teams involved in making this happen. So thank you, panel.
Thank you very much, everybody, especially the people that stepped in last minute. Lefteris, Javier, thank you. Really great discussion and a wonderful building, absolutely wonderful looking building. We'll look forward to it appearing on site very soon. And thank you, Alina, for moderating.
Thank you.
Today. Please stay where you are, because I think you're about to get some mementos. I just want to sign off by saying thank you all for staying. It's been an absolutely wonderful day. First event in Birmingham, and I think it won't be the last. It's clear that there's a lot of really useful content that we all got out of today. Amazing presentations, amazing discussions. Thanks again for everybody. Thank you to the Zak team, who again have laid on a meticulously organized event. And enjoy your evening. Thank you.
Thank you.
Thank you. A round of applause for Stephen, as always. Excellent job. Thank you so much. Right. So we have drinks sponsored by Obex. Would request all of you to please join us for that. Thank you all for attending today's event. We've recorded today's event, so you'll get a copy of the presentation, the recording of the event via YouTube link next week, next Wednesday or Thursday. And we look forward to hosting you next time around. And not to forget, a big one in London on the 8th of November at the Hilton on Park Lane. Thank you all.